Buenos días, tengan todos ustedes, la Agencia Espacial Mexicana y los colegas que nos están viendo a través de la sesión Teams de manera remota, a nombre de la Agencia de Entrenamiento de Software Skydel de Orolia, que nos va a proporcionar de la empresa Orolia a través del señor Richard Brook, que vino especialmente a México a dar este entrenamiento a 5 instituciones de educación superior mexicanas y personal de la. Vamos a hacer una pequeña ceremonia de inauguración. Le voy a dar la palabra al señor Brook, Robert, para que nos explique el alcance de este curso. Adelante.
So good morning, buenos dias. My sincere apologies that my Spanish is terrible. I can speak English and a little bit of German, but my Spanish is terrible. So the training today will be in English, but I'll do my best to work through it. But I'm very excited to have everybody. Okay? Is it okay?
Yeah, go ahead.
Okay, but I'm really excited to be working with all of you today. This is the first program in Latin America. We've launched this software in many countries, and we have about 30 universities right now using this. But the good news is Argentina is right behind you, so we've been working with CONAI in Argentina. So I think this is a program that will launch. The training today is going to be very informal, but it will be a little bit complicated because we have people remote and people that are here. And I know some of you may have had a little bit of struggle loading the software. This is normal. And I'll explain all the details of that as we go through it. But the goal is to actually go through the Skydel software and give you a strong understanding of how to use it. And more importantly, show you how to learn more on your own because there are a lot of tools and resources. But we're very excited about this partnership with the Mexican Space Agency, and I see great things for Mexico as it leads the way in Latin America.
Thank you, Robert. Dr. Landero nos va a dirigir.
Thank you, Robert. Thank you for being here today. And good morning, everyone. Welcome to all universities and institutions that are going to be in this project. It's a very important project because the trends in satellite telecommunication and navigation are very important, and new technologies are emerging, and we cannot be outside of this game. So the opportunity to develop new technologies, new hardwares, new networks are very strong with this software. So thanks to Orolia to have this donation to the institution, to this donation to ours, the institution, and as well as the Mexican Space Agency. This software is very powerful, and you are going to see. And thanks again to Orolia for this donation, and thanks to Robert for this seminar. I am sure that it's going to be a success, even that some problems could be happen, but as Robert said, that is normal when you have a hybrid course, something happens always. So thank you very much, Robert, and thank you to Orolia, and congratulations to all of you for participating in this seminar. Good luck.
There you go.
The picture for
I'm smiling under.
Okay.
Perfect. So maybe 2 minutes to everybody on the internet before we get started.
Yeah.
Is that okay?
Yeah. Me pasas una pastillita de estas porque yo no tomé la mía. No.
So I think we'll leave the camera off if everybody's okay with that, and we'll just go with the software. So to everybody on the web connection, can you see my screen that says agenda?
Yes.
Perfect, good. Okay, so I want to talk about a little bit about what I want to cover today, but I also want to explain to everybody that I can be flexible and adjust with this. The goal is to make sure that everybody understands the basics of the software. So what I plan on doing today is, like we talked about, we'll do a little bit with introductions. I am going to review the Orolia Academic Partnership Program very, very briefly. I know some of you have seen this, but I think it's important to explain it one last time now that it is more formalized. And then we're going to spend some time doing introduction to the software, or to Skydel. The goal on this is to make sure you understand the advantages and the capabilities. We will definitely get into the software and have you going many demonstrations and usage today, but I think you need to understand the power. I do want to say one thing very, very formal up front. Be careful with this software. It is near perfect GPS. So I say that respectfully, asking you to please remember, you connect it directly to a receiver or inside a chamber. Do not modulate this if you have a software-defined radio into the open air, because probably you will get arrested and go to jail, because it can also do spoofing and jamming and things. So keep in mind, you have a very powerful engine, but especially at the universities, if you authorize students to use this, you might want to keep that capability separate so that they don't modulate, they just use it on the computer, okay? But it is near perfect GPS, GNSS. If you modulate this in this open air at high power, whatever your test is saying, the people on the street are gonna see that. So if you're making a test in Hamburg, Germany, and the people downstairs in the street are using GPS, their phone might say, Hamburg, Germany. Okay, is that good? All right, we'll talk through this installation configurations. A lot of you have installed the software, thank you. A lot of you installed the software late last night or early this morning, thank you, but we'll make it work, no problem. The goal is to make sure you get used to this. As we go through talking about this, I will explain the type of computers, the capabilities, but also about GPUs. Some of you probably, if not most of you, probably don't have GPUs. That's okay right now. The software still works. You just can't necessarily do what's called real time, and I'll explain that to everybody. We're going to walk through making basic test scenarios. If we have plenty of time today, you're going to set up scenarios for static locations, meaning no movement, which is very common in telecom networks or 5G networks. You're going to set that up and be able to transmit that. We're going to do an automotive application to show you how to map, maybe from Puebla to Mexico City, and we're going to put it in jammer and interfere in there so you see that you have the capability of not just creating GNSS, but other signals. With that, we're going to talk about what's called plugins. This product will interface with IMUs, sensors, gyros, any type of device that handles motion, even on your phone. So for example, Apple and Samsung are our customers. So if you guys are runners or exercise people and you go running, then we use our device to test to make sure that that's possible. We'll spend a little bit of time on interference and jamming. We will not be doing spoofing today. I'll show you some videos and show you how, but that's part of more of our advanced training. And then we'll talk about connecting a receiver. I do not have a receiver with me, but I have an online demonstration ready to show you this so you see live systems, not just the classroom. Lastly, we'll do automation and, of course, the summary and the next steps. This is a lot of material to cover, and if you think about what we talked about at the beginning, this is really what we call our level 1 and level 2 training combined. I thought it was better to come to Mexico and do this in person and try to get you guys started versus doing a bunch of different web sessions. So this is a full 6-hour day. Lunch is provided for those of you guys that are here somewhere around 12:30, Yvonne? Yeah, around 12:30 we'll have lunch brought in. But we're going to cover what's called level 1 and level 2. And for those of you that are at the university level, we actually have a lot of this in our student workshops. So part of what we do, we've done this now for about 8 universities, is if you're going to integrate this into your curriculum, we have no problem doing the first workshop for them. We've done all of these remote because of COVID, obviously. But if I get plenty of notification and maybe we could do 2 or 3 courses at the same time or universities, I have no problem coming down. I love coming to Mexico. It's my third favorite country, I'm sorry. US and my daughter's in Germany, so I love beer and I love Germany, so that's my second. But you're my third, all right? By the way, I like to have a little bit of fun. Is that okay? Good, all right. If someone wants to continue, we do offer certifications, but for that, we like people to come to our location in either Montreal or Rochester, and that's several days of very intense, very focused training where you actually have a lot of live systems and scenarios. But if you're curious about what we're covering, that's everything about the agenda. So any questions on that? Is that okay? You're all excited, aren't you?
Yes, one comment. 1:30.
1:30 lunchtime? Okay, so Mexican lunch, not American lunch. No problem. It's okay. All right, so let's do a quick review of Orolia and the OF program. If you're not familiar with Orolia, or if you did not see the first presentation, Orolia only does resilient positioning, navigation, and timing. That's it. We don't do a bunch of Ethernet or fiber optics. Our goal is to be very focused in this area. We can fix that. Is there now? Thank you for telling me that. I thought it was projecting. One moment, please. He will do it now. I wasn't saying.
Creo que ya. Ya se ve, ¿no? Ya.
Yeah. Good. All right. Sorry about that. I forgot to share it after the camera was on. Like I was saying, Orolia only does resilient positioning, navigation, and timing. But we do many products in this. The first one is this resilience aspect. So we do everything from protect the military to government with all kinds of anti-jam antennas, all kinds of devices. So that if there's a live mission for the military, or if it's a bank protecting its data, we actually have many ways of protecting all of that signal. And the reason for that is because that's your timing for your network. We actually have that. That's our biggest product portfolio. But we also do a lot of protection of lives. The airplane that I flew to Mexico on had an emergency beacon on it. That's provided for by Orolia. So it's Embraer, it's Airbus, it's American Airlines, it's a lot of the commercial airlines. If an airplane crashes, we actually have equipment on that plane to find it quickly, whether it's at sea or whatever. So a lot of those. Every kind of navigation. You're going to see today me talking about drones, drone swarms, satellites, spaceships, cars, boats, a little bit of everything, smartphones. Anything that has navigation to it, we can fully test, qualify, and protect. That's everything. And last but not least is timing. Most people don't know it, but if you take the Galileo satellites, our clocks are inside the satellites. So we're initiating that original stuff through our clocking signals. So that's your basics on Orolia. I don't want it to be a big commercial, but I wanted everyone to see that. So, OAP. This is a program we started about 1 year ago. And we started this very quietly because we wanted to do something different. We wanted to get a lot of universities involved first before we told a lot of people. And the reason for that is we believe the future of testing isn't forcing someone to buy a large system. I've sold systems for my competitor for years for $1 million, $2 million. That's a big investment. And everything about some of those systems is proprietary. So it is our belief that you build a community with the software that you can customize. So yeah, we provide all of the technology for GPS and positioning, navigation, and timing. But if you want to do something specific, like integrate it with your equipment, you share that information or ask other universities if they've done it before. So we'll talk a lot about the online community. If you haven't seen it or looked at it, it is actually starting to get very, very robust. We've added a lot of data. Universities are starting to add information to it also. So the goal is it's not just you. Universities ask each other questions. They get information or resources from each other, and they share things that they do. So for example, I can build a custom signal in the software. So maybe there's a low Earth orbit type technology that you want to test or try before you put a satellite in the air. You build it in the software and then go from there. Welcome, good to see us. Join us. Thank you. What we've done with that is I came to the Mexican Space Agency and asked for sponsorship. I wanted to know that we all work together instead of actually giving it to each university individually. And that helped us to really build this program. And the goal in Mexico is simple. I want to focus on Mexico, Mexico problems, anything that's in the region, research for the region. Whether that's smart buses or transportation, whether it's network timing for banks, whether it's the problem we're having where people are stealing trucks in Mexico. These are problems we can solve together if we work on it because you have the technology to simulate it and test it now. But I think that partnership is very important, in my opinion. And like I said, you're the very first in Latin America, and a lot of that is based on my experience here. I came here maybe 20 times in the past with my other companies, and had actually been in this room before with another company, so very excited about it. All right. What you get, and I think I've explained this, so this will be very, very fast. Each organization will get a permanent license for Skydel. I will give the license, it's about $300,000 value. That has all frequencies, all constellations, spoofing, jamming, everything. This is a permanent license with no fees, no additional cost. It belongs to the universities and the Mexican Space Agency. If someone were to buy this, it is about $300,000. This license belongs to the university or the Mexican Space Agency. But if you want, students are allowed to have licenses under the authority of the university. So if you have a PhD student working on a project, we can give them a temporary license up to 1 year. It is not permanent. After 1 year or 6 months or whatever time we agree on, that license will go away for very obvious reasons. All of this is possible without buying a thing. Legally, in our country, we're actually a French company, but my headquarters is in Rochester, New York. In both regions, We classify this as a donation. We are not allowed to charge you for a shop. So everything you get is not chargeable. If you want to purchase our hardware in the future, which actually modulates the RF signal, no problem. We give that to you at a discounted rate. But you'll see you are allowed to build your own system. We are very proud of the fact that we don't have proprietary systems. Everything that we do, we tell you. We use commercial software-defined radios. We use commercial GPUs, and it runs on a commercial computer. So you can build your own if you want, probably for about the same price, but this is not a goal to sell. Our feeling is if we get education research started, then commercial customers will buy from us in the future because you represent it for us. So it's a good partnership for us overall. So any questions on that? Does that make sense? I brought 3 masks because I've never presented with the mask, so we're going to swap. See if that's better. Any comments, questions, or anything on that? I think almost everybody that has downloaded a license right now, you still have a temporary license. I think it was for like 3 months or 6 months. So you still have that temporary license. What we're looking for at the end, you'll see, is I want to sit down with each university and just understand the plan. When will you integrate it in the curriculum? And it doesn't have to be immediately. It takes time. If that's 6 months from now, fine. What programs will you use it on? And 2, we like to make sure we keep up communication for all of that. But those are all temporary licenses because I think it's only fair that you try it, you use it, you learn it to understand the full capabilities. Okay, why? This is like 30 seconds. It's good for us, it's good for you. The end. It's marketing, it's use, it's promotion. And I also learned a long time ago, I may be a crazy gringo from the US, but in Latin America, I think relationships are important. So we build trust between us and between you and me and the companies, and then business comes later, versus trying to get money right from the beginning. All right? That's my joke. Is that okay to have said that? Okay. Normally I smile when I say that, but you can't see it. So details of the partnership. Again, this is a quick review. All the stuff that we talked about, you guys have already been provided a licensed capability. Some of you have it, some of you struggled a little bit, and we'll explain that. Most of the times when you actually had trouble, it was your computer, or maybe you missed a step in the getting started guide, but we'll get through that, it's not a problem. I'm gonna give you guys all information today to the community. You're gonna set up an account, and any questions you have day or night, you can type it into the forum. If you need questions answered, search first, because there's hundreds of questions already in there. If you want to do very detailed testing, we have about 15 or 20 advanced documents in there. We have plugins, which allows you to customize your signal. So this is where we're going, and honestly, we want you to use the forum whenever possible, because we want data to build up in there. We want information to build up there so it's useful for everybody. So we'll talk about that. Initial training is today, and of course, if you guys want to publish white papers, anything else, you have full permission to use Skydel in anything that you publish, anything that you put out there, any research, any PhD projects or whatever. If you do log in the forum, you're going to start seeing that universities have already done that. The University of Stuttgart just published 2 white papers using Skydel, and the ION conference, it comes up in the fall. There's already, I think, 9 papers proposed that are using Skydel. All right, so that's all the basics. Any questions? I think that's a review for many of you, but I wanted to make sure I touched on that up front just in case somebody did not see the very first training. Okay, let's talk a little bit about a couple things, and I'm going to sit down for this, change to my browser. Did the online change the presentation? Still in the presentation.
Okay.
Okay. So all of you now should see the Orolia page. If you're curious about other programs and other people that are in this, on the Orolia webpage, it's orolia.com if you want to go there, /OAP, Orolia Academic Partnership Program. It gives you information on the account, If you're curious about who's in the program, there's a list of current members that comes up, but also as we add these, we don't have all of them added up top. You can look at all the different regions on where we are. So you notice we just add University of La Plata in Argentina. We've got AEM, and what I'd like to do is over the next couple of weeks as the universities get rolling, to make sure that we add you to this. But if you want to know who's in this, it's a lot of universities in the US. It's a lot of organizations across Canada, every major university in Canada. It's Fraunhofer in Germany, bunch of different ones there. You can scroll through them. Ohio State, Oregon State, Osmedia University in India, Queens is in England, Canada, Stanford, UNB is in Canada. There's 2 universities we just added in Spain, which I think some of you might work with. There they are. So there's quite a bit of ones out there. There's actually 3, I think. No, there's 2, Juan Carlos. So there's a lot of different universities that are actually being added overall. I'll probably add 2 or 3 in the next couple of weeks. I do want you all to watch for an announcement. The program formally gets announced this week, and there'll be a webinar about all the future events on December 13th. I think it is. So if you guys want to actually attend that webinar, you actually learn a lot about what we're doing. And I'll give you a quick couple of examples. We are now developing material for your curriculum. So if you're actually at a university and you're teaching a course or you want someone to learn the product, there's going to be step-by-step labs where the professor can go in and just change like the position of the application, and the students can use it to learn and grow. 2, we're going to actually start doing a monthly newsletter where we feature a university and some of the projects they're working on so people get an understanding and have kind of calls every so often. But 3rd, we're finally almost ready to launch our competitions. So probably in the spring or the fall of 2022, or maybe both, we're going to have competitions where students can compete with each other. So there'll be things where we set up competitions where they can actually have things and they develop stuff and they can submit it. And we're going to give them nice awards like trips to trade shows or scholarships and things like that. Lastly, the middle or late next year, we're going to set up a job board on it because there's a lot of university students that are leaving with GNSS education, and there's a lot of companies needing that expertise. The companies tell us all the time they can't find it. So I think the bridge between companies like Qualcomm or Samsung or Trimble and Novatel and all these big organizations, students can then start to put their resumes out there and post jobs, or commercial companies can post jobs. So that way it starts to build a bridge between education, research, and commercial also. So we'll see how it goes, but that's the plans for the future itself. Lastly, and I want everybody, if you have your computer, to go ahead and go here and log this up. I want you to log in to learn.orolia.com if you have a computer right now. If you don't have a computer, just look for someone's shoulder or take a look at theirs. So this is the online forum that I'm talking about. You can set up an account, and there's nothing tracked as far as any privacy or anything, but you can set up an account in there pretty easily. But the goal of this is actually be a place where everybody can share information. So if you look at the system itself, there are a lot of things in here where people have asked questions, and a lot of them are still Orolia people. We actually put a lot of questions on here. But there's a couple things to notice. If you're actually trying to get information, we actually have down near the bottom application notes. If you want to do detailed training, click on application notes. And there's a lot of white papers and application notes that are being submitted. And not all of these are submitted by Orolia. There's actually a couple on here. Let me see if I can find one. This one here, this one came from one of the universities. So if you guys want to post something This originally came from Top Dad, who actually works at University of Stuttgart. But he actually published that they actually have a manual on how to set up an HTML interface for this. And this goes to your website if you publish it. It's not our advertising, it's yours. So you notice it goes straight to something that the University of Stuttgart's already done that will help you out versus actually us doing it all the time. So again, building that community is really, really important. All right, and last but not least, I'll go back one more. We're publishing more and more videos. So some of you may have looked at some of these videos, but they're now on the site. Let me go back to the home page. Again, scroll down the left side. You should see something that says informational videos. I will show you some of these videos probably today. But if you ever want to figure out how did Rob do that or how do I run through this, everything that you want to think about from an application-wise, automation, general tutorials, there's more and more videos being published. Which does remind me, by the way, if you want the presentation that I'm using today, in the chat window, you should see the link to download that presentation because it's actually very useful too. Because you'll see later on, there's a lot of step-by-step information on how to set up tests. Because we all know how it works. You go to a training course and it's easy, and you go back to your office and you have a beer or two and you forget everything that you learned. So those are good refreshers. That happens to me at least. But if you don't have an account set up, you might want to go ahead and set it up. Like I said, there's no information. I think it's just a username and password. That way you can log in at any time and be able to see that information and be able to have access to it. All right, any questions on the general information? Like I said, there's a little exercise I have on the screen. If you forget to do this or you want to do it later, that shows you how to log into the learning portal. Basically shows you how to set it up. And again, anytime you have a question or information, please feel free to just post it there 24/7. It's there for you. Good? Okay, everybody online, is this going okay for you?
Question about information.
Any questions come online or anything? If there's any questions, you can also type them in the chat window. We're monitoring that, and if I need to slow down or speed up, please let me know. I usually do pretty good, but this mask is driving me crazy if I'm honest, so it's okay. All right, so let's talk about what we're doing here. So when I say that we're simulating all aspects of GNSS, I want to make sure I explain that a little bit because we will not cover everything in 6 hours. There's some capabilities that we definitely cannot get into. But basically what we do is from the satellite itself, clear down to the device that's using GPS, GNSS, Galileo, Beidou, any of the technologies. We have full control of almost everything in between. So if you want to actually make a test last week, you enter the date and time, and we move the satellites where they were last week. If you want to test next year on April 16th, you type in the date and time, we move the satellites to where they are on April 16th, and the data that's transmitted from the satellite matches that. So it's not complicated technically. It's just taking the data that we know the pattern of the satellite, we know what the information is supposed to be. We actually program that. Whether it's GPS, Galileo, or whatever, you have then full control of everything. The signal itself, the messages inside the payload, you can actually go in and create intentional errors to see how your receiver responds. You actually have the capability to change the environment. The troposphere and the ionosphere. Some of you are probably familiar that certain parts of the world have something called scintillation. It's very common as you get close to the equator, which is a bubble in the actual atmosphere. So you have the capability to control different models for the atmosphere, change those atmospheres, and in almost everything we do, you can import your own models. There's no way that we're perfect and have everything, especially in the research area. So we always give you the capability to create your own models, your own information, and import it into the system. Then we start talking about multipath or echoes, signal strength, signal loss, errors, interference, all of that stuff that would happen while that signal's coming through, predominantly near the Earth. Most of that happens as it gets closer to the Earth, especially multipath in big cities. And then last but not least, what's the application? So you define that application, whether it's a static location, like I mentioned, like a 5G cell site that doesn't move, whether it's a sensor on a pipeline, that's an IoT smart sensor or smart valve, still static, it's not moving, but it's used. There's now smart fire hydrants, if you've seen these, they're really cool. The fire hydrant knows its location, and firemen can find it quite quickly, as well as know how much water and pressure are in there. Automotive, whether it's a car, whether it's a bus, boats and ships, you have that capability also. Drones, airplanes, rockets, satellites, any application that you want. We will be setting up these models today to get you familiar with them. I'll be honest with you, I think it's pretty easy. I will admit to you that I was not formally trained in GNSS. I went in the military and learned telecommunications, and I majored in computer science. I don't really always understand every specific aspect of GNSS, but I can go in and simulate almost anything because the GUI's been made to the point where you can do it pretty easily. All right? If you get to something detailed, like you want to change an antenna pattern to make different antenna models, there's typically information in Skydel that tell you what to do. Or if you add a radio, it gives you literally a diagram of the radio that you're adding. So overall, we do everything we can to do that, but I want to make sure we do that and explain that. Last but not least, you can build your own custom signals. I mentioned that earlier, that's very unique to us. And you can also do what's called plugins. So if you want to talk to an IMU or a LiDAR unit and actually compare the information from that coming to system, you can build your own plugin. So someone always says, oh, you don't do this or you don't do that. We give you the ability to build it, because if we start building everything, then they want to charge you for it, which raises the price. Then it takes longer to build it, and you're never going to build it perfect for everybody. So our thought process is to open the code up. You want to do something specific, you're never going to be able to mess with the core code, obviously, but you can go in and change your own signals, change your own plugins and make your own options, or import models to make it the way you want. So again, quite powerful overall, and you should have all of these licenses, and we'll check them in a couple of minutes to make sure you have those licenses. Any question on simulation? I know a lot of you know this stuff, but I want everybody on the same page. When we say test and simulation, again, near perfect signal. And yes, it will generate interference, it will generate jamming, and it will generate spoofing. So a lot of what people like to test sometimes, especially in automotive, is can I spoof a signal?
What about the augmentation technology?
Which one?
What about the technology, augmentation technology?
Yeah, so we do SBAS, space-based augmentation systems. We do all the RTK technologies. What am I missing here? QZSS, we do ERNs, we do all the regional technologies, but we want to check your licenses in a little while to make sure you have those. So what happens when you download the licenses, if you didn't check all the boxes, you might not have the license. There will be a couple of licenses you will not get. You will not get encrypted signals because it's controlled by the military. Right now, you will not get the PRS signals that we're developing for Galileo because they're not published in an ICD yet. So there's a few things that you can't get. Normally the secret codes, the classified codes. We're willing to give it to you if you get permissions from the government.
We said someone from Puebla telling that it's excellent for research work at graduate level. It's very clear we should not modulate outside the experimental chamber.
Yes, sir. Very much. Very important.
So they're getting it.
Yeah, they're getting it. So good. So I'm not talking too fast or crazy then, and the mask not changing it. All right. Wonderful. Thank you. Okay. So let's talk about the engine itself. These are more of the technical specifics of it. So this is built to work off of software-based systems. So I worked for a competitor for years where it was hardware, FPGA-based type systems. The software that we give you will load on almost any computer, but you're going to find, as I explain it in a little while, if you have a computer without a GPU, then there's some things you can't do. If you have an older computer, you might not be able to do anything except send it to file. The software is friendly to install, but limited on capabilities if you have older equipment. And you'll learn this today because I'm going to walk through it so you guys can see all of that. That's not so important, I don't think, for the professors or the doctors or the senior people, but with students, you got to think about that a little bit. And many universities just have a system set up that they let students use versus them putting it on the computer because of that, because they can't force a student to buy a GPU or whatever. Easy to configure, like I said, I learned it pretty quickly. All major constellations and frequencies, we are adding a few of the new ones, but GPS, GLONASS, Galileo, Beidou, all the ones that we mentioned, all the augmentation technologies, all the regional technologies like ERNS we support. And you should have these and we'll verify it. This is pretty important. A lot of times you want this to work with other systems. So whether you want to automate this to Python, C# or C++, you have that ability. But also, we have something very unique that I like. I'm a little bit lazy. I admit it. I hate scripting and coding. We have what's called point and click coding. If you do something in the software, it saves those commands because we send the commands to this processor and to the system also. We make all commands visible to you, and you can edit them. So if you actually are in a hurry and you want to do 3 or 4 test scenarios, you do it visually in the software, then you export to Python, and you already have your base script done for you. That makes it a whole lot easier. The advanced signals that we talked about, you can customize or create very advanced scenarios. There's a couple of companies we can't mention, but one of them starts with space and ends with an X, that I can't say altogether. Almost every mission that they do, they're using us for all their missions, far advanced in everything that they do. So pretty complex stuff. That's from the launch to space. And there's different dynamics, as you guys know, during the launch versus once it gets in space. The antennas and everything are completely different. You can modify the variables in real time, so you don't have to stop the test. If you want to change the signal level while a test is running, there's sliders that allow you to change the signal level. Or if you want to drive through a tunnel, you can change all the signal or power levels together and move those back and forth. You can integrate the interface with no additional hardware. So it does have the ability, if you just want to use it for research purposes, you can send IQ data, RINEX data, NMEA data, all of that can be sent to a file. So even if you don't have hardware, you can generate those signals internally, send it to a spreadsheet or a CSV file, and that's what a lot of universities are using as students right now that are just learning. They want to send that information. They set up a scenario of whatever. You're in Puebla on April 16th, 2023. They set up all the patterns, they send that information, and then they log the data to file, and they ask them questions to learn about the technology. We will create IQ data, and if you don't know what IQ data is, that's the data that's sent to a receiver to modulate. So we actually allow you to transmit that, pull that IQ data out of the system, and you'll have that file or that capability. It has a very high rate of iteration rate, so it does very rapid things. You should also have access to an option called Advanced Dynamics. So you can actually do rockets, spaceships, everything moving very, very fast. You have that capability. And of course, you can record and send everything to Python that I talked about. So you can read up on the data sheet. You'll actually see all this stuff in action today. But this is not a second-rate simulator. I'll be honest with you guys. I worked for a company called Spirent for years, which has been known as the only simulator for many years. We're taking business away from Spirent like crazy because they're still very proprietary, very controlling, and very expensive. My wife liked it when I worked there for many years, but that's okay. Customers didn't. Here's what's unique, and this is what we'll talk about a lot today. You can load this on a computer, and you can use our hardware. Inside our hardware is the computer, the software-defined radios, the GPUs, ability to also connect clocks to it. It's basically what we call a turnkey. It's all-encompassing. Or you can build your own. but I'm going to explain this a lot today because you have to think about this. You need a decent computer. It's going to be a Windows or Linux computer, but it needs to be a strong computer, especially if you're doing 5 constellations, augmentation signals, multipath, interference, jamming simultaneously. That computer's working hard. All right. Inside that computer, you can have 1, 2, or more GPUs, graphics processing cards. That's not just to process the graphics, that processes the data. That's where we're quite different. We took the concept of gaming, anyone's kids or anybody in the room is a gamer. We took the concept of gaming because the GPU can process so much more rapidly. And you're going to see that as you set this up, you have the ability to test your GPU. So you see something very different from Orolia. We don't tell you you have 24 channels or 24 satellites. We don't tell you you have 48. We don't tell you you have a certain amount. It's called all in view. If you can see it, Skydel will process it. But the GPU, most GPUs will only process somewhere between 150 and 300 satellites. So if you're doing a very robust application, maybe you're doing it inside a chamber and you have 8 antennas, each one broadcasting differently, with 4 constellations, that becomes a very robust application. For that, you may need a 2nd or 3rd GPU to do that. But I'm going to show you guys how to test the GPU today, so you know my test is going to work. And we're going to give you either green, it's great, marginal, you're right on the border, or red, that it fails, so that way you always check on that. Okay? And last but not least, your software-defined radio, if you're going to modulate, you're going to transmit RF or connect it to a cable. We work with 3 brands, and those will be shown later on the presentation. It's Edis Research, National Instruments, or DECTech. We use the DECTech cards in all of our equipment because we find it's some of the highest quality. And DECTech's coming out with a card next year. I think April, they're launching the new card, which will double the capabilities. So you actually have multiple RFs on the card and up to possibly 500 or 600 signals. So the cool thing is, if you build your own or if you're using ours, you don't have to go back and spend a bunch of money to change it out. You get upgraded GPUs, drop them in if they grow. Get upgraded SDRs, drop them in if they go. So you grow over time versus having to purchase a very large system. And then you're locked into that and have to trade it in.
Can you mention some of the prices?
I will in a couple of minutes.
Okay.
Yeah. I think 3 or 4 slides from now I'll mention it. But I'll give you the basics. This product here goes from $20,000 US to about $80,000 US based on the number of GPUs. And I'll show you that it's actually bigger slides. The SDRs, they vary in value. I think you can get some of the basic SDRs for like $1,500 US. And then I don't know GPU prices, to be honest with you. But we'll go show you those later on. So any questions on that? So one of the things I'm going to ask the universities is kind of what your thinking is, whether you'll build your own or whatever. And it's not anything to do with sales. I don't get paid on sales. I get paid on this program. So it's not to do sales. I just want to make sure I understand what you guys are thinking. Each has benefits. This is going to be a little bit cheaper, but it's a lot of work to build your own system. This will be a little bit more expensive, but it comes, you put in a keyboard and a mouse and you go, and you're running. So each one's different.
I have one question.
For example, what about we know that the TR several times works fine using other operating systems like Linux. I don't know if for Orolia the software is also compatible with.
Yeah, it's with Windows 10 or above, or Linux and Ubuntu. There's Ubuntu systems that work with those. We're testing Mac right now, but it's not going so well. So for some reason, a lot of the code is stuff on Mac, but it will work on Linux and Windows. In fact, a lot of the universities are making Linux servers for the students to use. We run it on Linux because it seems to work better for us on Linux. So our product, this is actually running Linux out of the box. But good question. All right. So I think I talked about this, but I want to make sure I understand the flow, you guys. It's getting warm in here. You're over there fanning yourself? Yeah, it's getting warm. I'm full of hot air. That's why. But I want to explain this slide. And for those of you guys on the internet, I'm going to move from the left to right on that box. Skydel is the software. Remember I said Skydel will load on almost any computer. But it doesn't mean it's going to work. okay? Because you have to think about the actual PC. So the software there's there. So if you missed it, in the directions, it told you to look at your minimum PC requirements and desired PC requirements. They're two different things because you can still function on a minimum computer. You just can't do full real-time functionality. And we did that on purpose, by the way, because students and things do want to have it. Then you have your PC system. So like we said, a Linux or a Windows-based system. A modern computer, typically a gaming computer is what I have, and it works a whole lot better. That will then generate your IQ data to the SDR. And this is where we actually have the ability of porting that IQ data that we talked about out to file or whatever. And then your SDR is then converted to RF itself. There's a couple of the actual GPUs that we use that work really, really well. It's typically the ASUS and the NVIDIA GPUs, just because they seem to be able to process more. We get the question all the time, will this work with any GPU? Maybe.
Okay.
It works with a lot more GPUs than we had talked about, but GPUs are kind of like cars. There's cheap cars, there's nice cars. The cheaper the GPU, the less chance it's going to work, and the less channels or satellites it processes. It just can't keep up. So if you're building a system at the university or here at the Mexican Space Agency, we recommend sticking with these three. We tested them like crazy. We work with them a lot. We literally put them in our systems. Our defense systems, we actually put other cards in them too. But those are the ones that we recommend. But if you want to try others, you can. Our tech support tends to be a little flaky about helping you on a lot of times, if I'm being honest with you, just because we know that the results get marginal when you go to other ones. So I hope you guys are okay with that and understand that it's not that we're forcing you or we have any arrangements with these customers. We know these three work, so we highly recommend you stick with those. And I got that in a Dell computer when I ordered it, so it's pretty easy. And again, when you connect to your receiver or your device under test, this is either a conducted or cabled test, so you connect directly to the antenna itself with a coax cable, or you actually do this in some type of chamber. If it's a small chamber for a phone, that's okay. If it's a large chamber for an airplane, that's okay, all right? So hopefully that helped to clarify that a little bit. And this will explain to you when we start using the software in a little while, some of you will see different things based on your computer, and I'll explain it each time. 3 modes, I've pretty much covered these, but the software is powerful by itself. So you can send information to files. You can send information to a receiver. You can generate IQ data. So the software is powerful by itself. You add a GPU to it, it's very powerful. You put either a software-defined radio or Orolia's hardware on top of that, then you can modulate it. So it's kind of like build the system as you want. And most of the directions are in the guides that help you on this as you go through that. So I think I've covered all of those earlier. I do want to spend a couple minutes on this, and I apologize because it is maybe hard to see on your computer. But as of the last code drop that we put out, I think these are all the options that you get. So there's all of your constellations, and I'll double check this because I didn't check it recently. So there's all your GPS, L1, L2, L5, L1C, GLONASS, G1, G2, Galileo, E1, E5, all the PRS. We have been selected to develop the new encrypted signal for Galileo. Spire used to be the one that did that, but they're part of the UK and they left Europe with Brexit, so now no one wants to work with them. So we get all this contract since we're core companies in France. All the Beidou signals, the Beidou signals can be a little bit tricky because there's B1, B2, B, all this stuff. So we are working on a couple of other Beidou signals. When an ICD is published, we try to get it out fairly quickly. All your QZSS, all your NAVIG, all your SBS, SBES. Some of the SBES stuff, I think we do L2 and L5, if I remember right, but not, I'm sorry, L1 and L5, but not L2. But there's a very, very detailed chart, and we'll see it in your software in a couple minutes. I'll talk about multi-instance. I am enabling 2 instances of software in your license. What that means is you can start the software 2 times. So if you're testing an airplane that has an antenna on each wing, you can take and actually have 2 separate tests running each antenna with slightly different parameters because the airplane's moving. We ran up to like 16 plus instances for drone swarms. So you guys may need some other instances in the future. Give us a yell, let's talk through a little bit and understand the application. But keep in mind, this is not launch the software and run. You can actually launch the software multiple times. And the most common application is RTK. If you know RTK, you've got a base station and a rover for agriculture or for survey. And you might want to send each one of those a separate signal. So you have that capability that you can launch the software twice and run it side by side, and I'll show you guys how to do that. There's your custom signal I mentioned. This is called extended limits, which allows you to do very, very rapid movement. All right. Advanced jamming, hardware in the loop or hill. So I don't know if you guys ever had any application where you run hardware in the loop, but that's basically you control it, send information to us, and then send it back out. In advanced jamming, be careful with this. Right? Do not. I probably would not give that option to students myself. All right. Especially with all the stuff going on in Mexico, I think jammers are illegal, right? So advanced jamming is some pretty powerful capabilities. I would not give it to students. It can act as a spoofer and a repeater, so if you actually want to regenerate or spoof a signal. And I think everyone probably knows spoofing. It's giving a fake signal and taking control. It's not as easy as people make it out to be in the press, but it is very possible. IQ file generation and then the plugin license. So those are all the things that we've talked about, and I mentioned to a lot of you guys on the previous call if you were there that you're getting. But this is what we're going to check today when we actually fire up your software. All right, do you guys need a brief break for coffee? I like taking a break about every hour or so, just 5 minutes to stand up. So we'll take about 5 minutes. Is that good? Maybe 10. 10 minutes. And by the way, that's the American 10 minutes, okay?
Yeah.
Not the Latin American 10 minutes. So take 10 minutes. We'll start right back up in 10 minutes, please. Okay, good. You guys that are on the internet, we'll start exactly in 10 minutes. It's on the chat window. Yeah, it's on the chat window.
Okay.
Yeah.
Thank you. But if I want to see the link for this presentation, in order.
Right, so it's right. Very, very beginning. No problem. It's okay. So go to are you logged into the system? You have the invite? Log in, and then you can download this link right here. And let's download this presentation. But it's in the chat window, so you're probably not in the meeting, are you?
No, I don't think so.
Do you have the invitation in your calendar?
I created an account.
For that, yeah, but in the meeting, go to your calendar. When Carlos sent out the invitation. I'll copy the link and we'll email it to you real quick. Okay for you guys? Okay.
Okay.
Check your email and see if you have it.
Thank you.
después de que quede terminado, vamos a tener antes de la principal es un correo y le damos la vuelta, entonces ya no sabíamos que llegamos.
You see that first. Funny.
Si hay un tema, de hecho, digamos, ya no se ve cuando quieren sacar. Nada más para el impuesto.
George,
Y con la piseta.
Antonio, this is you right here on the screen, the second one.
yeah,
Okay. Did you load the software? You did, right? Okay. Good. Francisco,
Yes,
did you load the software?
yes, I download the software, but I did not receive the email to
Okay.
activate.
Okay.
you received my request?
Yeah, I did, but I don't know if I got it or not. So Grace is the activation person, so I'm resending it to her. Uh-huh. Grace is our administrator. All right. Is that Maria back there? Is that Maria?
Yeah.
Okay. And she's going to be using your software, I think, right?
Yeah.
No problem. And then Seraphin. Okay. Okay. And Dr. Edan. I'm sorry. Say that so I don't mess it up. Is this your first name, yeah?
Yeah.
Say it so I don't know. Oh, that's easier. Good. All right, everybody about ready to start? Okay, let's go ahead and get started. Can someone on the internet tell me that you guys can hear me just to make sure that you're back? One of the universities just chime in that you can hear me?
I can.
Good. Then you're the important one, right?
Thank you.
Perfect. All right, so let's get started, and hopefully everybody can see the presentation. It's the cloud that says setting up Skydel. If not, please let me know. So this will be a very fast section because I've looked and I've already talked about most of these, but I still want to say it one more time, and then we're going to open up the software, and I'm going to start showing you how to use the software. All right, so when you start thinking about this, we already mentioned this earlier, the computer is important. So if you did not look, in the operator's manual, they show you minimum requirements and recommended requirements. Minimum requirements will work, no problem. But you won't have all of the real-time functionality or processing of data, and I'll show you this in a couple of minutes. If you put it on your computer and you don't have a GPU or something right now, no problem. If you want to move that license to another computer, we can do that. Grace will help get us set up with that. But that's why we have both of those. So remember, minimum versus recommended. This gives you a lot more power, a lot more capabilities. All right, and of course, the GPU card allows you to do real-time processing. The GPU or video card, I talked about that.
That's how we were. You're not trying to.
I am not. I thought I was. Let me go check again. All right, now you should see the screen coming up.
I just can't see others.
I'm going to reopen the file again. See, we shouldn't have taken a break. Should see it coming up. Apologies, I didn't change anything.
Okay, we are seeing you explain the software right now.
Okay, now let's go try the PowerPoint. Okay.
The power.
That's okay. We're going to use software then. We can adapt. Everybody sees the software now? Okay. Let's do this from the software instead of the PowerPoint then. Yep.
If you go outside the team session and then go back.
Try this real quick. So I'm going to log out for just a minute. Still nothing?
Yeah, you are seeing you.
Okay, I'm not going to go into presentation mode because for some reason that's what changes it. Yeah. All right, because I think if I go to presentation mode, it goes away. I think it doesn't. It works? Okay. Okay, so my apologies. Back to the discussion. We talked about the computer. We talked about the video card. And then the 3 ways of actually testing. So everything there was covered earlier. So I'm going to move on to the next one. Computer requirements. We talked about the minimum and the maximum. And when we start the software in a little bit, we'll know exactly what's on there. But I do want to mention everything we're talking about. I try to give you the links in the user manuals online. Hopefully you have everything that you need. And there's also a lot of resources in the learning portal. For example, there's one that shows you how to set this up on an HTML server if you'd like to be able to remotely access it. Okay, moving on. Installing the software. There are always a little mistake here or there when this happens. So anybody that struggled with installing the software, it's normal. So the process is actually pretty simple that I think you guys followed. You go to the link and you download the software. So that gets you access into it. Once you download the software, it's going to generate that file that you send back to us. You take that file and you send it to us, but the reason we put this form online is we don't know which options to put in there. So a lot of times if we actually have it for student licenses or something, we want to make sure that you don't give them licenses that you don't want. So it has to be authorized. This will be automated probably in a few months. We're doing it manually right now just because we're being careful with it, but the goal is to automate this pretty soon so you can generate it on your own. But we still have to control it. Remember, this is still a controlled product at the end of the day because it's powerful. So it'll still have to be approved, and I'm typically the one that approves it for this program. So Grace always gets my approval before she sends you the license. So I think 90% of you probably have your license files. There's a few that you don't. And if you don't, we'll actually work through that today. I've already just checked on one. But Grace is our administrator in Montreal, so she's watching right now. If she needs something when we get to your software, she's going to help us activate it quite quickly. And then you send that file to Orolia, and whenever possible, copy me if you ever have to do this again, just because if anything happens, I like to be in the middle of that and watch it go faster. So it's pretty quick overall. Did everyone do all those steps when they went through it? I know you're waiting on your activation from us. Most of the rest of you have it on there. To the folks online, if you do not have it activated yet, send me an email. It's at the beginning of the presentation. It's robert.burke@orolia.com. And maybe Yvonne, do you mind putting my email address on the chat window? So that way, if you don't have it activated, let me know, and I will check on it for you at break or at lunch. Okay? So that's how you install it. And again, it installs on many computers. So I think we've worked that topic out. Your signals and your licenses. So everything that we talked about earlier, this gives you more detail about all the constellations and frequencies. And every time we release new software, you get more. So we release software almost on schedule every 3 months. So part of being in the learning portal is if you log into the learning portal, you're going to see if the software has been updated. And you can update your software under the OF agreement, no problem, no charge. Yeah, sometimes it fixes little bugs, but a lot of times we're adding capabilities each time. We try to add at least 2 capabilities with every software release of things that people are asking for. So very important. If you use the software and you see something you'd like to have, something that we don't have in there, something you think would be interesting, put it in the forum so we have that information, because the engineers are quite good at getting information in there. Their job right now, they said, is to have the best system in the world, so they're trying to do everything they can rapidly and add stuff quickly. Some things are harder. The PRS code for Galileo, for example, is about a 9-month project because we're working with the folks in Europe on that overall. And again, this gives you all the capabilities that we talked about. Green is things that are available now. Blue is in development, and I think this chart needs updated because I think the L2C is out now. There's no G3. I do want to mention something right now that's important, and I'll bring this up twice. The constellation that you're testing will dictate how many channels you can run on the GPU. Some technologies, like GLONASS G2, the way they run the frequencies and the way they transmit it, it takes more GPU power. So it's not a model that says you can get exactly 24 satellites here, 24 here. GLONASS G2 and Galileo E5b, those signals are actually more robust and harder on a GPU. So that's why we're going to show you how to test the GPU so you understand it, just to make sure it can process it. But it's not an exact science. We give you the freedom, but we also give you a way to test it every single time. And like we said, hundreds of signals, about 150 to 300 signals per GPU. And we have systems right now with a lot of GPUs. We've installed chambers that have 30+ satellite antennas in the chamber, and the satellites actually go across the chamber in the sky. We amplify and decrease the signal to actually show the angle of arrival of the satellites. We do surface systems and wavefront systems, which takes about 6 GPUs. So it will scale for big projects if you get involved with some of those. Okay, I would like to switch to the software, so let's make sure this works. If you have the software and you want to follow along, great. If someone else has it besides you and you want to look at theirs, great. But I'm going to spend a lot of time in the software now instead of actually being in the presentation. If you don't have the software, you can follow along on mine because I'll have mine on the screen, we hope. All right, can someone verify really quickly the software is on the screen? I think it is. Okay. So if you installed Orolia software and the Skydel's on there, you can obviously double click on the icon for Skydel and open it up. There's a couple things that I want to explain about the interface, and there's a slide on this also if you want to see it. I think it's the next slide. But the software itself, when you start firing it up, there's actually a little bit of a flow or logic to setting it up. We all get in a hurry, including me, and we jump here, and we jump there, and we jump here, and then you end up getting something wrong. So it's easy. I think Mexican's the same as Spanish is the same as English. You read a book, left to right, top to bottom, right? Same, okay. So that's kind of the way the software works if you think about that. So I'm going to start by clicking on a new configuration. As we go through this training, I'm going to ask you to save a couple of configurations so you have them. But any test you run, you can save that and just go straight to it in the future. So for example, I'm going to have you guys do a route where you drive from Puebla to Mexico City. You save that, then you can pull it up next time and it's already pre-configured. So click New Configure. New configuration, sorry. Okay, so when you start with the software, you're always going to start in the upper left-hand corner. So I'm just going to explain the icons a little bit for right now. So the upper left-hand corner is your settings. This is where you're always going to program your test. This is the most detailed menu option in the software. So if you click on settings, you see everything from output to start time, global parameters, a menu for every single constellation, a menu for the vehicle, which is what type of car, vehicle, boat, ship, rocket you're using. And then you've got your interference, which is the menu to actually set up interference, spoofers, custom signals, and plugins. You might not have all of these depending on what you checked when you actually download the software. We'll see that in a couple of minutes. I'll show you how to verify that. So if I have some menus that you don't, make sure we think about what those are and whether it's something you're going to need. Easy to update these. Again, staying on the left side, if you want to connect to a receiver, so if you're testing a Trimble or a U-Blox or a Qualcomm chip or Novatel or Serpentino, all the different receivers out there, you can actually connect to that receiver through a serial interface. And we do that for two reasons. One, we can give you the ability to control it. So you can do a cold start or a warm start of the receiver. And by the way, when we start testing, that's really important. If you test a receiver and that receiver is tested in, you gave it the parameters to be in Mexico City, and you go in and you change your parameters now for Ensenada on the West Coast, that receiver is going to be confused for a little while because it has the old parameters in it. So it's always a good idea to at least do a warm start because it clears out those registers. A cold start is always better if you're doing tests. And very important in GNSS. This sounds crazy, but one test of a receiver does not prove it's good or bad. You just typically test a receiver 30, 40 times. That's why we build in a lot of automation. Because what happens sometimes as you're testing a receiver, it gives it certain parameters and the atmosphere changes or something happens. Those are all the things you have to take into consideration. But a rule of thumb, and all the manufacturing companies know this, is one test of a GPS receiver doesn't always prove it's good or bad. So you want to automate it sometimes if you're actually, especially if you're sending something to space, you want to test that thing hundreds of times, different parameters, because you're not pulling it out of space if it goes bad. All right? So keep that in mind, and we'll talk about automation. But that receiver gives you the ability to not have to open the software for the receiver. If you're doing an automation, you run a test for 15 minutes, you can reboot the receiver in the script and run your next test without constantly going back and forth manually. 2, we give you access to read what's called the NMEA data, the navigation data, on a receiver. That navigation data is what it uses to present the navigation to the user. That NMEA data itself is something that you have the ability to see, so we let you see it. And even though we're not to it yet, you'll see a tab down here in the bottom called deviation. If I'm connected to a receiver, I can see what I'm transmitting, and I can see what the receiver is doing. Because the most important thing is the receiver responding and following the navigation the way that's being sent to it. And whether it's a bad cable, a bad antenna, a bad receiver, whether there's too much interference, whether there's too much noise. And this is also very important when you attack a receiver. So part of what you're going to be able to do is you're going to try to jam or spoof a receiver. And when you jam or spoof a receiver, you want to see when the deviation happens. You want to be able to know that it's going out of sync or actually out of location. So we give you all that automation built in, and that deviation tab at the bottom is one of the reasons for that overall. So it's quite powerful to see just your simulation and what the receiver is doing. On the left side, the third one down is your map. So, yes, sir.
I don't know if you can ask.
Go ahead and ask the question if you want online. Jorge, do you have a question online?
Okay.
You might have to unclick mute. Jorge, if you want, you can also type the question in, and we can look at it too if you want to put it in the chat window. I will continue then. So the map, it's a map. It's easy to understand. But the map isn't just a city. You'll see if I actually have a satellite going around the Earth, then the map is the Earth. It shows the trajectory of the satellite. This is always going to be the map that is actually on the vehicle itself. And you'll be setting these maps up today. I'm going to actually have you guys program some routes and things in today so you understand it. The fourth one on the left is automate. Pretty simple. It allows you to do any type of automation, and we're going to use this menu today a lot so you guys understand how to customize it a little bit. But that automate will actually do everything that we do in this system. It will capture it. So right now, since we haven't been doing any testing, your automation menu is almost probably empty, like mine. It just shows the start. But we're going to use this a lot today. But remember, these are your only 4 icons when you set up your test. There's not a lot of menu trees or things hidden. It's in there. So pretty easy. Settings, receiver, map, and automate. Any questions on that? Pretty basic, right? Okay. Okay, I want to show you a couple things then at the top. So across the top, at the very, 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 very top, you see File, Edit, Window, Tools, and Help. So click on Help. If you actually get a new license and you want to update it, or there's a new code change, this is where you would start to do that. But also, we keep our online learning manual everywhere. So if you actually need to look at the manual, we keep it in the software, we keep it in the portal, But I will tell you, if you click on the user manual, that's an online manual, so it actually goes to the web connection. If you don't have an internet connection, it won't go. If you actually want to add a plugin, so for example, University of Stuttgart's publishing 2 plugins pretty soon. And if they open source their plugins, you can add their plugins to your license, but they have to open source it. Same as you, if you develop a plugin at the university or here at the Mexican Space Agency, you can publish that as private, or you can publish it as open source. And if you open source it, other people can download it and use it. So that's up to you, depending on the test. That's the freedom we give you. Yeah, it's a box. If you look in the bottom, you've actually got the plugin. But all the plugins, we actually keep all the information on GitHub that's off of the forum. So all the details, all the informations, all the published plugins are there. In fact, I think if my computer works with you, I'll show it to you. Maybe. There it is. So if you go to the forum, which hopefully everybody online sees the computer changed, you actually see the GitHub repository. You go to GitHub, there's the plugins that are actually listed there that are public. It actually has the documentations on how to do the plugin and so forth. Yep, exactly. And our people are quite, I almost talked like I'm in England. I said quite keen. Our people are very interested in the plugins that you're developing because we are also developing plugins. So maybe we're working on the same thing or something. So if you're working on a plugin, just send me a message or put it in the forum. And you can even do a private message in the forum too. And I can get the engineers to talk to you because they'll be involved with this a lot. Yep, and all the details are in there. I'm not a plugin expert because it's only been out about 6 months. It's pretty new, but all the information should be there to do that. No problem. All right, so I'm going to go back to Skydel software. So the last thing I want to show you is actually in that same help menu. You can get to the user forum, but I want you to all click on About Skydel. This will show you your version, so always double check every few months to see if there's a new version, because like I said, about every 3 months, almost like clockwork, the engineers will put out a new release and you can download it, there's no charge. But you will also see all of the licenses that are actually put on there. So you see that all the different licenses are yes or no, and then most of you probably have an expiration because we gave you a temporary license. When we give you your permanent license for your permanent system, specify to us that it is the permanent, so that way we set them all to never. So that way you actually have it. But I think right now almost everybody has a temporary license because that was the agreement for you guys to get started with the temporary license. But if you look through that, you'll see all the different capabilities that are enabled, all of the constellations and frequencies that are available are in there, the plugins, the HIL files, the IQ, Galileo, Y code. You will see some things blocked, like M code will be blocked, since that's a military signal. But overall, you should have the majority of the capabilities except for M and Y. What's that? I don't remember what the Y actually stands for, Yvonne. I apologize. Yeah, it's one of the military classified signals, though. Maybe someone on the phone knows, but I don't. Yeah, but you can scroll through and see all the different ones that are there. And if you're curious, we even publish all of the release notes so you know the most recent release, everything that was added. So you see we fixed the bug with Gaussian noise. We added features of navigation messages for Galileo E6, fixed some more bugs. It is software. And they were actually having problems with the DECTEC cards weren't always coming up in the right order, so they fixed that. So we always show you everything that we're doing in the most permanent, in the most recent release. The most recent release, and most of you guys should have it, it was somewhere in the 21.9.3. You do have the ability to download all of the different versions if you want to go backwards So just double check to make sure that you've got the most recent, which Grace should have outlined to you, which I think is 21.9.3. Okay, any questions on general navigation? Okay, we're gonna see how people installed their software now. You guys ready? Sounds like everybody's good so far. Any questions on the internet, on the web connection? Okay, I would like to run through setting up a very quick and very basic test with everybody, okay? So, I want everybody to click on settings, and if I go too fast, please jump up and down or scream. In settings, I want you to click on output. If it's not already there, it should be the default. Go to the middle of the screen where it says select output type. Again, left to right, bottom to top. So settings, output, down to these here. Click on the pull down menu that actually has none RT or none or whatever in it for the output type. There will be a lot of you that will not be able to run in anything except file and none. So if you have a GPU, you can run real time. So the explanation on these, and they're in the slides later on, is the numbers and letters are cards. They're software-defined radios. So if you're using a DECTEC card, you choose DECTEC card. And when you choose a specific card and you go to add it, it always tells you your hardware configuration. So you know your signal levels, you know that you're supposed to put in a cable in the actual DB. And when we actually sell our units, we always send it with the four-way splitter. We always send it with attenuators and a DC block to block any power going back into your system. But if you build your own, you got to think about these things, and the diagrams are in the book. But if you add a specific card, we try to tell you exactly the physical configuration, the signal configuration, how much loss and signal is in there, because the receiver is typically used to getting somewhere around neg 110 to neg 130, neg 140, depending on the receiver. Okay? So that's a hardware configuration. So if you went there, just click X on that. And hit clear to make your screen go back to nothing. A lot of the tests that we're going to run today are either none or none RT. So none means I am not transmitting RF. No RF signal, no transmission, none. And the difference between none and none RT is pretty easy to understand, but when I explain it to you, it may get a little complicated for a second. None doesn't worry about time. It doesn't care about the GPU, all right? And you'll find if you actually like to run fast tests, if you go to none, you can do what's called a turbo test. It will run time faster. And a lot of people like this because if they want to run a 24-hour test, but they don't want to wait 24 hours, they go to the none mode. And you can run none mode in any computer. If you go to none RT, real time is what the RT stands for. It requires a GPU because it's got to process all of those signals real time. Real time is what what works a GPU hard. If you do real time with 8 satellites, it's not a big deal. You do real time with 100 satellites because you've done GPS, GLONASS, Galileo, Bayo, SVAS, QZSS, and you want to do multipath testing with echoes, you can do hundreds of signals. You will work a GPU very aggressively. So that's why we call it real time, because it's processing all of those signals, the path, all the data, all the transmission, all the signals simultaneously. And that's when typically you start thinking about adding a second GPU. Did we turn the electricity off too? No. So for right now, I want to check something. I want everybody to set theirs for none RT. This requires a GPU. So if you have a GPU, you can actually add in a signal. So add and see if you can add. Anyone not able to add yet? Just by clicking add, it brings this line up. You can add or you can't. Okay. If you have this line right here, let me see if I can figure out how to turn on the laser. It's the line that says none RT. This is actually one output. So let me explain this a little bit before you guys do a bunch of setups. I can add multiple outputs by clicking that add button several times. Each of these is one different output or SDR if you're doing an SDR. So if I have 3 SDRs and I click it 3 times, then I can set up 3 different outputs. If I only have 1 SDR, then I can only do 1 output. Our devices that we have always come with up to 4 outputs. And I'll explain that in a couple of minutes in the hardware section. But what I want you to see is, and I'm going to show you this real quick, so everyone watch instead of clicking for a minute. If I add an output, you get the output line for that specific radio output. I'm going to edit that output on the right side, and I'm just going to make it GPS L1CA. Actually, let's do L1C. Once I enable a signal, and you can add multiple signals, and I'm going to explain this in more detail later, you'll notice that I have a button that comes up that says test GPU speed. If you don't have a GPU, then you can't test a GPU speed. And what we do is we give you the ability to make sure that that satellite, I'll stop for a minute. It's down here at the bottom, it says test GPU speed. This is testing your GPU on your computer or testing our GPU on our hardware. And when I click on test GPU, this is where you have the ability to change your satellite count. So now, most of you probably know this, but I'm going to ask it anyway. About how many satellites do you need to see in GPS or GNSS to get a sync, to get a location fix? 3 to 4. Yeah. So if you're testing, a lot of times people think, well, I'm going to make it as high as possible. If I'm in a car driving on Earth, how often will I see 24 satellites? Never. They're all around the world. So you have to think a little bit on your configuration, and I'm sure a lot of the GNSS experts know this. If I'm running a test on Earth, normally you're probably going to see 8, 10, maybe in the desert, 12 satellites, maybe, depending on the location. So you don't always have to crank that number all the way up if you want to actually have lots of signals. What's different when I go up in space? If I'm actually have a satellite in space that's using GPS, can it see more satellites? It actually can, because it can see over the horizon. So a lot of times, the higher in elevation you go, the more you can see the horizon. So a lot of people, when they do GNSS testing, if it's an Earth-based application, they probably only use 8 satellites for most tests. That way they can run more constellations. If you get into aerospace, you might be adding a few because it's up in elevation. You get into space, you can see a long ways around the horizons of the Earth and see more satellites. So just think about that when you're running your test, because we give you the power. We don't tell you what to test with, so you have to think a little bit when you're running your test, what am I doing? And if I do want to run GPS, GLONASS, Galileo, Beidou, QZSS, all of these simultaneously, then you can reduce this count very easily just by clicking it down. So if I'm doing a test and I just want it to be 8 satellites, then it's less work on my GPU, and I can prove this to you. So if everyone can see my screen right now, I just changed it to 8. I'm going to test my GPU by hitting start. It takes about 15 or 20 seconds probably depending on the satellite count. You see that I got a green line here, and my number is very, very, very high. A 1.0 or better means that you're pretty good shape. That's a passing score. So we got a 6. But if I go in here now, and I'm going to do 24 satellites, I'm going to run the same test. As long as the software doesn't make a fool of me, that number is supposed to be lower. So there's 3.43 right here. So everyone understand, the more satellites, the more signals, the more things you generate, the more work on a GPU. And it's okay. Maybe you put 2 GPUs in your system. So this normally brings up questions. So I will pause here for a minute because this is a different way of thinking from traditional simulation. You have the power, you control the satellite count, you control the quantity of GPUs. But test that GPU on very robust tests just to make sure. Okay? What are the questions or what is confusing here?
What is an acceptable score?
What's that?
What is an acceptable score for the test?
A passing score normally of about 1.0 or above is good. So what I'm going to do right now is I'm going to show you a robust test. So watch what I'm doing. I'm going to go into my non-RT. I'm going to enable GPS L1. I'm going to put GLONASS G1. I'm going to put Galileo E1 in here. I'm going to put SFAS on there. I'm going to put it the Beidou. But I'm going to add a second card. And on the second card, I'm going to go with the lower band. I'm going to put GPS L2, GPS L5, E5A. Let's put some Beidou on there. So now I have a lot of signals. So if I test my GPU speed, yeah. So see here, they're actually listed right here.
How do you select that?
In the edit. No problem. Ask questions at any time, you guys. I'm very easy to get along with. Just because it makes sense to me doesn't mean it's you. So what I want you to see, and we're going to do this in detail later. It's so. Yep. Yep. And it's okay if you don't have all of these set right now. Do you guys have a GPU in that one?
Yeah, we have.
Good. It's probably not option, so we'll check that option. So we're going to do like probably 10 exercises later on where you're going to use this over and over and over again. What I really want you to see right now is the simple point here. I have lots of signals, okay? I'm going to test my GPU, and now, since I have lots of signals, I've got different settings. But keep in mind, I did GPS. In fact, I'll show this to you. You see up here, I have GPS L1CA, GPS L1, GPS L2, GPS L5. GPS is set for 14 each. L1, L2, L5. I'll show you how to change those later in the detailed settings. But what should happen right now is don't worry about the exact configuration. What I want you to see is I put a lot of work on that GPU. And if I start it now, there's a good chance it's nominal, which is yellow, or red, which is failing. See how the test is taking longer? It's taking longer because more signals. It's got to process all of those. So the score right now is 0.58. So Antonio, you were asking earlier, the 1.0 or above is passing. When you get below 1.0, it starts to fail. And there's even a yellow setting if it's right around 1. So the point I'm making to you guys, I know this is a little bit confusing at first. We give you power. Test that power. If you're going to configuration and it's a robust configuration with lots of signals, lots of satellites, lots of frequencies, test the GPU to make sure it can process that. If it does stretch it to limits, either A, reduce your satellite count. So I could go in here and say, I'm going to lower this to 8. I'm going to lower this to 6, because GLONASS is hard to see here. Galileo to 6. Actually, Galileo is a good signal here. Beidou, we don't want to worry about Beidou too much. Reduce SFAS. So now, what I did is reduce the count for all of those. So this should make my test a higher score or a higher number. And I actually have a documented exercise for you guys to play around with this in a while.
What happens if you try to force, even if you don't pass the GPU test, you are able to run the simulation?
You're going to run the test, but it's going to have trouble keeping up. So you're going to actually have GNSS errors coming up on it because it can't process all those satellites simultaneously, and it will corrupt your tests. So now I almost passed on that one, 90. So please don't get caught up in the details yet. We'll get there. But GPU, keep thinking GPU is the power. It's the processor. It does all the work. Okay? For those of you that actually, when we do tests today, if you don't have a GPU, you're going to run in none. So what I want you guys to do, if you've done anything in your screen, hit clear so it's completely empty. Go to your output type and click none. Nix, nada, none. Go ahead and hit add, and the menu looks the same. You can do all the same stuff. And you can go in on that output and click edit, and you can add signals. You can run all the tests you want, but you're not transmitting RF or IQ data. Okay? So the fun thing about this and what a lot of people like is just choose one signal. Let's just do GPS L1C. Hit OK. And we're going to run a quick test so you see it. You cannot test the GPU because you have no GPU, but I want you to go up to the top, to the left, to start. Click start. Make sure you're on the Constellations tab on the bottom. And these are the satellites that we just configured. So this is your output. You're running a test right now. But I want you to look at the clock in the top. Right there. It says that it should be moving much faster. It says it's 7 minutes. When we've only been running it for 1 minute because it's not real time. So this is the way to run a rapid test if you want to test something or your configuration pretty quickly without real time and timing clocks required. So let me review what we've covered just to make sure that I have everybody up to speed. The first thing we covered was the 4 icons on the left. Pretty easy. We talked about the top line, which has your tools and your help menu and how to actually upgrade your software. Okay. We've used the start button, but we can also stop it. So that's pretty easy. And of course, when you run your test, you'll always see in the top whether it's ready and whether it's processing and the amount of time that it's ran. So this is where you always look first when you run your test. Okay. But I want to show you something really interesting. We're going to go back to your icons on your left and go down to automate. Everything that you just did in your simulation is saved in commands. So if you want to go to the right in this main menu and see the scroll bar right here, You can scroll back. Everything you just did in Skydel is saved. So if you want to actually do scripting later on, pick a line, any line here, and double click on it. That's your script. So if we export this to Python, that's what's going to export for that specific command. And if you want to know what it does, hit documentation on the same menu, and it tells you basically what those commands mean that are in there, the output or the input. So remember, I call it, people don't like this. Do you guys ever learn to program years ago in Visual Basic? That was my very first programming language when I was much younger. And people make fun of it now, but it was easy because it was point and click and it coded. So that's why I call this point and click scripting, because technically you are coding right now, but you're doing it with your mouse. Okay? And if you want, since we're on this menu, this is later in the training, but underneath the lines, you can save these files or export it directly to Python if you want. No problem. So any questions so far? Okay. Is everybody still running a test? If not, press start. And we're going to talk about the bottom screens down here.
Can I have a report of the simulation?
I'm sorry?
Can I have a report of the simulation?
Yes, I'll show you how to do it in a little while. Yep. There's two different types of reports. There's the commands and the actual specifics of it, so yes. So just so we get everybody on the same page, I want everybody to go in, and I'm going to do it all together. So let me just clear this. Let me stop the test. And just so we're all together and see the exact same thing, you're going to go to Settings, Output, and you're going to go to the middle and choose your output type. And I'm going to configure the same as everybody can by clicking None. You don't have it chosen already. We're going to add one output by clicking Add. And right now, just so you look, there is nothing configured. See how it says yellow, no signal? So you have an output that's not configured. So we're going to click Edit. You guys okay? Okay. Click Edit. And we're going to just choose one. Let's go with L1, GPS L1C. You know what? I changed my mind. Let's do Galileo E1 also. So you should have GPS L1C and Galileo. Hit OK. And now you notice you have a signal here where it used to say no signal in the middle of that output. Okay. And you'll notice on the bottom right-hand corner, this is your sky plot. If you've never used a sky plot, it's simple. Lay flat on the ground and look straight up at the sky, basically. Where you see north, south, east, and west, these are where the satellites are. Now, I haven't had you guys configure a time and date yet. We'll do that later. Okay, it's the default right now. We're going to do some really neat things over time. But we can still run a test on the default settings. So if you go to the top, it says it's ready. Right here, at the top, click Start. And you know you're running a test because of a couple things. See, the counter is moving, and your status says streaming RF. Okay? I set up that test so I can explain to you the bottom. So we're going to focus on the bottom half of the screen right now and these 4 tabs. Everything is color-coded, okay? So I want you to look on the left side where it says GPS, GLONASS, Galileo, Beidou. These are the colors of the satellites. And if you notice, there is blue on the sky plot and green because that's what we configured, GPS and Galileo. You can control each of these individually. So where there's colors on the left, these are buttons. So we had GPS, you can click on it. If you click on GLONASS, there's nothing because we didn't configure it, but you can click on Galileo. Yeah, since we're in none mode, it's not real time. Yeah, it's just going very, very fast. People want it to go fast because they call it turbo mode. They want to run tests faster. So that's why it's faster instead of slower. So yeah, but it's not real time. But does everyone see the controls that I click each of these? And the reason this is important is I can control that satellite power. So I want everyone to click on GPS, and you notice that you have a satellite enabled. It has the green bar. There's a bar underneath of that. I can change the power of a satellite real time. And this is from the reference. Everything's neg 130 dBm, but I can change the reference by sliding that bar. If I want to change the power over here on this satellite, I can change that bar. Why would I want to change that? Any thoughts? Why would I want to change satellite power?
Probably attenuation inside. Sometimes the receiver is below.
Exactly. So if I wanted to, driving in Mexico City, tall buildings on each side, and I have now 8 satellites that are maybe talking to my receiver. I want to take 3 or 4 satellites and make them disappear like they're behind a building. So I can change the power of a satellite, or I want you to go to the left and hit reset sliders right here. That's a button. They all go back to default. Like that. And if I click all sliders, the box above it, I can change the power all at the same time. So for example, I just drove into a very long tunnel and I lost all my satellites. What does the receiver do? And more important, in some applications, does something else take over? I lose GPS, but does my inertial sensor on my car keep working? So those are all the capabilities, because it used to be years ago when we used satellite navigation, we drove in a tunnel, we lost satellite, our receiver went crazy, it didn't know what to do. Most modern cars, if you do this in a tunnel, keeps going, because it's the sensors and everything about the car. When you turn the wheel, it still has local navigation. So you can simulate losing GPS and see if other devices take over. But the point I want you to see is you have full control of each satellite for that specific test, or all satellites real time. If I just did this that I'm doing right now to a receiver, it's not happy. It just got really confused because it went from a perfect signal somewhere around neg 130 dBm to, uh-oh, I have craziness. But again, if you want to go back to default, it's easy. Just hit reset sliders.
That's the power with clear sky.
What's that?
That's the power
with normal clear sky on this specific test. And there are many parameters I haven't shown you yet. Like, where is this test? What time is it? What day? I haven't set those up for you yet. We're just getting you used to the GUI. But yes, for that. And remember, that was just the GPS satellites. If I want to control the Galileo satellites, then the same thing. I click on the Galileo color, and I move the slider around for Galileo, but GPS is okay.
What about the reference?
What's that?
What about the reference?
The reference is always neg 130. That's always what a receiver's roughly getting. We don't change the reference. We change the levels from the reference up or down. Any questions so far on the conference call? Is everybody doing okay? Maybe give me 1 or 2 yeses on the web at the universities. You might have to unmute. Oh, we got some chats coming in. Good, perfect. I got some yeses. Again, unmute if you have any questions, because I don't want to go too fast.
But running on this mode, no, we are not generating signals.
No, but you're actually generating the IQ data that would control those signals. So it's not truly modulating RF. It's doing it in the none mode because you don't have the ability to do it right now. But it still simulates every aspect of that. Yeah, you would not connect to a receiver right now because it wouldn't work in the none mode. Okay, on this bottom menu, there's a couple of other things just so you know. Look clear to the right, see that little eye. Click on the eye. If you want to know what things mean, this just shows you. So you notice on your screen, I want you to look at a couple things. Since we're in none mode, do you guys see the lines? That's the satellites moving. That's the direction of the satellites. And depending on where the satellite is, it's going to be a different color. So the dark greens typically means you see it. The light greens means it's probably over the horizon. You can't see it with your receiver. But this just gives you an explanation of how these things mean and what they mean and what's going on. So it's just data or information. And you do have the ability to change your graph if you get really geeky. This circle right here, we can do this in linear or in sign projection. Not that important, really, unless you really get into a lot of detailed testing. But you notice linear, that actually shows you the Earth mask and the elevation mask, where the actual sign actually just puts that off to the edge. So all it does is it's how you view this circle. And some people like to view it different ways based on history normally and how they learned, okay? But you do have that ability, and it shows you to change that. You go up to the top of the window, and it shows you how to do that, all right?
Earth mask, something like azimuth.
What's that?
Earth mask, similar to azimuth.
No, I think what would probably be a better way of saying Earth mask is when you get to a certain point, you're past the horizon, you're past where you can see the satellites. So the Earth is masking that signal. It's probably a better way of thinking it. But again, I'm not an expert in the linear and the sign stuff, so if someone has better information on it, feel free to explain it. But that's just changing the view of that circle. But the cool thing is, since we're in the none mode, according to our test, it's been running for 1 hour and 22 minutes because it's not real time. And over 1 hour and 22 minutes, the nice thing is you see the satellites moving. They really don't move that fast, as you guys know, or the Earth doesn't, I should say. All right, so any questions on this one tab, the constellations tab? We're going to change this a lot today. There's going to be many times where I have you do GLONASS or Galileo and change these. But I want you to see how it works. So let's go through the other 4 tabs. Tab 2, I already showed you. Nothing will be there right now because that's the deviation of what I'm sending versus a receiver that I'm connected to, and we don't have a receiver connected right now. So for example, I had a U-Blocks receiver that I wanted to test, and I actually connected to it through this receiver icon on the left, right there. Then I would actually see data here because it's the deviation between my simulation and the receiver. That's why you see nothing there, but you will later when we go through some stuff. The spectrums. Tab 3. Click on spectrums. And I'm going to go change my test very quickly. I want you guys to see a result here. I'm going to stop my test. Do not follow this. It's just going to be a quick change. Okay, so I'll tell you what I just did, but I don't want you to do it because it's not going to work. I changed my settings to none RT, which most of you can't do if you don't have a GPU. And I'm going to start the test, but I'm running GPS L1 and GPS L5. When you have a GPU, you'll actually see the spectrum mask. The GPU processes the spectrum mask, I'm sorry. So right now, I'm looking at GPU L1 CA, which is this configuration, or radio 1. And this one's looking at RT, or radio 2. So if I want to change this, and we'll do this a lot today. I know I'm getting a little bit in a hurry here, but I want you guys to see the result screen. I'm going to add some signals to this. Now, if I hit start, remember, each card now is transmitting multiple signals, and your color codes come in again. So there's your GPS right there, and there's your other signals. So this is a visual representation of the RF signal coming out. This will be really important in a little while because I'm going to show you guys how to generate interference. You can control your interferer. So whether that's a different type of interference, a different form, a different pattern, I'm going to show you guys how to set that. But it gives you that capability that when you inject that, you can visually see everything that you're doing. And if you want, Orolia offers a free poster. All the universities want to go online and order the free poster. We have free posters that give you all of the actual patterns and the modulation techniques so people can visually see all of these. But it's just basically a spectrum analyzer or a spectrum plot of the actual signal. So remember, if I go up here now, I'm going to stop it for a second. Remember this chart. And I take something out up here. I take GLONASS out. I hit start. Now it's just going to be GPS. This is a great learning tool for students. If you actually want to show them what a signal looks like, you want to explain to them the modulation techniques, you can actually show them each one of these individually. All right? I'm going to go in and check the messages really quickly because the phone's going up here. Yes, you can use that type of display for your courses at ANOA, no problem. How pretty. You guys are funny. No more questions. Good. Okay.
Can we change the parameters, the central frequency?
You will have the ability in a little while to build custom signals and change your frequencies and so forth. Yes, sir. Yeah, and I'll show you an easy way to do that, even though it's getting ahead of ourselves. I can actually go in. The GNSS signals are defaulted, but if I go to interference and spoofer, I can actually choose my center frequency, choose my sampling rate, and change that actual specific pattern. So plugins, custom signals, interference, you can do that. But on the GNSS signals, we lock those to the ICDs. Did that answer your question? Yes. Okay. So I'm going to show you two more tabs. And again, these are just explaining the tabs to you themselves. When you do complex tests, let's say you do hardware in the loop, and you're working our system with maybe a D-Space Galexio device, which is a device made out of a German company called D-Space. And you're syncing it with D-Space. but you're going to synchronize it also with automotive software that you're going to bring in and show a car driving through the automotive software. We work with many different types of software and hardware packages in hardware-in-the-loop type configurations. But when you do that, people always have trouble troubleshooting because they might have two hardware devices, a receiver and a hardware-in-the-loop device. They may have three software packages, ours and maybe an automotive software package. There's even city software where there's a picture of the city with all the buildings and the height, and you can literally do 3D tracing where you literally show GPS bouncing off buildings. The point being, this software works with a lot of stuff. So when you start fighting with many systems working together, we've just added a brand new tab, literally just a couple months ago, called Performance, that allows you to always see our performance. If you go to Hardware in the Loop, then we can see others. So that way, if someone questions, are we processing data, are we having errors? Because we can. You know what happens? We always monitor the performance of our data. So you can see the constellations, the modulators, the streamers. You will rarely use this in a standalone mode, ever. But if you're interfacing many devices and you want to see the performance of each individual system, we have now decided to show you our performance, good or bad. We're going to map it out for you at all times. And even though it's just me working by myself, you can see over the last minute, the constellator, the modulator, and the streamer. What we do is from the minute we get a command in our software and we modulate that to the GPU, from the GPU actually streaming that IQ data, we map all three steps of that. So you could literally see a bad GPU card by doing this. If all of a sudden the streamer was flaking out, you could see that for some reason it was modulated good and transferred good, but the streamer's struggling, it's probably your GPU. So if you ever have problems, this just segments our capabilities in the box. It's a little confusing, but I promise you 90% of the time in standalone mode, you won't use it. All right? But very powerful in hill configurations, especially for complex things.
This flows in the performance of the hardware.
From our software through the hardware. Yep, 3 steps. We call it the constellation, which is generating the GNSS information from the standards, to then modulating it through the GPU, and then streaming the RF data. So all 3 aspects of that. So you could isolate it, but very little deviation there. And then the last tab, please don't get caught up on that tab. I'll give you the hardest one to ever work on, is if anyone ever works on a flight simulator, an airline flight simulator, and you interface us with the flight simulator, you've got us, you've got the flight simulator, you've got typically a hill device, and you've got the pilot making manual controls. That's 4 aspects of a test. So it gives you that capability to isolate each part of that. Is it the flight simulator? Is it us? Is it something else? And then last but not least is we log everything. So on the right side, everything that you just did, we always run that log. And if there's a problem, it will turn red. So you always see it. So everything we've been running, you've seen all the tests we've run. From the minute I started working with you guys a while ago, every single one of those commands, everything that I did has been saved. And every time I ran a test, it tracked it. So you have that log. So if you go home and you run a 12-hour test at night and you come back, you see, let's say you run 25 tests in 12 hours. You can come back and say 24 passed, but 1 failed. When? What time was it? You could see what time that test failed, and then you could go to your receiver logs and see why the receiver failed to see what happened in that simulation, because that will be read as a log.
There are a couple of questions.
Okay. Let me go look at them real quick. The reason you can't see the spectrum, Jose, is you're in none mode. So let me explain that again so everybody can see it. Is the spectrum does not show up unless I'm running real time. So I'm going to clear my test. I'm going to go to none mode, Jose. I'm going to add just 1 signal. Hit OK. and when I start my test, you are absolutely correct. In the none mode, you will not get a spectrum because there's nothing being modulated. So that answered Jose's question. We can see what the other question is. So Carlos 3 University, Rogerio, is it Rogerio, right? Carlos 3 just got added to the program. They're brand new. But I do think one of the things they're going to look at is their hill configuration. So if you guys want, we can get our experts, you guys and Carlos 3 on a call and run through their hill configuration. But they do have, Rogerio, the hill option in their software, I'm pretty sure, because I helped configure that. I think that was all the questions online. All right, so basically what I showed you was navigation. Yes? Because the spectrum and the signal is processed by the GPU. So the GPU, if you don't have a GPU, you're not going to have that setup. If I go to real time, so I'll clear it now, and you know you don't have a run because you would normally have it. Yeah, it's a matter of speed. Yeah, because it takes a lot to build that plot. So, but if you go to none RT, and I do the exact same test, GPS L1, and I start it, then you have the spectrum because the GPU is processing it. So that's the importance of having a GPU. Remember I said at the very beginning of class, we will get different things at different times based on your computers. All right? So in my opinion, your primary system, the permanent license, I would make that a full system, a full 1 or 2 GPUs, multiple SDRs, so you have full power. But student licenses or temporary licenses, then you don't have to have everything enabled. Okay, any other questions on the interface? All I've been trying to show you how to do is how to navigate. So remember some simple things, left to right, top to bottom. So you've got your receiver settings, automate. Each of these, if I go to them, will have some settings sometimes. And what we're going to spend a lot of time on today is we're going to be going through a lot of these configurations. You have a very powerful engine in front of you. I can go in and change the atmosphere. I can change the date and time. I can change the vehicle. I can change the Earth's orientation. I got that kind of power. I can move the Earth.
No,
yeah, I do. I can move the Earth. And you can too later on. You'll be very powerful. What was the man, Atlas, that held the Earth?
Yes.
We're going to move the Earth. We're going to be very powerful today. But that's the interface itself. Okay? Any other questions or comments? All right. Here's your test. All right. I want to know what options are on your software. What version of software do you have? I want you to find it for me. Where would you find it? I'm not doing it for you this time. You got to do it. Yeah, help. About Skydel. Very good. There you go. All right, so you passed your first test. You get free lunch. Good. The people here. on the web connection, you must buy your own. All right. I want to know where the operator's manual is. If I want to find the operator's manual and I'm where Skydel, how do I find the user manual? Same place. Help. Yep, user manual. Or remember, you can go to the user forum from here also. Okay. If I'm in the automate tab, how do I know what a command actually is? So if I'm in this automate tab on the left, you've got all these commands. How do I know what each automation tab is?
By clicking on it, documentation.
Yep, but how do I get to documentation?
Click on.
Yep, you click on it. Double click on it, and you see the actual command and documentation. Good. And I know these are crazy little things, but I want to make sure that you're remembering stuff. So, good. And why do I have nothing on deviation when I run my test right now? What's deviation?
The difference between the simulation and...
Correct. The difference between the simulation and the receiver. So why do I have nothing here? You don't have a receiver. If I had a receiver, how would I connect it? You would physically connect it with cables. You're right. You're right. But how do I connect Skydel to the receiver? I click on receiver, and I'll show you one extra thing. It's a serial connection. You just connect. Serial connection. Yep. That's when you would connect it to a serial device with your stop bits and everything else. Good. You passed your first test. All by cable. We go through serial inputs, yeah. What you can do, I've seen people do a serial to wireless dongle. You can do that, but you still connect your stop bits and everything here. But we do through a serial connection on our GSG8. If you want to go wireless through your device, you should be able to do it if you build your own system. What's that? Because I had to take it across customs and everything else, and they'd give you a hard time. But I have a live system set up and running. So later on, I have a remote system at our Les Solis office in France. We're going to wire our network into it, and you're going to see all this stuff through the network. Yeah, for one day to bring all the equipment down, I could have, but for one day I thought it was hard, so it was my choice, if I'm being honest. Yeah. Good. Okay. So I'm going to go back to the presentation, hopefully. Let's see if it works. And make sure where we are really quickly, because I think we can start doing some real tests now. So the people on the web conference, you should see my computer screen now. I'm going to try to present it. So I'm going to give it a second to make sure they see it. Good? Okay. All right, so I'm going to go through this section just to make sure we did everything we were supposed to. So this is just a picture, and remember, this presentation is in the chat window at the beginning of the session. You can go to your chat window and pull up that presentation, and this goes through it. But this covers what I talked about. You got your 4 primary controls, your start and top at the top, your output settings are here. Where'd my mouse go? There it is. My output settings are here in the middle. You have your test configuration window, which we have not set up yet. And then you have your results or bottom tabs. And remember, there's now 5 tabs. When I made this training, there was 4, but we just added a 5th tab, so I have to fix that in the training. All right? So that's just a picture of what we did in Skydel. These are just unique things that I showed you, so I'm going to fly through them, but it just shows you the things that we talked about already. So if you pull up that presentation later on and you don't remember things, it's there. And the user manual always walks you through stuff too. So if you pull up the user manual, there's step-by-steps. Okay, we talked about this, showed you what options you have on Skydel, so you can go into File. And again, all of this presentation, I give you step-by-steps on how to do that if you don't do it for several weeks. Good tools for students. All the information about your software is on there. I'm just making sure I didn't skip anything. I did not show you multi-instances. So basically, if you go to the bottom of your screen right now and go to the Skydel icon, let me get out of presentation mode. If you hover over Skydel, it probably shows you one window. If you double click on it, you should be able to open up a second window. If not, you may have to single click. Oh, come on. Single click and do Skydel, because they keep changing that menu. If you have multi-instance, you should be able to open up 2 instances of the software. So right now I have, it's hard to see on the screen for you guys that are remote, but I have Skydel opened up 2 times. So you see 2 windows on the bottom. So all of you have 2 instances. If you need more, let us know, send a message to me. I enabled 2 instances because I thought that was enough for your first license to get you on. Remember, if I want to do something complex, the one I like is drone swarms. Does everyone know what a drone swarm is? Where you can fly many, many drones together. So the way I like it is, I like regular football a lot, but I like American football better, sorry. But at the Super Bowl last year, they always do the light show at night. Those were drones. That was a drone swarm. Each drone had an individual pattern that it ran. So this is basically, if I wanted to run 10 drones together and I wanted to make my own Super Bowl, I could do it. But where it's really used is like networks. So there's a big thing right now, if I have a temporary event like a concert and I want to give Wi-Fi, but I want to do it through drones or devices, I can actually have those drones flying different patterns in different places. So there's all kinds of things for drone swarms, which is the easiest way to explain. If I wanted to control 16 drones in Skydel, I could. Each one, I would program a different path, so they would all fly simultaneously through 16 instances of the software. That takes 4 GPUs, by the way. It's pretty robust.
All the instances are using the same license.
Same license, multiple instances. Yes, sir. Very good question. Yeah, so a common thing is, and I'll check the questions, I get my phone dinging, but a common thing is a lot of times an airplane has an antenna on each wing. There's bulldozers that have an antenna, a very, very large bulldozer like a Cat D10 has an antenna on each side of the blade, because that way if they're digging dirt and they want this one to be a ½ inch lower, the GPS antennas operate individually. So you can test different signals or different antennas on the same vehicle also. It doesn't have to be different vehicles. So how you use it, there's 50 different examples of how to use it. All right, so I'm going to look at these questions online real quick just to make sure there's no questions from them. Yeah, precise farming. So Rosario was talking about precise farming. Precision ag is huge right now. So this is very big in Mexico too. Everywhere is going to precision agriculture, where the combines, the tractors, everything are autonomous. But even sometimes they have multiple receivers on those. So for example, in precision ag, you can actually have 2 devices side by side, putting water on a field, but this one puts more water than this one because it's drier there based on the sensor. So there's some neat things you can do in precision ag. In my opinion, agriculture is almost as good as defense right now on what they're doing. Some really good applications. Rosario, you said you need 4 instances, so you have to buy me a beer for 4 instances. Cerveza. Send me a message, Rosario. I'll get your 4 instances enabled. Rodrigo is sending the presentation. Oh, now they're talking about lunch, caviar. No caviar. Good. Okay, so I forgot to show you that earlier. But I think every one of you should have at least 2 instances on that. No other company does that, by the way. That's my bragging point. Okay, back to the presentation. Make sure I got everything. I apologize if I keep pulling my mask down. I'm not going to get in trouble, am I? It's hard to do all this talking. There's a lot of hot air inside here. Okay. What's that?
It may be fine.
Good. All right. So multi-instances. I think everybody on the internet should now see my screen, hopefully. And again, you see in the demonstration here, this is 4 instances opened at the same time, which is possible. Okay, so let's talk about hardware briefly, because I don't want this to sound like I'm selling you hardware, but I want you to understand the hardware options. So for this, you don't need your computer turned on. But I'll explain a little bit about the hardware that is not donated, or you can build your own. The Skydel simulation works on all of our commercial and advanced systems. It is our plan in the future to only have Skydel software. We still have 2 products that have been around for 15 years that are manual front panel interfaces. We're going to be replacing those in the next year or 2, and those are actually going to use Skydel software, but we'll probably just put a little screen on the front where Skydel runs on the front, because people still want manual configurations. We also just came out with a brand new product called a Solo. This product, it's no secret. Does everyone know what a Nook is? A computer called a Nook? Yeah. It's a very small computer. We took a commercial Nook, we put an SDR, GPU in there, and you can now get a Solo from us, but you can build it yourself. It's a Nook computer. But a lot of people wanted that because, especially the military, they can't build their own sometimes, so we build it for them. But you're going to see this is going to grow. We're going to add more products over time. But remember, you don't have to get our hardware, but I'm still going to explain it to you briefly so you understand it. All right, so this is our GSG-8. This is just one, and this is the most common commercial one. You're going to see different terminology with us sometimes. You'll see GSGs, but you'll see the word BroadSIM. BroadSIM is a term we use normally when it's through our proxy company. We're a French company. We sell to the US military. So we have a proxy company called Orolia Security. We have a company in Europe that's a proxy company to sell to the German military. So when we sell systems to the military, we literally change the name of the product. It's called a BroadSIM, which means it can support classified signals. Same software. Skydel works on all. But when you have classified signals for the military, it's very strict and very controlled about the hardware and what can do and what can't do. So if you ever see conflicting terms, it's on our forum. BroadSIM just means it handles classified. If any of you get involved with classified projects, so for example, the Mexican Space Agency working on a project with NASA, then we can get you the classified codes, but that has to be approved, obviously, through the right people. We can't approve you. It has to be the governments that do that. Okay? But the GSG-8, honestly, it's a computer. It's a bunch of slots. So you can put your SDRs inside it. These are commercial SDRs in the back. It's the same cards you can buy and put in your computer. It's got 2 commercial GPUs possible in there. All we do is we give it all encapsulated in a single box. Our prices, if you want to know the truth, are about 15 to 20% more than building it yourself, because we have to make a little bit of money on it, to be honest. But a lot of people go with this sometimes because they want to get it all together. A lot of people build their own. We don't care what you do. That's your choice. The software is still donated free to you. All right? But you can do multiple constellations, multiple frequencies, and I'll show you what I mean by that in a minute. Multipaths, everything that we just talked about, as well as hardware in the loop. We also give you a bunch of other ports, like serial ports for receivers, timing ports to put a clock onto it if you want to put a clock into it. A lot of those capabilities are there if you want to do a bunch of extra things with it also. But you can literally take the GSG-8, put a keyboard, mouse, and a monitor on it, and it runs without any extra parts. There's your GPUs. I think we talked about those a lot. This is the internal working. It's the same diagram I showed you earlier. It's Skydel software running on a Linux platform inside our box. Central processing units there. Your GPUs running it. There's your IQ data coming out to power your SDR. There's your clock distribution, because we do give the ability to distribute clock between all of your cards. If you build your own and you have 4 deck tech cards, tie them to a common clock. Get a good clock source and tie them all together. If not, it'll cause some clocking errors. So that's why we show you that you can tie the clocks here. We've already done it in our box, but if you build your own, you do have to have a common clock. And of course, you talk to our salespeople, they'd love to sell you a clock, but that's not my job. Plus your clock and your 1 PPS signals we talked about, there's all the ports that I just explained to you in the last picture. So I'm going to go through this fast. If you want me to slow down, please let me know, but I don't want you to think I'm trying to be a sales guy. All right. Someone asked about prices earlier. I think you did. So here's how we configure our product. GSG-811 is 1 RF, 1 GPU. 821 is 2 RF or 2 SDRs, 1 GPU. 831, 3 RF, 1 GPU. 842, same thing, GSG8, 4 RF outputs, 2 GPUs, so you can process 500 plus signals, and then again, same thing. So that's the price for the hardware, somewhere from 25 to about 75K US dollars. But if you ever actually get into our system, you start looking at GSG8s, this is how we configure it. The same way you'll configure your system if you build it. Got to figure out how many RF outputs do I want. Some cards, like National Instruments, have 1 SDR card with, I think, 2 or 4 outputs on them. So sometimes you can get a more robust SDR where you have a single card with multiple outputs, but we stick with the Deck Tech cards that have 1 output per card. This is what is changing on the Deck Tech cards next year. So for example, I was talking to Dr. Espana down at Conai. He's looking at budgeting for next year, and he wants to be able to process 400 or 500 signals. And he said, do you think I should get, an 842? And I told him, I said, you can get an 842 now if you want, because he's budgeting for next year, but he's going to put out an RFQ like mid-year. I said, I think you can do less because you put the newer Deck Tech cards in, you could do less. But you got to think about how you configure it. More power probably means 2 GPUs. So we're looking at a configuration now called an 822 for next year, which is a GSG8 with 2 SDRs and 2 GPUs to get ready for the new cards, because the new SDRs are going to be very robust. All right. Any questions on that? Okay. I think this is basically the same thing. Let me look here. Oh yeah. A lot of people want all of these combined on one. We give you the freedom through manual connections. We could automate this, but we prefer to keep it this way. So when you actually want to go to a single output through 4 cards, we do include a combiner in our system. Remember I said that earlier, combiner, cables, attenuators. We even send you a U-Blocks receiver, so you have a receiver. But the combiners, if you actually have an 821, you put 2 together on a single RF.
On the combiner, you output the same power.
Yeah, all we do is put these together. We don't modify the signal. So if you go in and change, let's say you make RF4 an interfere, and you want to amplify the interference, then these will stay normal. This will amplify the interference itself. So you can control the individual inputs with the simulator, but they're combined over the same cable with no manipulation in the combiner. No physical manipulation, just combining. Did that answer your question? Good, okay. All right. Another picture of the back, I already showed you that. And then again, I told you what comes with the box. So 3 attenuators, coax, USB cables. That's just the stuff that comes with it. And if you ever want to see all this stuff, everything's in the forum. We've even got a video called What's in the Box, just so when people get the box, they know what comes with it. So you have it. And then you saw this menu a while ago, setting up your own hardware. Up to this point, we were talking about our simulator. Setting up your own hardware. When you go in the Skydel and you choose the card, remember in the output where you guys chose none or none RT a while ago? If you went in and chose Deck Tech or you chose Edis Research and you hit add, a picture for that specific radio comes up in the software. So you know exactly how you're setting it up. You're actually kicking out, the live signals, what the IQ data is, what the signal measurements are coming out of it. It gives you the setup of that. And there's some very complex setups in our owner's manual or the user's manual. You can go in and set up an 842 with 4 individual outputs if you want. Or you can set up an 842 to a combiner. Or we can put simulators in series. We've done large circle and wavefront systems in chambers where we have 8, 10 of our boxes stacked on top of each other and actually be able to do robust stuff. So keep in mind, these are the building blocks that you can keep adding if you need to over time. Skydel will support it. The software will support it. more pictures of the hardware. I'm not going to spend much time on these unless you guys have questions. But this is that new product that I talked about. Because you can build this. This would be a neat little student kit. If you went out and got a Nook at a university level, or you wanted to take this home, I have about 30 people that I know who bought this during COVID because they couldn't go to the office and work, so they have this at home, in their home office, testing at home. Obviously, they're not modulating. But the little Nook, you can buy a little Nook online. You can get the SDR and the GPUs for it. You can build your own little system. And a Nook computer is probably, you know, when you guys are, some of us are older, remember the old metal lunch boxes you used to beat your sister or brother with? That's about the same size of an old metal lunchbox. You beat your sister and brother with it? They were good, especially with the thermos in there. But it's about that size. Right now, you'll notice it's only the broad SIM because we have supported the military by putting a classified signal on that. There'll be a Skydel version, I think, in February or March. Okay. Oh, I did want to show you guys one individual setup. I pulled this directly from the user manual to show you what I just meant to say. If you were to use an Edis radio, or you already have an Edis radio, you notice an Edis radio has different outputs. So we will always give you the configuration in our user manual and step-by-step guides on how to set it up with the PC. Again, you always have a good reference clock coming in to actually go to the receiver, but we walk you through the directions, and then you always get to choose, obviously, which device you're connected to in the output. You will see two settings that you don't have, wavefront and anechoic chamber. I didn't enable those for you guys because I didn't think if you had a chamber where we're testing SERPA, but if you do, let me know, and we'll jump into that. Those are very robust, complex setups because of SERPA systems, different wavefronts, different bandwidths, and so forth. And again, this is right out of the user manual. I copy and pasted this. So when you do this, you can go in the user forum and ask questions, but always check the user manual. It's okay. It's a good starter kit. It doesn't have advanced stuff, but it always gets you started. Okay, so what time is it right now? This was a. I was thinking this would go to almost lunch, which is good. Okay. So here's what I'd like you guys to do if you don't mind. I know this is a little bit weird, but I like to keep good records, and I have a terrible memory. So if you guys don't mind, those of you that work together, get together at each university, send me a quick email right now before we go to lunch, and just answer a couple questions for me, because I go back and I put this in my database. But basically, are you guys using this for research, education, or both? And it's okay if it's just one for right now. You're learning, you're growing. On the system itself, do you see the software only as what you're going to use? You thinking about building your own system? Or are you thinking about going to GSG8? And again, I promise I won't give this to the sales guys. That's not the purpose. The purpose is so that I don't forget. For each university, I have this information. And what are some of the applications? If you teach aerospace at the university, if you teach automotive at the university, I want to kind of understand a little bit about what you're doing. So when we talk in the future, we can make sure we think about what you're interfacing, because every use case is different. And let me explain this real quick. The way I test GNSS for a car versus a 5G cell site, completely different. They're different tests. For example, a car, one of the measurements that's really important is called time to first fix. When you come out of a parking garage, you want to see GPS quick, very first fix. A cell site's not that worried about time, it's worried about accuracy. So you check timing and accuracy to cell site, you check time to first fix at a car. And we see this in our car. How often are you driving and the GPS map in your car shows you on the side of the road? Okay, so let me know a little bit about your application, and you're not required to do this. This is just a request. When you get your permanent license, are you going to just use the permanent license? Do you think there'll be student or temporary licenses? And if you guys want me to, when you're ready, to put your plan together, I'll get on each university, each call one-on-one and go through what you guys are looking at, so we make sure we figure out what the education is doing. So just a personal request, not required. Any questions on anything from this morning? And again, this is in the presentation. Okay. I think I might jump ahead a little bit, if you guys are okay with this, and do one scenario, because I think the food's coming at 12:30, I think you said, or 1:30. Okay, I lied. Let's take a 10-minute break. All right, we're gonna take 10 minutes. So right now it is, let's just say it's noon, 12 o'clock. So we'll start 10 minutes after. Let's take a 10-minute break because I need a break. I was thinking it was lunchtime, but that's American lunchtime. Good. All right, so you guys online, we'll be back in 10 minutes.
Sincronización son las cosas. Bueno, más bien el argot es
Is anybody in here from IPN? What's your name? Miguel, is that it right here? Miguel, yeah, okay. And Robin, is that? Okay. You guys do have Skydel, yeah? Okay. Anybody here from UNAM?
I think they are remote.
Remote, okay. And anybody from UPAEP? Remote, okay.
Those guys over there, they are all in the same place.
Bree, you doing okay? Maria? That's not Maria. She left. I thought it was her.
You need only one answer.
Yeah, just one from the university, just one from both of you.
take a photo of the assistant for the press release?
Sure. That's not the software. You want the software? You want the software? You want me to send you a?
It's better.
You want me to send you a picture of it?
Yes, please.
Okay. So we'll do this. Or you want it up on the screen? I can go on the screen to see it. Settings. And I have many, many pictures of high images, high quality.
Well, the one with Dr. Carvalho with you,
Okay.
and other of all the participants on.
Okay. Set up a quick test. And there's something on it.
De hecho, yo estuve, no, tenía de la charla.
Is that something like that you want? And our marketing people have a lot of really good images, so take my card if you want. And if you want, just send me an email of any pictures you want. We have many, many pictures, and they're high quality images. And two, if you want, to go to our website too.
Also, for the participants for the check.
Or the participants. Well, I'm going to see that too. Okay. I haven't checked them all off, but those are the people invited.
Okay.
You can at least see the universities on the app.
Yes, I understand. Thank you.
Yeah, especially Strasse Deutsch. Yeah, I lived there for 3 years, and I can communicate really, really well. But if I read proper German or Hochdeutsch or Hochdeutsch, I have trouble with it. But I lived on the streets for 3 years and I loved it. When I left high school, I went in the army. I went to Germany for 3 years. Okay. So, but it was all bad stuff. You learn to order beer and drink food and chase girls and crazy stuff. And I can understand most stuff, but it's a little tough when I go away for a long time because my daughter lives right now. Okay. Yeah, my oldest daughter, she's 33 now, and she lives in southern Germany. So, you speak good German? Proper Hochdeutsch?
Hochdeutsch, yeah.
Yeah? Not me.
Ein bisschen.
Huh?
Ein bisschen.
Yeah?
Schwer.
Uh-huh. Mm-hmm.
Wenn ich so Dinge goes.
The problem I have is if I come to Spain or Latin America for 3 or 4 weeks, then my mind starts to adjust. And I just came back from Germany, so almost everything I'm thinking about right now is almost more either Italian or German. And I've never been great at languages, especially all the time traveling, but I can usually do pretty good. But Germany, if I don't go for 1 year, I forget it. It takes like 3 days for it to start making sense. So, and then I learned Kinderdeutsch because I became a father at a very young age. We won't give you the details. But my daughter, I was teaching my daughter to speak, and she was teaching me to speak when she was 2 years old. So a lot of the German that I speak when I'm around her is Kinderdeutsch. It's like we were a little kid or something like that, so it's pretty funny. Yeah, so Strasse Kinderdeutsch is my dialect. My daughter says when I talk, my daughter is half German, her mother's German. And when my daughter goes out in public, she goes, talk German so everybody can laugh at you. But it works when I'm by myself. It's just our family. We have fun. All right, let me get this real quick. Trying to get everybody's name down that's here. Carlos Perez. Okay, 2 minutes, we'll start. So to everybody on the internet, I'm going to go through this list really quickly. If you see your name, raise mute and let me know. So Rigoberto Morales, are you on the line? Ricardo or Jorge from AEM?
Here I am online.
Perfect. Thank you. Thank you
very much.
Ricardo or Jorge, are you online?
Yeah,
Yes, my name
Rigoberto
is Ricardo.
Luis.
Víctor García Garduño.
Gracias. Thank you. And then looking at IPN, is Luis, Victor, or Andres online? Andres just said he was here in a message. Okay. Victor or Luis, are they online? Okay. Yunam, is Jorge Perez online?
Yes, I am here. Also,
okay.
I installed Skydel successfully.
Okay, good.
Thank you.
And is Rafael or Jose with you?
Yes, we are here, but online.
Perfect, no problem.
Yes, Alberto Ramirez, I'm here online.
Okay.
Thank you very much.
No problem. And then UAZ, Victor or Jose? Anybody from UAZ online? Nope. Okay. Noah, so Rogerio, you're online. I've heard you. Carlos or Sergio, are they with you?
I'm here.
And that's Carlos or Sergio?
Carlos.
Okay, sorry. And Jose, you just came on from UAZ. I saw that. Okay, good.
Robert, I have Skydel too.
Okay. I'll send this list out afterwards, and if it's wrong, you guys can all fix it for me. I'll send it to everybody. And then UPAUP, I think I saw Luis was online, or no, that was a different Luis.
This is Charlie. I'm online and I have Skydel installed.
Okay. Is anybody else with you, Charlie? Is Luis or Hector or Enrique, Maria, Sandra?
Maria is here.
Perfect. Thank you, Maria.
I
And
have
Sandra.
Skydel.
Sandra is here.
Okay.
The last one, please.
Perfect. And do you guys
Also, Hector was on.
Okay. This is not really important. I just like to know who was on. So, and then, which of you guys do you guys have Skydel on some of your computers?
Maria have Skydel.
Maria's on fire. Maria's smart, isn't she?
Luis Felipe also has, well, is here and has Skydel.
I don't see it. Who's there? There you go. Good. Okay. And then Dr. Enrique Sanchez Lara is not here, correct? No problem. Okay. Muchas gracias.
You may see Oliver.
Which one?
You may see.
Oh, here? Yes, here? Okay. All right. Okay. So let's get some going here. All right, I'll go through the messages. I see everybody sending messages. Thank you. I'll go through all of those and double check everything. He is here? Okay. Good. Perfect. Okay, let's get started. Is everybody back? Okay, we're going to start going into details now. So a lot of the stuff that we're going to do is going to start setting up actual simulations and different types of simulations. And what I try to do is every time we do a different simulation, I try to show you one or two new things so we keep doing repetition. Two, I'm going to ask you guys through some of these to do some exercises where I don't tell you what to do. Just to play, practice. You can't break it. Trust me. No one can break this. If you do break it, then we'll just throw your computer away. It's not a big deal. All right? All right, so everybody online, hopefully, I haven't checked. You can see my presentation. It's a big airplane that says creating simulations. Okay.
We can see your camera.
My camera is on. Nope. Okay. All right, so let's talk about building simulations. First off, I can't say this enough. Most of the questions you're going to have the first month, they've already been asked. They've already been addressed. They've already been part of stuff that other people have done. So I know this sounds like a little bit like a child, but use your resources because there's probably a really good chance the information's already there. You've got videos, some really good videos out there. You've got some application notes and things that are written, documents that are there. You guys all have access to this training document, which goes step by step and so forth. And these videos, like I said, are good too. And then remember, inside Skydel, on the bottom there, you've got the user manual. You've got information. You've got access to the forum itself. So use the stuff that's out there. If you can't find the answer, of course, let us know. But our hope is over time to build this so more and more and more you learn on your own and grow on your own, because we think with more students getting in, things like that, it's really important. All right? So with that, let's get started on this a little bit. And I've mentioned some of these before, so this is a little bit of a review because I jumped ahead earlier, but I do want to explain these a little bit. So you're welcome to follow along in Skydel if you want. So first off, like I said, you're always going to start top to bottom, left to right. You're always going to start in settings. You got to set up a test before you run a test, okay? And then you configure your output. And then number 3, define the output. And there's a couple of settings here that you may have not seen before, but I want to break these into 3 categories to make it easy. First category is no radio. That's where your none and your file and your none RT actually do not require a software-defined radio or SDR. You can run these on the computer, but none RT requires a GPU. Exactly, thank you. None RT requires a GPU. These do not. And I'll explain those in detail a little bit more, but it's easy. This is on your simulator. This is sending data to files, and I'm going to show you how to log files. You can file the Orionix data, the NEA data, the raw data, a lot of different data. 2 is a commercial radio, and these are almost always the numbers. That's the part number of the radio itself. So DTAs or DETECs, I think those are Edis Research, and those are National Instruments, if I remember right. Those are the main 3 that we work with. We often get questions where we work with other SDRs. We prefer not to, just because we've tested probably 100, and a lot of them are not high-quality outputs. And our concern is if we don't have high-quality SDRs on this, then you're going to say that we are a terrible company when we're using COTS products. So we highly recommend you stick with the radios that we require or specify. You can work with other radios, but you're going to get nominal results. We know it for a fact, all right? But these are the main 3 that are out there. Anywhere DECTEC does a good job, Edis Research and National Instruments. And there's a good chance some of the universities might already have these already out there. And, yes, sir.
And what about the ETUS N220?
I don't know. I have to check the list because I have a full list of all of them and then how good they are. I'll check the full list, see if I can come up with it. I don't know it off the top of my head. But I think they should lean towards the better, newer ones, but we can check it.
But if the last release does not work with the last models, can we upload older release of the Skydel? And probably they could work with the...
Let me check on that. I don't want to lie to you. I don't know is my answer because I haven't been here to the whole history. I've only been to Orolia for about a year. So write that question down and send it to me. I'll get you an answer. Or put it on the forum and the experts can answer it right away. Yeah. I don't want to lie to you. I don't like to lie. Okay. I tell lots of stories, but I don't lie. And then the 3rd category is large systems. So remember, we support very robust applications. So this is a full anechoic chamber that might have 16 antennas in the chamber, or 32, we just did one for that, or a SERPA or wavefront controller type of system, we do those. You may or may not see all of these. You should have none RT and file as a minimum, and then probably the cards themselves. But I don't think I enabled anechoic chamber and wavefront for you guys because I didn't expect it. But I have no problem. If you need it, just let me know and we'll talk through it. All right? But you got to choose this because everything bounces off this. Remember that I showed you earlier. None and RT, none and none RT look very, very similar, but the question came up. I didn't get a spectrum plot on that. So the best way to do is just play around with it and work with it a little bit. You'll learn the differences over time. All right, so setting up your radios. These are just quickly what happens on each of these. And you're welcome to go in and see this. If you click a COTS radio, that stands for Commercial Off the Shelf, DECTEC or Edis Research, we always launch a window showing you how to configure it or set it up, always. Large systems, there's a long process on this. If you're going to add 16 antennas on the long process, then we actually typically help you and we load a file and we send you a configured file that you load with all of it on there. That's why it's looking for a menu, but it's had 3 steps, and these steps are in the user manual. But realize when I just change that one button, it changes what happens after that. So it could get confusing. That's why it's so important. None in RT, we talked about that. You're going to use that a lot today. So we run a lot of our tests on none or none RT. Then you can simply add your outputs like we did earlier, where you add your outputs in there. And then last but not least, we're going to run through this exercise later on today. But if you click File in that download, you got to tell it where you want the file. So it launches a window in the menu on your computer and says, where do you want to drop the file? So most of it's pretty intuitive, and we try our best to put things in there to make it launch something. Where it gets you confused is when you press the wrong button. So if you want to actually do a radio, but you do non-RT, then actually you try to run it, it's not going to run properly. Never get to the radio. So when I went back to that previous menu, I know it sounds really childish or small time. Go through the process. Start with your settings, go to your output, always go straight down to your output type. And then you're actually in pretty good shape. 99% of most things will work well after that. But if you start off wrong, you're going to have a little bit of a headache. Pretty easy, I think, right? Okay, so just remember that flow. Left, right, top, bottom. Okay, and again, we did this earlier, but I just want to walk through it and know that you have this resource here for you. Once you get that output chose, then you add in the quantity of outputs that you want. I have a bad habit. I will call these radios a lot of times. It's my bad habit, I admit it. Because if you're in the none mode, there are no radios. So this is more your output or your radio that you're adding there. And again, you can add, depending on your interface, add the amount that you have to transmit. So for example, if you have an 842 from us, then you have 4, because it's 4 SDRs. If you configure your system and you have 2 SDRs, then you can add 2. So this has to match your network configuration. On our product, if you have an 821, which is 2 SDRs, and you add the first 2, when you click add the next time, it won't let you, because it's all programmed in there. But it could get confusing when you build your own system. So just know that. These outputs are primarily frequency-based. I'm going to reiterate that later. For example, if you're running in the L1 band, that first radio, if you set it for L1, then you can choose all the constellations in the L1 band. We combine L2 and L5 and call that lower band, and we're going to use this a lot when we do our testing. In fact, I'm going to probably constantly ask you, change this, change that, just to kind of get you thinking of going back to that. All right? But that's adding your different outputs themselves, and once you add it, then you can actually go into it and edit it specifically. So again, settings, output, add your output in, add the specific number of outputs or radios you want, and then set up each radio for that specific configuration. Whether it's L1, L2, interference, it's actually going to flow through it. So if you follow the numbers most of the time in the slides, it walks you right through it pretty quickly. And this will become second nature for all of you. Some of you probably fly through it already. All right, and then we get to that window that I talked about. You guys were in this a while ago, and this is what I just mentioned. These outputs are band specific. L1 band is your L1 frequencies, and that's why you have your GPS L1. Galileo E1 is in the same band. GLONASS G1 is in the same band. And it's okay if you want to choose multiples in there. It's no problem to do that. Your lower band, obviously, is your L2 and your L5, and we combine those. So that gives you a little bit of optimized performance because you can have 2 bands running all 3 frequencies because they're actually in the same bandwidth itself. Okay? And last but not least, we're going to do this later on when we get to the interference section. It does not have to be GNSS. It can be interference. So if you want, you can take a card and dedicate it to be a jammer or a spoofer or to be interference. No problem. I'll show you some scenarios where you can have 2 dedicated cards. A good spoofing attack requires a jammer and a spoofer. So basically what happens is the receiver, say you're driving a car and someone wants to spoof you. It's very difficult to just spoof. Normally what you want to do is disrupt that receiver. So most good people that know how to do this, they jam the car first, and this receiver loses its signal. After it loses its signal, they introduce a spoofer, which is a fake signal, and then they open up the spoofer. The GPS receiver was offline because it was jammed. When it came back on, it saw the spoof signal, thought that was the signal, and then took that route or used that signal. So a lot of times when you do spoofing, it requires a jammer and a spoofer, and you can actually have each one set up for a different card. Another scenario is this happens a lot in marinas. If someone wants to jam boats coming into a marina, they might have 3 jammers in different locations to give different signals and block it completely, because the jammer has so much power to go such distance. But a large marina for boats could be very, very large. So keep in mind, this could interfere, create whatever you want. I could even have just 4 jamming signals and no GNSS if I want. Use live GNSS, let the receiver run on live GNSS, and then I test different ways of jamming. That's up to you as the user. Each output can be whatever you want it to be based on that specific test. So does that make sense, or is that confusing? Make sense? Okay. Point being, you set it up the way you want. And when we get into interference in a little while, you'll see there's an easy way where you just choose interference in a band like GPS L1, or someone asked earlier if you can define the bandwidth and the actual center frequency. And the answer is absolutely yes. No problem. And then remember, I'm not the smartest person. I forget things. I didn't show you this earlier, but under each of the actual settings, each card, there's an edit to configure it, but there's an edit if you want to name it too. So I'll do this for you guys in a little while, where I might name this L1, I might name this L2, and I might name this jammer. So I know what it is. So when I'm running my test and I go to my spectrum plots, it always has the name as well as the radio number. So you can identify or just give it a name by clicking edit under non-RT1 or non-RT2. You can change that. So there's a lot of neat little things like that that you can do. Again, pretty easy. We did most of this earlier, but I wanted to walk through it in a flow for those of you that maybe struggle a little bit with it. Next, testing the GPU. Should sound familiar. All of you can test the GPU. I don't even think I'm going to walk through it. But remember, I don't know why I have 2 2s there. I guess they could do it twice. But on this one, remember, you can change your satellite counts. And one of the exercises I'm going to ask you to do is to set up a configuration and tell me where the cutoff point is between good and bad for your GPU by changing the counts. Again, remember, the higher in elevation, the more satellites you might need. The lower, the less you need. So if you're on the Earth, you might only need 8 GPS satellites. All right? Depends on where you are. So I think we did every one of these things earlier. I'm just looking at the slide. We did that. And remember the score, it's not that important, but if it's 1 or above, it's green. If it's like 0.95, sometimes we give you a yellow color. But you don't have to remember the number because we color code it for you. If you have trouble with green and red and yellow, let me know. There's remedial training at the bar later on. All right, any questions on that? Pretty easy. Okay. So here's what I want you to do. And I'm going to play dumb, and I want you to do this on your own now. I want you to create an exercise. On those of you that do not have a GPU, that first setting should be none instead of non-RT. But I want you to set up a basic test with the following. The first one, I want it to be none. You're going to need to have 2 outputs and radios. And actually, when you do that, you know what? This isn't going to work because you guys don't have GPUs. Remember, right? Yeah. You already saw me do this earlier, right? Where we tested the GPU. If you have a GPU later, this is just basically talking about a basic configuration and a maximum configuration. I knew I did that earlier, long ago for a reason. But if you want to really have some fun, go in there and really stress it out and play around with the settings a little bit. But always check this, please, because I don't want you to start a test through your GPU and you overrun the GPU without checking that out. So if you're going to do a robust test, check your GPU is the point to be made. And I showed you this earlier, so we won't make you do the exercise. Uh-huh.
You don't have
You have no GPS L5 in yours? Okay. So we'll get you set up with L5 now. It's no problem. Did you go to lower band though? You sure? Do you mind if I check behind you to verify? I don't think you've made a mistake, but I'm going to check. Is it okay? Go to lower band. Okay, so do that outside.
radio. Lower band. Sure you don't want to get somewhere? Yeah, so I maybe did not make this very clear. You have to choose upper band and lower band. In fact, let me show it to you since there was just a little confusion on it. I'm going to start Skydel real quick. Those of you online, you should see my computer screen with Skydel running now. So my apologies, it's my fault, it was not yours. So when you want to choose the different signals, you have to choose upper band or lower band first. Upper band is all of your L1 frequencies. Yep. So I didn't explain that, so blame it on me. Lower band is L2 and L5 frequencies. And interference, while we're on here, I'll just show it to you. Interference gives you an option. See this little box here that says choose with signal selection? If you just want to create a jamming signal in L1 band, you can actually just click that and choose L1 if you want. Or if you want to create a specific frequency, you can choose your center frequency yourself, and you can actually do the maximum minimum as far as sampling rate on that itself too. And if you have more than one GPU, you can even specify the right GPU. Because a lot of people want GPUs separate from, or their interference separate from their signal.
Robert, the definition of interference is just a unmodulated carrier at a certain frequency.
We will define it later. There's a separate menu. This just chooses the frequency band for the interference. I'm going to show you how to choose it later. So you could do like BPSK or different types of noise levels. And I will show you that later on in the training.
Thank you.
Very good question. Yeah, so my apologies on that. I don't think I showed you guys that earlier. That upper and lower band is how you choose L1 or L2 or L5. You cannot run upper band and lower band on the same card with DEC Tech, just because they're different frequency ranges. I think you can on Edis Research and National Instruments, though. Good. All right. Back to the presentation. So we're not going to do that exercise because we did it earlier. And remember, you have to do this on none RT. So my mistake, I'm sorry. We're going to get into some new settings now. But I haven't shown you that. They're easy. But remember, I can run any test, past, future, or present. So your second icon actually shows you this. In fact, I'll just go to Skydel to make it easier. If you're in Skydel right now, and you have a test set up, so right now I have set up to run GPS L1 and L2. The second menu option is called Start Time. So if you go into Start Time, you have the ability to change this, and it's pretty easy. If I want to run a test, I'm going to do my birthday. You guys write this down and send me presents, okay? If I want to run a test next year, February 23rd is my birthday. Did you write that down? February 23rd is my birthday, all right? And I want to make it for 11 a.m. So now my test is designed to run on February 23rd, 2022 at 11 a.m. That's when it starts. And I can go forwards or backwards. So if someone said there was a problem last week and I want to test it for something that happened in the past, this will go backwards too, no problem. So I could do this in the summer, June 10th, no problem at 11 a.m. It will put the satellites where they're supposed to be for that date and time, all right? And if you're a geek and you want to know which actual specific week that is, because GNSS has week numbers, you can see the week numbers as well as the seconds and leap seconds if you need to also. So that's option one, custom time. Option two is set it the same as your computer. So if you want this to run on the computer, right now it's going to run whatever time my computer says. So right now my computer says it's 11:23 and it's on East Coast time. It's 1:38 p.m. That's what my test is going to run. Pretty easy. All right. Or thirdly, if you want it to be, I hate using this word, if you want it to be a slave or run off of receiver time, you can do that. So if you're testing a receiver and you want the receiver to set the time, we will go from the receiver and what time is on the receiver itself too, which is pretty common sometimes, all right? I'm going to have you guys using 2 of these settings today off and on when I actually have you run different scenarios. I might tell you to set up a test for last week or tomorrow. If you need to test leap seconds, does anyone know what leap second is? Someone tell me what leap second is in GNSS. I think you all know, right? Every once in a while, they have to adjust GNSS time because the time is not perfect. So if there's ever a leap second, it's always published out there. There's leap seconds. And when there's a leap second, there's a correction. You should test a receiver to make sure it can handle the leap second in advance. What happened, there was a leap second change or a date change about 2 years ago, and a lot of people didn't check them. And when it actually came to the real time, the receivers failed. And there were thousands of receivers in the field that had never been tested, and they never downloaded the new code from the manufacturer. So Novatel and Trimble and all these companies, they send out code updates a lot just for the leap seconds. So you can check leap seconds themselves also. But there's also one down here that I'm going to have you using today, which is running a test for a specific period of time. So if I want you to run, I'm going to give you a very good example. I'm going to actually later on have you guys run a test to file. And the thing I'm going to ask you to file is IQ data. IQ data will eat up space in your computer fast. IQ data is very, very, very large files. So I'm going to have you do a test later on where I actually have you capture IQ data in a file, but I'm only going to ask you to do it for 15 seconds because it's still over a gig of space that it uses on that. So you got to think about that. But this is if I just want to run a test for an hour, or if I want to go to run a test for 2 hours, and after 2 hours I want it to stop and reboot it. You can do things like that. So this just controls it. It is defaulted at unlimited. So to explain why this worked earlier, the defaults are a custom time. I forget what we put in here as a custom time. The default is unlimited, so it'll run until you stop it. So that's why that worked later without you setting it up. And it's not required to set it up. But if you want to know how, for example, the military is going to do a deployment, and they're going to take helicopters and they're going to run them in another region or test flight next year. They need to test for next year or during that test. They test now, it could be different. Next year, those satellites are a completely different location. So you should always test for the application. Another example is if someone's going to deploy a 5G cell site, they should test the 5G cell site on the date they're going to install it, not 3 months earlier in a lab in a perfect world. Make sense? So very, very easy to set your start time, not complicated at all. Any questions on that? Okay. So now we're going to get to the complicated ones. Click on globals, the next menu option down. If you didn't see it, I'll go back again. So we talked about output, then start time. Now we're going to talk about global. Global is exactly what it says it is. It is global aspects of GNSS. So this is where you actually control the atmosphere, the troposphere, the ionosphere. This is where you actually can go in and change the orientation of the Earth. You can also set your signal levels here. So I'm going to run through each of these briefly. There are a lot of details to these, but I want you guys to see what's in here so you understand them a little bit. And all of these, again, are in the PowerPoint presentation and the user manual. So the first thing is the atmosphere. If you haven't worked a lot in GNSS and these are confusing terms, it's okay. Yep.
Come back to the number 18, the leap second. From where that number comes from?
What's that?
From where? Number. Why the phone number 18 is the second
It is the default or the standard that's there. I don't know. I have to be honest with you, I don't know. I can get you an answer, but I don't know why it's 18 as a default. Because that's the right one. I don't know. I'm not. That's a GNSS question that I don't know, but if you want, write it down. I'll get you an answer for it.
Okay.
Yep. Nope, I apologize. I always told you I wouldn't lie to you. It's okay to say I don't know. It's not good to lie. Okay. Back to the atmosphere settings. So in case you guys get lost for a second there, we went to output. We're in global now, and I'm going to run through each of these and explain them briefly. And there are some things in here that I have to admit that I can't explain every detail of. But remember, that satellite for GNSS is typically about 20,000 kilometers in the air. So most of the models that we're dealing with have to do with the troposphere and the ionosphere. So we have the standard models in here. But here's what's really cool. You can change these. So under troposphere, there are standard models that you see in any simulator, which is the Sastemonian and the Steneg. You also have a model called the DO229, which is a model that's required for airplanes and drones that they test those with. So it's part of the test there. And you can leave that for none if you want. This is the model of what's happening in the troposphere under normal conditions. The same on the ionosphere. You can actually do the curvature model or a spacecraft model if you're in space. But a lot of people like to change this, especially research scientists. A lot of people at Qualcomm or somewhere designing chipsets like to change these. These are the models themselves, and please don't ask me to explain these because I'll tell you I don't know them really, really well. But you can import all these parameters through Rhinex data to change all of these. So maybe some of the doctors at the universities and so forth that are on the line are probably really good at these things. We are also working on some newer models. There's some models that are out there that you can actually download and use. So we're going to be adding some new models in here. But keep in mind that that gives you the basic capability to change the atmosphere parameters as well as errors through the atmosphere. And this one will blow your mind, so I'm not going to get into detail. But I can literally go into the actual visualization of the actual globe, and I can literally go in here and edit, and I can change the parameters of each of these through a model that allows me to take the entire globe, and if I'm actually going to be doing tests in a certain region, like let's say, for example, I want to go down here close to the equator, or maybe over top of Brazil, and I want to change the models of the atmosphere in that specific region, I can. And I can literally go in there and change those models to be something different. And again, this is a very detailed test, so I don't expect you guys to all have to stress over this, because normally it doesn't get changed. And then I can actually go back and actually change the environment itself. It's based on how much signal degradation and things like that. If you need to do this, go to the user manual and it walks you through that. But what I find is normally when people do this most of the time, these are pretty experienced people that go in and start changing these models. And a lot of people that change it also do air balloon research too, where they take weather balloons way, 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 way up in the atmosphere too. So if this is a little bit confusing, I'm not expecting you to actually set these today. I just want you to know it's in here. And this is almost always covered in our advanced training, so that's when the engineers come in and train you. If you want to change the orientation of the Earth, you can. You can import models. We have a ton of models on our GitHub atmosphere if you want to change these. That's the orientation of the Earth. If you don't change it, it works perfectly because it's normal conditions. You will be using logging today. So the first two, I don't care if you remember, but this one I do. When you're doing your test today, I'm going to ask you to log data at certain times. So you've got the ability to log all data, which is great for students. You're teaching students and you want them to see all the data that comes out of satellites because you're teaching them the message format and everything. You can. You can log all the NMEA data if you want from the simulator. Remember, we give you the ability to get to the receiver and get the NMEA data from the receiver also. But this is how we do our deviation measurement. Remember that deviation tab earlier? We monitor the NMEA data on the receiver and compare it to the NMEA data that we're transmitting. But you can save that in a file in your computer if you want. Rhinex data, you can save it, and Rhinex is the receiver, I forget what the acronym means, but that's your Rhinex data. Or if you want to actually go in and do hardware in the loop testing, when you set that up, you can save that too. But the point being, you can download, you can log any data to a file. So whether that's a CSV file, or whether it's a specific format for that technology. For example, IQ data is in an IQ file. Excel, Word, none of those read those IQ files. You have to download a software package. Normally it's a paid subscription to download those. The one I use all the time is this, what's it called? Something Magic. File Magic will actually pull up any type of format, like there's thousands of formats there. But remember, logging is logging of global information. Signal level, I can change signal levels here, but where else can I change signal level? You guys remember? The slide bars on the bottom. So if you want to do an automated test and you want to script a bunch of stuff and you want to have different things changed, you can do it that way or you can do it manually. It gives you that option. And last but not least, you'll only use this synchronized simulator setting when you actually put two simulators together. So if I buy two GSG8s and I put them together because I want 8 RF cards and 4 GPUs, then you have to synchronize the receivers or the simulators so they have all the common settings. So again, I don't spend much time on those. These are in the slides. It is one of my weakest areas, if I'm being honest with you guys. I think you've seen that. But that's the detailed capabilities that are there. And all of these are explained in the slides that we were talking about earlier. And if you guys do go to the advanced training or ever want to get the advanced training in person, our engineers spend a lot of time on this and actually make a lot of changes to these. All right? Any questions on those? I know they're fast, but you get an idea why. Is it close to lunch yet? Not yet. Okay, one more setting, and then we're going to take a break and call it lunchtime. So in your left settings, click on settings and go backwards to settings again. And now I'm going to blow your mind. You ready?
Okay.
If you chose GPS, which you did, I can change everything about that GPS signal. We have the default settings. So if you said that you set this for GPS on February 23rd of next year, everything is pre-populated for that specific time, from the signal strength to the messages to all that information. But we allow you to change everything, every aspect of GPS. So whether that's the actual messages inside there, because there's specific messages, and if you teach GPS, you can teach all of the message formats themselves. This is great for students. The order of the messages, you can change the sequence. Because remember, GPS is just a one-way communication link with messages inside of it. You get the signal. It's a really weak signal, but you get the signal, then you start to interpret the messages. You can change the messages. You can change the pseudo-range offset. You can even change the orbits. You can force a satellite to go in the wrong place. It happens. There's a reason why there's control centers for GNSS, because they have to do course corrections on the satellites every once in a while. So you can change the orbits. You can change the perpetrations if you want, which is actually the angles. You can change the signal control. You can change the health readings. A satellite transmits good health or bad health to it. You can create echoes here, commonly called multipass. If you want to create three of the duplicate signals, you can, with maybe a slight delay between them. So for example, right here in this city, this is a glass building, right? GNSS signals will either reflect or refract off this building. And when the car is on the ground, it might get 3 of the exact same signals with a slight delay in it. So you can create that environment if you want, where you can actually send a bunch of multipass signals to see how the receiver deals with this. We've even had to do this on the International Space Station. We're working on the International Space Station project, and the Canadian Space Agency created the robotic arm that goes on the International Space Station. And when you dock in and you bring a spacecraft in, or something that the arm reaches, there's literally reflections off the space arm or the spacecraft. So we had to build all these models for the International Space Station where you wouldn't expect in space to have reflections, but the arm on the space station or the incoming spacecraft literally had reflections off of it. And they need accuracy to the nanometer level if they're going to grab hold of a spaceship in space with that arm. So it's pretty cool that you can do this to that level. But you have those capabilities. We're working with, you ever heard of Zagazig University in Egypt? There's a professor there, I forget her name, it's a female. Huh? She actually has built models for cities and echoes and things like that too. She's doing urban environments. So you can do ray tracing and there's 3D models and stuff, but she's doing some neat research in Egypt on that also. So she's got an OAP license too. So those are the things you have the capability of getting access to. You can disable a signal. I can literally turn a satellite off if I want. So all of a sudden the Russians launched a rocket, knocked a satellite out of the sky. What happens? You can turn the satellite off if you want. Transmitted PRN, you can inject errors or even adjust the antenna types on the actual GPS system. I'll show you how to change the antenna on your vehicle later on. If you're doing a car test, you can set the antenna on the car. But these are everything, and it's a little bit interesting because they're not all the same. GPS is American. We do things one way. GLONASS is Russian. Their stuff's quite different. So their menu options for GLONASS are a bit different because of what's inside of the GLONASS payload. The same for Galileo. So I know this is very, very detailed, and we won't spend a ton of time on this today, and I will not ask you to change these today because all the default settings are normal conditions. But you do have the power to change everything in that pattern, in that signal, in that data messaging. And there are instructions in the actual manual for that. Even QZSS and the navigation signal have that also. So the majority of these settings, from GPS down to navigation, those are all specific settings for each specific constellation. One rule of thumb, and I've done this, I've literally had to go in and change a setting in Galileo, but I forgot to set Galileo up on the original card, and it drove me crazy for 20 minutes. So make sure if you're changing something, I know it sounds really, really dumb, but only because I did it, but maybe it's because I'm dumb. But I literally changed Galileo settings, but I never had Galileo enabled on my output, so it never took effect. All right, any questions on that? This is used a lot in research. But normally if you're just testing receivers or testing vehicles and stuff, a lot of people don't use it. I would probably say 10% of most people that use GPS receivers change those settings. Yes, sir.
If you change something settings, you are changing the default value.
Yes, sir.
So make sure that you want to come back to the...
Right, but if I close this out, so let's say I'm running a test, and I decide to choose to close out Skydel. If I chose out Skydel, it will ask me if I want to save those changes. And if I change them, I save them to a file specific to that date or time, or I can save them as a certain file format too. So I name that file. So if I was saving this file right now, I might say Mexico training, if I could spell, 3. So now those configurations are only in that file. So the next time if I start up Skydel, and I say, wait a second, new configuration or open configuration. New configuration goes back to the default so you don't make a stupid mistake. To pull up that one that I just did that maybe I changed, I have to open configuration and go find it. So hopefully the chance of you changing the default settings are only changed in the file you saved. If you do a new configuration, it always goes back to default. Because we're human beings and we all screw up. Except for Maria, you don't screw up, right? No. All right. Any questions on all of those? Because when we come back, we're going to do a lot of settings. And I'll give you a little bit of a preview on what we're going to do. When did they say lunch was coming? I keep forgetting. 1:30? Huh? What time is it now? Okay. So we still have time then. I should just keep going then, right? Okay. I'm good if you're good. I can talk all day. Okay then, let's do some tests. All right. So I'm going to talk about the vehicle menu itself. So in your settings, go down to vehicle. We will make a lot of changes in here today. This is the specific vehicle that you're testing. By the way, my cell phone is considered a vehicle. It's something that carries GNSS. A car is a vehicle. A 5G cell site is a vehicle. A boat, a drone. This is anything that you're testing the application itself, okay? So with this, I don't know if the vehicle was the best word, but I think we all understand why we used it. You have the ability to do everything from a non-motion to circles, to make a map, to go around the earth. All of those are things that we're going to do. So we're going to set up a very basic scenario right now, which is no motion. And I'll show you the slides in a couple of minutes. So under vehicle, you have 3 settings. You have the body, you have the antenna, and you have the elevation mask. We're going to start with body because we always start left to right, top down. So we're going to click on body, which is the default setting. And over here, if you move to the right, you have a pull-down menu. This is going to choose what you want to do. We're going to do all of these separate today. Each one of these is going to be an example that we run through. But let me explain them really quickly. Fixed means no motion, static, stays in one place. Circular is the circle, pretty easy. Track playback means you're going to pull data from another file or another system. So for example, there's all kinds of programs for automotive out there where you run a route in the car and you record it and you save that data and you bring it back and you play it back. We can accept that data from other systems or files if you want. All right. This also works in some automotive systems or flight simulators also. Vehicle simulation. You're going to map specific routes. Who here does not know how to use Google Maps? I think we all can use Google Maps. So if you wanted right now, like when I take my Uber home tonight, I don't trust Uber. So I always go to Google Maps and I'll say I'm going to route from here to Marriott Reforma. And I'll watch it. But we always do map from here to one address to another. That's exactly what vehicle simulation allows you to do when you do it later on. You'll be able to map from one city to another, and it'll actually map it for you, and you control the speed for a car drive. Okay, and we'll do that later. Hardware in the loop is a hill system, or hardware in the loop. So someone mentioned that they actually had this with the university in Madrid. Actually had a hill system. So if you're working in a hill system or a hill device, like a device called DSpace Scalexio is a common hill device, then you'd set it for that. And then lastly, Earth orbiting spacecraft is exactly what it says it is. We're going to do this at the end of the day, where you're literally going to actually map a satellite around the Earth and run that route. But for right now, we're doing it easy. It's fixed. Once you go into fixed, hit edit. Everybody should see something now that had latitude, longitude, altitude, and so forth. If you want to test a specific location and you know that latitude and longitude, you can. But there's a really cool feature. Do you guys see the crosshair in the middle of the map? Everybody see that? If I want I can put a latitude and longitude by the crosshair. So the map is movable. So I am going to move to Mexico. I'm going to go down to Mexico City. And then I'm going to zoom in a little bit. And then I'm going to move my mouse around. See if I can look at those crosshairs. You can zoom in. And I'm going to put a fixed location. Let's say it's a 5G cell site. Right there where those highways come together. You guys all see where my mouse is? Everybody online see this live where I'm actually moving the map? If you do that, you can then go up to the top and click Use Crosshair Position. If you click that, your latitude and longitude will match where your map is. Everybody see that? So move it again if you want, and say you want to put it somewhere else. I'm going to zoom in and go to another location. Let's put it down here at this location. If I say this is a cellular site that I want to put at the end of that location between those two highways if I want, I click Use Crosshair Position, and it automatically changes my latitude and longitude. Because remember, there is no motion, this is fixed. You do have the ability to change the pitch, the roll, and the yaw. It's not used very often in a static fix. That's basically when you take a vehicle and a vehicle's moving, the pitch, the roll, the yaw of that. But can you think of a fixed location where that might be needed? Anything that's static but might move a little bit? Huh? Could be a drone. A drone could be hovering in a static but moving a little bit. Could be. Believe it or not, really, really tall cellular towers on a single monopole, they move a little bit. So we still give people the ability to change that if they want, but it's not common. Yep, altitude there too also, so you can change the altitude itself too. So I'm looking at some of the messages. Let me make sure I saw the messages online. Yep, James is floating, changing altitude. You're right there, exactly. So anyway, you're allowed to change these different settings if you want on these altitude drones, but the map is what confuses people a lot. And I don't think our user manual does a great job of explaining it. But if I wanted to, let's say I wanted to leave Mexico, you always see the little map in the top corner too. So if I wanted to, I could take this clear down to, let's go to Brazil somewhere pretty easily. I can change this anywhere I want on the globe. I can go over here to South Africa if I want. All the standard maps should be in there. So now we're zooming in. There's not much there. Let's go down here south a little ways. So now I'm on the coast of South Africa, or I want to do something out in the ocean. I want to actually do a buoy. That's actually a really good application for a static device that moves, a buoy in the ocean. They have GPS receivers, but a buoy moves back and forth, up and down based on storms and stuff. So I forgot about that. That's a good application too. All right, so pick a location. Why don't you pick your house? It won't be precise, but go pick a location for your house. Let's make you choose something specific. Or your university if you'd rather do that, or where we are now, but go pick a location you want. I'm going to make my house, but don't you guys come visit me until you bring beer. So play around with that for a couple minutes because it takes a little bit of getting used to. Go find about where you live or your hometown. In case you guys want to know where I live outside of Charlotte, North Carolina. I live on what's called the Redneck Riviera, which is a lake. They call it the Redneck Riviera because that's where NASCAR people, you guys follow NASCAR racing? I don't, but there's a lot of NASCAR people in Charlotte area, so they have the really nice houses on the lake. I don't live on the lake. I live up here, a little further north. That's what we've been looking for. All right, so I have selected my house address. Very, very important step. If you leave this window, make sure you click OK. I think they're supposed to fix the bug, but there is a bug. If you just exit the window, it doesn't always save your settings, so just make sure you hit OK. So does everybody have a location selected? Use the crosshairs and hit OK. OK. All right. Follow me here. We're going to go back to settings. And we're going to set up a quick test. So I'm going to add a radio. Let's just do GPS L1. And I'm going to have you guys do an exercise on this in a little while. All I'm going to do is give it a GPS signal to show you guys where the map's going to come up in a second. So none or none RT, it doesn't matter. GPS L1. And I want you to click Start. If everything worked well, your map icon on the left should now be the location you chose. So I chose my house outside of Charlotte, North Carolina. So if I zoom out, I am now testing in that specific location. But remember, I set this under static. This is my live test right now. I'm setting a location. If I had a device, if I took my phone right now, took it apart, hooked up the antenna, my phone would think it was sitting in Charlotte, North Carolina. It's a fun joke to play on friends, but don't do it anywhere else. Yeah. So does everyone's map showing that specific location? So right now you're literally running these satellite signals in that specific location, and it's not moving. Later on, we're going to put a car on the road, and you're literally going to see the car driving, and I'm going to make mine go really fast. I'm going to do like 180 kilometers, so it goes really fast. But you literally just set up that test. So the test we're going to do when we come back from break in a little while is we're going to have you guys go in and set up one of these tests from the ground up, but I'm going to ask you to set a specific time, a specific date, all that kind of stuff to start to use all of these things together. But I think static location is pretty easy to do, and there's no motion, but it could still be a jammer in a static location too. If I wanted this to, instead of that being GNSS, if I went back to my settings, and instead of GNSS, don't do this, I went in here and I said, I want this, instead of being GNSS, I want to be an interferer, and I want that interferer to be in the GPS frequency. That is no longer a GPS signal, that's interference. So this, and literally, if I were doing that right now, this test would not be giving you GPS in that location. That test would be sending out interference in that location. That makes sense? Good. Any questions, comments, anything from this morning that's confusing? So far this morning, you've learned about the OAP program. You've learned about all the tools and resources and everything on the forum. You've learned the basics of how to use Skydel. We walked you briefly through the hardware and how to configure our hardware or yours. And now you just set up your first test scenario, which was a static fix at a specific location to generate either GNSS information or interference or jamming in that location. Pretty easy, isn't it? You guys feel like experts yet? Almost. Remember, everything that I have just shown you, I'm going to show you the slides real quick so you know I'm not lying to you, because remember, I tell stories, but not lies. So everything that I just talked about is in all these settings. Let me scroll down to setting up a scenario. This is the static scenario. So these are the steps that we just walked through. If you forget this, shows you how to walk in, choose the vehicle, choose static position, how to use the crosshairs if you don't know the latitude and longitude. And this will be the exercise you get to do when you come back from break. All right? Any questions? Because I tell you what, this American is hungry as can be. I didn't eat breakfast this morning, so.
There's a question, Robert.
Yes, sir.
The vectorial map, is a 3D map or is a 2D?
It's a 2D map, is what it is. We do interface some 3D maps. So there's a software company called, I think it's French. I think it's called Octo. There's a couple of 3D packages out there. We will provide data to the 3D packages, and those 3D packages will actually import that into a 3D model if you want. But we only do 2D here. You can do elevation in the settings, but we don't actually throw 3D buildings and all that stuff. Good question. Any other? How about online? Any questions from the guys on the web? I'm looking at the chat window real quick to see if there's any questions. Rogerio, you can see spectrum, but you have to be a non-RT. If you're a none, remember you can't see it, and you have to have a GPR or GPU, Rogerio, to run in non-RT. Again, Jose's same question, spectrum, I think. I'm just going through the questions online real quick. All good here. Charles says he's good. I am not under, let's see what Rodrigo's saying. Let me go back to my settings. Settings, output. I am under none on mine, Rogerio, and it actually shows no spectrum. To get the spectrum, I'd have to change my settings, so I'll clear it. I'll set it to none RT. I'll add a radio. Set it for GPS L1. And then when I start it, I should have spectrums because I had it on RT. You're just testing me, aren't you, Rogerio? Did that answer your question, Rogerio? Perfect. He said yes. Okay. All right. So we have food here at AEM for those that are here. We're pretty good on schedule. It's 1:30 now, right?
Almost.
Okay, 1:20. So 45 minutes for lunch. We can do that. So we're going to start in 45 minutes to everybody online. So we're going to do a 45-minute lunch. All right? Then we'll start back up. So I'm going to mute the conference, but I'll leave it up. And then we'll start up at then. So you guys online, we'll see you in 45 minutes, please. Thank you. So you guys about ready to start pretty soon? I don't know if it's the exact time, but I think we're close. Oh, this is the live snap. This is a simulation. This is just showing you a real satellite signal starts. This is the atmosphere. It's just showing you real. Yeah. I had to think for a minute too. Just shows the network of the atmosphere. It's not the best picture. That's a network cloud. She's going to actually jump in for a second and do a live demo to a live system. Okay, is everybody online? Send me yeses if you can hear me online. Looks like Charles hears me. Jorge's on. I think everybody can probably hear me. JC, Luis is on, Jorge's on, Victor's on. Good, thank you. Okay, so I think we got everybody back here in the room, right? Okay, so I've been able to catch up with Grace. Grace is the one that enabled the license for all of you guys. You probably saw the email that came back from her. And Grace is going to do us a favor. She's going to connect to our demo system. The one thing that I would like everybody to see is a live test. Everything we're doing in the room is none or none RT. And since maybe I was a little bit lazy for not carrying a simulator and receiver down here, I wanted you guys to see how it looks a little bit different when you have a live test, okay? So Grace is online. We've got her unmuted. You guys be nice to Grace, okay? They're laughing, Grace. I don't know if they want to be nice to you. So Grace, can you hear me? There's Grace.
Yes, I can hear you. Can you hear me?
We can perfectly, yes.
Perfect.
So if you want to go ahead and share your interface, we'll actually take a look at some of these live demos. And we can go ahead and connect to the system that's remote. And this is in Les Ulis, France, right?
Yes, so this is an actual GSG8 that we have in one of our locations. So everything is already set up. We have the GSG8, we have a U-Blocks receiver connected to it to be able to track the vehicle position. So I hear from Rob that you already have the basic Skydel training. So
yes.
I'm going to use the basic configuration and maybe go through what's happening like in live when you have an actual GSG8 and you have a receiver connected to that. Is it okay, Rob, if I
Yes, please.
Yes.
So these guys already have seen Skydel. They've used Skydel. They've used it in either none or RT mode. And we just did our first scenario, which was a static scenario. But we were hoping to have them see it connected to a receiver and see some results and so forth.
Yes, sure. Okay.
So we see your screen. Can you make that bigger? There you go. There's some old men in here. Maybe not me.
So actually, I'm going to open maybe a new window to show you what is, because you use Skydel in non-RT mode. So new configuration. So when you have a physical GSG8, which is associated with your Skydel, in the option here, I selected DTA 2115B. This is the DECTEC card that is connected to the GSG8. This is what allows us to have the signal output, the actual signal output. So in the first demo that I opened, so I start by sorry. So I select DTA and then add. So I don't know if you view this little diagram here with Rob, but this is what's happening in a true simulation with an actual satellite. You have the satellite here, you have the satellite transitioning from an antenna and then to a receiver. So when you use an actual GSG8, you have the live sky is your Skydel. The live sky, the satellite, it's Skydel. Then you have the DTA, the DECTEC card, which convert your IQ data from Skydel to an RF signal. So this is the DTA card here. Then we have attenuator and a DC block. Then that everything goes to the receiver. So we are enabled with this GSG8 to create a real GNSS signal. So if I go back to my first application here, okay, I add two radio here, so that means I will have two outputs for my simulation. So the first output is on the L band. I selected GPS L1, GLONASS, Galileo, Beidou, and I will add Gaussian noise to have a kind of real signal. And here I have the same thing, but for the lower L-band, GPS L2, GLONASS, and Gaussian noise too. So why I use different radio card here to for GNSS L1 and GNSS upper L-band and lower L-band, because the frequency of the different band are they are separate, so we can't run the same kind of signal on the same radio card. We have to switch if we want to use another range of signal frequency. So this is why you will see here on Skydel you have different output type, and each output type can run on a different radio card, a different output. So this is truly a basic scenario. I have my signal selection here. For the timing, I'm using the custom time, the Skydel time. And for the vehicle, so for the trajectory, I selected a circular trajectory with that speed. I'm going to increase the speed, and with this latitude, longitude, basically the vehicle will. I don't know if you notice it, but this is in Paris, and the vehicle is going. Okay, I'm going to cancel and open it again. So this is in Paris near to the Eiffel Tower, and the vehicle is supposed to go around the Eiffel Tower. So, surely for a basic scenario, what you only need to do is to select your output here, then the vehicle, the trajectory of your receiver. Then maybe, Rob, if you have another session, we could go through interference and spoofing, but I will just run this basic simulation to show you what we
That's perfect.
expect.
That's exactly where we are in the class. The next exercise they're going to do is a circle, so this is perfect.
Okay, perfect. So I start the simulation. Here. You can see the sky view. So we have GPS, satellite, GLONASS, and Galileo and Beidou, and we don't have the other. We don't select the other satellite, so we have nothing for this satellite. And I know that there is a physical U-block receiver that is connected to the GIGA. So I'm going to, okay. So this is the map in Skydel that allow you to see the trajectory of the simulator. So as I say, you can see it's going around the Eiffel Tower. But another thing which is really interesting is the U-Blocks receiver. So the receiver is not connected yet. I'm going to connect it now. If you want to connect any receiver, if you have U-Blocks, you can have Novatel, you can have Septentrio. This receiver works really fine with Skydel. There's this menu here. You click on connect, and you choose a USB port output. I know that my receiver is connected to this output, so I'm going to select it. Okay, when the receiver is connected, the U-Blocks receiver is connected, the information that you see here are the NMEA data. This data allow us to grab the receiver position. And using this data, Skydel is able to know where is the receiver, if the receiver is truly tracking the vehicle. So I'm going to do a call start to restart the receiver. Okay, so when you have a receiver connected, so now my receiver is connected, you see something here. I'm not sure if everybody is able to see, but there is a checkbox here, show receiver. So when you click on that, you're able to see a second sky view, a sky plot, which is the sky plot of the receiver. So this is what the receiver is seeing, is receiving. I think the output that I selected is so what attack? Okay, I'm not sure, but we have to give a little time to the receiver so that he will be able to track every satellite here. But as you can see, like there's some satellite that we start seeing here. We should be able to have the same sky plot when the receiver is actually working really fine. We should see the same sky plot. And if we don't see it, I think I have to change the output here.
No worries, Grace, it's okay.
Okay, it's okay, okay. Okay.
Let me explain something to everybody first real quick. So if you guys look, like Grace was saying, in the main window where you see that scrolling, that's your NEA data that we talked about, that you guys are going to be able to output. Earlier, you didn't see that because you were not connected to a receiver, but now you can. And two, as she's saying below on these bottom sections, all this time you've always shown one sky plot. That's what you were transmitting. Now you're connected to a live u-blox receiver. So this is what the actual receiver is seeing. So what Grace was noticing is if you look, it's actually syncing up now. Sometimes it takes a little while. The receiver is not seeing all of the signals that we're transmitting. So whether it's a setting or something doesn't matter, but at least gives you that idea of what you didn't see earlier was both screens. But remember, a lot of you guys weren't looking at the screen. There's a separate checkbox there that she checked to bring up that receiver status. And Grace, could you show them your map now to also show them that the receiver?
Yes, exactly.
There you go. So this is your receiver up in the upper right-hand corner that Grace has up for you now. So you won't see this in a non-RT setting because that's your actual receiver. And later on, you could actually even add different things to that. You could actually have two vehicles if you wanted to with multi-instance or something. So you have that ability to see much more. This is why I want you guys to see this, because everything we do is showing you how to set it up and run a test. But when you connect to the receiver, as long as you hit that receiver icon and connect serial to the printer or the receiver, you'll see the data. You'll be able to cold start it, warm start it. That's very, very powerful from a single interface. So sorry to interrupt you, Grace. I just want to show it to you in the classroom and point to it specifically.
Yes, okay. So maybe another thing interesting to view is the deviation here. So this tab show us the error difference between the actual position and what the receiver is seeing. So I'm going to clear and rescale so that we'll have a new block. So here we see the error in the latitude, longitude, and altitude from the position that the receiver is tracking and the actual the actual vehicle position or direction. So when you want to check if your receiver is working fine, and I know, for example, for the u-blox, the error here must be less than 1 meter. So we can see that the receiver is working fine. The error is -1. It's between 1 and between 0.4 and -0.4. So there is no perturbation, there is no jamming, so everything works fine. But maybe we will have another session with the jamming, and you will see the effect of the jamming to the u-blox receiver from this window.
So what I'm going to show you,
yes,
inject. What I'll show you guys this afternoon is how to inject that interference that she's talking about. And when you inject that interference, and you put a strong enough interference in here, that deviation starts to change. If she only had something like GPS L1, you could actually go in and change the signal levels of all the satellites and actually have a slight deviation too. So it's basically just taking that device and putting it through its paces and say, driving through tunnels, losing signals, jamming, interference, how does that receiver react? Here's what's very, very important that most people don't understand. Everybody will tell you, I bought this from Trimble, so it should be good. But what happens when they put it in a tank? What happens when they put it in a train? What happens when they take a Qualcomm chipset and put it in a car? Well, the antenna, the air conditioner, everything about that car has the ability to affect that signal because it's such a weak signal. That's a negative 130 dB. That's in the noise floor. So basically what you think about is the problem in the testing most of the time isn't testing a device like Grace is doing here. What happens when you put that device in a spaceship, in a car? The spaceship, that screws it up if you don't engineer it properly. Does that make sense? So that's huge. Go ahead, Grace. I'm so sorry.
Oh, it's okay. Okay. So next step is the spectrum. I'm sure you guys don't, I'll not be able to see it in the non-acting mode. Or see. Oh yes, I'm not sure. Okay. We have an underflow problem. I'm going to start it again.
But this is good, Grace. They haven't seen an error yet. So you notice here,
okay.
You had some yellows. We planned this. Grace and I planned this, really. You believe me? I said it would. But the yellows and the red, you actually, I'm glad this happened because everything you've seen has been perfect so far. And now you start to see that Skydel will tell you with yellow and red lettering that, look, there was a major error there. I can't read it, but.
Okay, so the runtime errors happen when Skydel is Skydel missed one package. For example, you were not able to track a package at the right time. So it don't happen truly, but it can happen. Can happen depending of the cable that you use to transmit the data from the GAG8 and all that. So, but it's something that don't happen usually. It happen when you have, for example, a lot of signal. When you select for here, when you selected every signal and there's too much signal for the GAG8, you can have this kind of error.
So Grace, let's ask the class a question, see if they remember. What could she have done to test that in advance?
Sorry, what?
I'm asking the class a question, Grace. I want to see if they remembered what I said this morning because they had food. And sometimes they forget things after food.
Okay.
So let me ask the class real quick, Grace. So she's getting a runtime error because she has a lot of signals. Yeah. So what could it be? And I'll give you a hint. Starts with G, ends in U, and you can self-test it. The GPU. So when she actually set this up, if she'd have tested all of that, she could have tested the GPU, and maybe she had too many signals and satellites for that specific GPU. I don't know, but I want you guys to start connecting all the pieces to see that that self-test GPU is huge at times like this, all right? Because she has lots and lots of constellations. She's got GPS, Bonus, Galileo, a bunch of those configured right now. Grace, do me a favor, stop the test.
Perfect, okay.
And just test the GPU under your current configuration for us, if you don't mind.
Okay.
Probably comes in at the nominal level. Don't change any numbers. Let's see what it comes at by itself.
Okay, so stats.
Yep. See how it. So let's test that GPU. It's probably right around that 1 mark. It lied to me. It's 2.58. I was thinking it would be a little bit lower. But that's the way you could have checked that in advance, too. So go ahead, Grace. I just want to see if they remembered something. And they didn't. They embarrassed.
Okay. So you already go through the jamming, is it that? Or if you
I haven't covered jamming and spoofing yet, but Grace, do you mind adding an interferer, so add a third card?
Yes, sure. Actually, I can load. I have already
Beautiful.
set up some
If you already
scenarios,
have
so I
it
can.
set up, that would be perfect. Actually show maybe a jammer or some interference so they can see it live.
Perfect. Okay. So I'm going to open the jamming scenario now. Okay. Okay. So this is also, I can say, a basic jamming scenario. Here, what I select is what I want to jam in this simulation is GPS L1 and GLONASS G1. So I have two separated radio for that. I put the interference here on the second radio. So Skydel has the ability to do a multi-band jamming. This means you can jam many signals from different bands at the same time. So here I just want to jam GPS L1 and GLONASS G1. So I select this signal here. I could choose to select to jam on GPS L1. That would be possible too. I set the gain here to 30 dB, which is the gain, which is what we advise for the user to use when you're adding the jamming to your simulation. Okay, so for the position here, I picked a fixed position in the middle of the Eiffel Tower for my receiver. So that means, for example, if you have your simulator, your Skydel simulator, he is in the middle of the Eiffel Tower, okay, in Paris. Then I go to the menu interference, and I had two interference in this scenario. I had two interference. The first interference, the first jammer. So I don't know if you remember, but I say that my simulator, my receiver was here in the middle of the Eiffel Tower. Then just imagine that so this is the trajectory of the first jammer. He's going around the Eiffel Tower near to the position of the receiver. This is really cool because we're going to see some effects. For example, when the jammer is close to the receiver, or when he's far from the receiver. So I had two jammers so that you'll be able to see the effects. But for the two jammers, I selected the same signal type chirp, and almost same trajectory too. So the other one was here, for example, and this one is here. We're going to see the combination of the two jammers and the effect that they will have on our receiver. So yes, so the menu that I used to set my scenario here was the output to select my GNSS signal and add the interference, the jammer signal. After that, I go to vehicle to set the position of my receiver, the receiver under test. After that, I go to the menu interference to add the jammers. I just want to do a quick review here. We have two menus. The first one is add a simplified jammer. When you add a simplified jammer, that means your jammer will not be able to move. It will be like the jammer is always at the same distance to your simulator. He didn't move. he will not move. He will not move. It will be a static. It will be a static jammer, and there will be no variation in the power from. There will be no variation in the signal, in the ratio jammer to signal. But when you add a dynamic jammer, you'll be able to better see the effect of the jammer, because you see how your receiver will act when the jammer is far or when it's close to your receiver. So I'm going to start the simulation now. I think my 2 jammers are not activated yet, so they are not activated. You can do that here, enable. You can see if it activates, you can do it here, enable. So I'm going to let them, first time when I'm running the scenario, I'm going to be sure they are not activated. So I'm going to map now to see. Okay, so as I said, my simulator this time is fixed. It has a fixed position, and I have the 2 jammers going round in contrary, I don't know, contrary direction. They're going around to the simulator. We have here a really interesting window that show the power, the receive power from the transmitter side. You can see here, for example, that the 2 transmitters are not enabled. So enabled is no, they are visible. We see the distance from the receiver. We see the reference power. We see the elevation azimuth and all that. So I'm going to just do a quick cold start on the U-Blox receiver and go here.
While you're doing that, Grace, I want to make sure we understand. So you guys see what she's doing. She has a fixed location for the simulator, no motion. But she has 2 jammers going in circles. And what's going to be really interesting on this is when she runs the live test, as the jammers get closer to the simulator, your deviation is going to go away. When they go away, it'll come closer. So you should be able to see all of that. So again, a fixed receiver at the tower, 2 moving jammers, or 2 moving interference sources is what she's got. And you guys notice she now has more windows. You got windows here for each of the transmitters too. So before we just had the one for the receiver, now you've got 3 things. Remember, we could have 5 vehicles with multiple instances with 3 jammers in there. So this could get pretty complex pretty quickly if you did a bunch of stuff like that, which is common. Okay, so she just did a cold start on the receiver, right, Grace?
Yes, so I did a cold start on the receiver, and you can notice here that we have actually the same sky plot. We just have the satellite that are out the, I don't remember what's the name.
Yeah. Over the horizon, basically.
Yes, so the receiver can see them. It can track them, but we basically have all the satellite in view on the receiver sky plot.
Yep, and your deviation should be pretty good on that tab.
Yes, exactly.
Ignore
my
the
deviation.
Sorry, but it's pretty good. Remember, she has it scaled way down.
Okay, yes. So my deviation is really good. It's between, so I say for U-Blox, it should be less than 1 meter. So I'm good. We have everything working, the spectrum. We don't have any transmitted jammer, so that's normal. We have nothing from on the jammer side, and we have a runtime error. So I'm going to start it again. Sorry, I think there is the R&D team is working now on this computer, so they actually tell me that they are working on this. So I don't know what they are doing. I guess yeah. Okay, so receiver.
So they can see it should be really cool.
Yes. So I did a call start, and as soon as the receiver is tracking, I'm going to enable the jammer so that we'll see the effect. And you can do it. This is really cool. You can activate and deactivate your jammer while the simulation is running. This is really cool. You can also change the power while your simulation is running. You can do that like on real time with your simulation. So now, okay, deviation. Okay. I'm going to do okay. So I'm tracking now. I'm going to wait a few seconds, then I will activate the first transmitter. Okay, so I'm activating the first transmitter now. I'm going to return back to the map. If I expand this window, okay, so if I expand this window, I can see that my transmitter is now activated. So that means is sending an RF signal. It's sending an RF signal. So transmitter 1 is activated. We're supposed to see something when he will be close to the receiver. So we are waiting. And what I can, yes. So we see here a kind of deviation, not that big, but deviation, and I can increase the power so we see it perfectly. I put 0. Okay. So we have a first deviation here and I don't know if you guys remember, but everything was green when I started the simulation and when the jammer were not activated. But you see that there's some satellite that becoming blue here because they are affected by the signal of the jammer. So these are jamming satellites. The satellite that become blue, these are jamming satellites. And when the effect of the jammer will be really great, you will see that there are some satellites that will disappear because they are really jamming. They don't have any effect on the simulation. So here you see, for example, this satellite disappear and transmitter 1 is close to the receiver, so we see more satellites that become blue, and the signal to noise ratio start decreasing. You see some satellites disappear because they are affected by transmitter 1. Okay, this is same thing for GLONASS 2, but yes, GLONASS, we have some satellite that we don't see, and we see also same thing here. Maybe the satellite don't change color, but the signal to noise ratio here is decreasing. Okay, so I'm going to activate the second jammer. Oh, okay. See the deviation also go up, but it didn't have like the position, the receiver were not enough perturbated by the jammer. But I will activate now the second jammer and increase the power so we'll be able to really see the effect for this simulation. Okay, so I activate the second transmitter, so all my transmitters are activated, and you see the two transmitters are going close to my receiver, and you can see the big deviation that we have here. You see a big deviation. Okay, the error move. The error is now more than 1 meter. The receiver is perturbated by the jammer. You can see here also for the constellation, we see more satellite that we see that more satellites are affected by the jammers. Okay, so I see deviation. We have a big deviation. Okay, another thing is the spectrum of the two transmitters. So I choose chirp. Oops, we don't have. We're not lucky. We had
We saw it.
a restart. Yes.
It's no big deal. We saw it. For some reason, it's acting a little flaky. That's okay. But you guys get the general idea is when you add receivers, you get multiple results. When you add transmitters, receivers, you get multiple results. As you add more interferers, you can put in all kinds of different noise and interference that I'm going to show you guys later. So chirp or BPSK at whatever power level. And the goal is to test the receiver. When does that receiver lose sync? How much interference can it take? And you'll find different variations. There's basic receivers like this U-Box, which can come not much bigger than a cigarette lighter. Or you can get a very robust receiver like a Trimble or one of the high quality ones that are thousands and thousands of dollars, that they're better at handling interference and jamming. But the point being, integrated into your application and what happens, that's the huge part of it. So I think that's the main things I wanted to show them, Grace. I think that's the main stuff. That they want to receive the live jamming and interference on a live system. And they're going to do the circle here in a couple minutes, and then they're going to do a vehicle also. So they'll set up almost these exact same scenarios. We just won't have a receiver to connect to. So any questions from you guys on a live system? I wanted you guys to see that since I didn't bring a receiver with me. You connect to a live receiver. This is a live GSG8 connected to an actual receiver through a serial port. You were able to see the results of everything, the deviation and everything come up itself. Any questions? Does it make sense? It's the same thing you guys have learned. It's just adding more and adding more and adding more. So perfect, Grace. I think that's all I wanted to show them, unless you have something specific that maybe you think is new or cool or important. Maybe I don't know. Anything new or important I don't know yet?
No, not that much. Maybe the performance tab that we had, which is really great to see the performance of the GPU when the signal is sending, when we have the GNSS signal activated and when they are streaming from the GSG8 and all that. So this is really cool. And we will add more things here for especially the HI. I don't know if you view that, the hardware in the loop system. So we'll have another tab to be able to see the timing associated to the HI. So these are new features that will be added to Skydel, but for now, this is all that I can show you for the jamming and for the basic simulation.
That is perfect, Grace. It's exactly what I wanted to see. So thank you. Can you guys do me a huge favor since Grace dealt with all your licenses? Can we give her a little clap? So Grace, you activated a lot of licenses in like the last 48 hours. And we won't say that some people were slow to request their licenses, but maybe they were. But you responded, and I think almost everybody has their license. So Grace activated those for you guys. So at least you know the voice and the person now if you ever get an email or anything from her. So that is good, Grace. Thank you so much for jumping in for about 20 minutes or so.
You're welcome. Thank you. Thank you, Rob, and thank everybody for learning about Skydel. And I hope you'll be our future Skydel user and partners.
Thank you, Grace. Take care.
You too. Bye.
Okay, so any questions on that? Again, I wanted you guys to see a live system since I didn't have one with me, but they basically gave you an idea of what would happen when you hook to a live system, see a live receiver, and so forth. Okay, so let's do some playing around. I'm going to let you guys do a lot of work now. So first off, if Skydel's open, shut it. Close the application. Turn your computers on, close Skydel down. We're going to start at the very beginning. We're going to have you guys do an exercise on your own, and we'll see how you do. All right, so a couple things that will change. Some of you may run in none instead of none RT mode. By the way, everybody on the web, do you see a slide that says field exercise 1 or fix exercise 1? Yep, they see it. Good. Okay. So as we do this, some of you may not have the GPU, as you well know. So under that, you can do none or none RT, depending on what you have. Sorry, 1 second. So I want you to set up a test from the beginning on your own without any help, maybe. So either none or none RT, depending if you have an output. I want you to configure one output, okay? And that one output will be GPS L1 and GLONASS G1. I want you to make the start time match your computer. There is a setting for that, see if you can find it. I want you to set the vehicle as fixed with latitude and longitude as I show there. So you're going to manually enter it this time instead of using the crosshair. You're going to run the test, and you're going to go look at the map icon. All right? And what I want to know is simple. Where is that? So set all that stuff up. This is somewhere in Mexico. But you have to figure out where it is by running the test and finding the map and zooming out on the test. So does anyone have any questions on what we're asking here? I just want you to play for a couple minutes. Try it out. Give it a shot. I'll walk around and see how you're doing. You guys on the web did the same thing. You guys on the web have a question, ask or just send a message. So Rogerio is bragging. He said exercise 1 is easy. Web, so I don't know if you guys know him over there for bragging. Okay.
86, get them. It's like a 5G cell site. Finished.
Okay, get started. Because it was a time test. Oh, yeah.
30 seconds. Requested help.
Okay, so most of you are starting to finish up. So basically, we'll walk through this real quick, but I think almost everybody got it. So your output, I'm going to run in none RT, actually clear. We just added one output, right? Let's see. GPS bonus. And remember, if I can't remember things, I can label this too. I can say GPS and glow. Go on. Did the start time with the computer, which was easy. Where is it at? Current computer time. You're going to run your test for 30 seconds, so not hard. Your vehicle was fixed. You're going to edit it, and I'm going to cheat, take it over. I made you guys do it the hard way. There's Ensenada down here somewhere. Did I go too far? There it is. And I put this right at that intersection of that highway there. I think it was somewhere here. So it's like a 5G cell site. I think I put it right about there. So there was a cellular site that covered that location. So the latitude and longitude should be pretty close. So I cheated. But it's whatever's comfortable for you, and run the test. You see your receiver, it's not on there. See your map. So it's a fixed location in Ensenada. And then again, I have the GPU, so I have the scale showing. But pretty basic test overall. And again, that's something that's not moving. And of course, if you want to save it, you saw that Grace was actually pulling scenarios up. You can save it on your computer and you can call it whatever you want. You can name it Ensenada or whatever, just if you want to have some examples loaded on your computer already. Any questions on that? We basically discussed that before lunch, but I wanted you to kind of do it on your own. Not too bad, right? Okay, good. All right, so let's keep going then. See if there's anything else you need to know. Let's do one more thing. And I'm going to show you how to do this, but I want to do it because Grace took a little longer than I expected. I'm going to show you how to log data. So we're not going to change that test. We're going to use the exact same test, okay? But we're going to go back to settings. And does anyone remember where I logged data, or you want to make a guess which setting where I logged data? And it's typically a round thing. Global. Yeah, so go into global. Click on logging. And I want you to log the raw CSV data. But you could choose any of these. I'm just going to choose one of them. Okay? And now run the test again. It'll take us 30 seconds, but we're going to run the test again. Now, while it's running, I want you to look at something real quick on my screen. Look at the location. Your files are always going to be under Documents, Skydel, Output, and if you don't give it a name, it'll come up untitled, and you can rename it. But I'm going to wait for 30 seconds, and you see my clock up here. If yours is in none, it's going to go a whole lot faster. Okay, the test is done. So I want you to look at that file. I'm going to go to Documents. Skydel. Output. What did I call it?
Output.
Mine did not work for some reason. Untitled, there it is. So here's all of your files that you actually just saved. So if you want to click on these are CSV files. So basically, this is the data that's being communicated during this test. So you can see the elapsed time and all the parameters that have to do with GNSS. And keep scrolling, because there's a lot. So those of you at the university that teach GNSS fundamentals, maybe some undergrad courses, these are great little tools that you can use so they actually have all of the information in files, and they don't even have to have a whole lot of settings in this. They can do it in none if they want to be able to do it. But I can save any type of file format that I want or any type of configuration that I want in the system. And the trick is, if you want to keep them, I would rename them, because the next time an untitled comes in, so I always rename them. I've asked them to put in place there where you can name the file, because you do that in other areas, and they're going to add that. But for right now, it just comes up as untitled. There's a question coming online. Let's see what they have to say. Yeah, so Rogerio, I'll talk to you about the question later on. You're right in your setting. So the one that Grace was running was basically quite simple in a circular trajectory, but you can actually do a lot more control. Raphael, you couldn't run the exercise itself. You should have been able to do it in none, though, I would think, Raphael. But anyway, the point being, I want you guys to see running a basic scenario, but I wanted to add a capability to this while we were at it that showed anytime you're running a test, remember, you can log the data itself. And you can do NMEA data, you can do Rhinex, you can do a hardware in the loop if you ever do those. And you can do all of those quite easily, as well as to change the actual rate too, from 10 to 100 to a gig. I'm sorry, to 1,000 hertz. Any questions? Pretty simple, pretty easy, right? Okay. You guys good to move on then? Okay. Let's go back to the slides. Okay, so we did the logging data, and there was an exercise on that, but we just did it together, so I'm not going to force you guys to do that. But if you want to practice, a lot of times through these, there's scenarios that you just want to practice or play around. All right, a couple of things that are very, very unique to Skydel, and this one's going to be a little bit more confusing, is we can record IQ data and save the IQ data files. But I want you to be very careful as we go through this to make sure you set the time limit. Remember what I said about IQ files earlier? They are huge. And if I was with friends, I would say something else before huge because they're really huge. All right? But I don't know you guys that well, so I won't use naughty language. But what Skydel will do, and I will show you specifically, is that if you go back to the same test, but you go to settings, you go back to your output and clear that test out. So I want you to clear that test. And we're going to do this in the none mode instead of none RT. So you guys that have GPUs, we're going to scale you down for a minute. All right? I lied. I'm so sorry. We're going to do a file. Told you I wouldn't lie, and I just did. We're going to do file. This is a very different setup. When you click add, it wants to know what the file is and where you're going to put it. So choose a location and just call this IQ file 1 or something like that, whatever you want. Any name you want. Remember where that's saved. It's in Documents, Skydel SDX, and save it. Go ahead to your output, and you notice the output name now? It's no longer none or NRT, it says IQ file 1. Okay? I want you to edit that, and I only want you to choose one constellation. These files are humongous. Just choose L1 or just any one. Click OK. Go to your start time, and I want you to decrease this to 15 seconds. And it's easy, go down to other, and just type in, I messed up. Go to other, type in 15 seconds in the very, very bottom. Run your test. What did I do wrong? I kept the old file open, my bad. You probably might have the same thing. Go to your Skydel. If you did, I'm so sorry. I messed up. Output. Close out. I don't like you. Close out your open file because it's trying to save when we already have a login. So close out all your old files. No. If yours is acting flaky because of that file we opened earlier and didn't rename it, so I'm just starting over to cheat. You guys have to do the same. I'm fixing my mistake real quick. If you guys are having errors, I can come fix it for you real quick. It's just remembering the old file. Okay. Let me run around, look at the computers in the room. If you have an error, just close it. Start that file. This file is what's corrupt. Start again. Good. Start. Those kind of. You guys on the line, if it's actually giving you an error, it's because I didn't rename and close all the old files. The fast fix is to close Skydel and configure again. Is that file? Skydel again. That was my bad. My apologies. Close this one. Okay. Constellation. Okay. Put your start time. Change it to 15 seconds. Very, very, very popular. Best. Let me show you guys what you'll end up with in the end, because I messed you guys up. I did not close. This happens in training a lot. I have you guys do one thing after another and after another. And your old file, when we saved the logging data, that file was untitled and we had the file open. So when Skydel goes to save, it's like you're telling me to save, but I already have something titled and it's already open. So it gets confused. So you have to close the file, kill the old file, and then start Skydel over. So that was my fault for trying to hurry the test a little bit. But if you can all see my screen, I'll show you what basically happens is now that I ran the test and mine did run the test, and you go to your documents now, you will have an IQ file if it worked for you. So it's in Documents, Skydel. What did I name that file? There it is, right there. So look at that test right there. Look at the size of that file for a 15-second test. If you want to read that IQ data, you will have to have a program that reads IQ data. So most of your standard words and Excels and all that stuff won't do it. So the program that I use a lot of times is this one that I showed you guys earlier, which is like a file magic. But there's about 10 programs out there. They're all paid services. And what you have to do, I think my license is expired because I cheat. I keep getting a free license under a different name. But you would normally take here and you would drag that IQ file over. But I think it's going to tell me mine's not activated. Not activated. But you can't read IQ files with standard programs. You actually have to have a special program to read it. Oh, there it did actually. It corrupted it, but it read it. But again, these things can be incredibly large files overall. So I know that IQ data information is a little bit probably cryptic to some of you guys, but that's the data that actually runs RF output on the system. Okay, so we've covered none. So I'll go back to Skydel for a second. You guys have seen 3 settings here. We go back to our output. You've now seen file, which sends the IQ data to file. You've seen none. Actually, you've seen more than that. You've seen none, which you can run on all computers. You've seen none RT. And Grace actually showed you a while ago this DECTEC card, which was an actual card. And when you added that, it gave you that configuration she was showing you. So my sincere apologies for messing up that exercise. I'm allowed to mess up once in a while, though, right? Is that okay? But does everyone understand the purpose of that? Instead of sending that data to a receiver, you can send it to files. And it's not just the actual IQ data. It's all of these files, Rhinex, download Rhinex, NMEA, IQ. Everything's there for you if you want it. Okay. check the slides real quick to make sure I covered everything. Talked about the uniqueability. There you go. All right, let me see if there's any questions online. Let me check my messages real quick. Somebody got a 1.3 gig file. So the file size will vary based on the constellation you chose, by the way. So they are pretty big files. If you run that thing for 20 minutes or 30 minutes, or you walk away and you have it unlimited, good luck. That is a huge, huge file at the end of the day. Okay. We're going to do something every one of you guys can do pretty easily. All right. We're going to do 2 or 3 of these back to back. So remind me between these to either close Skydel or make sure I name the files, because what I do is sometimes I change too many settings. Okay, so we're going to do exactly what Grace did. And I'll give you 2 choices. Do you want me to show you how to do it? Or do you want me to jump you straight to the exercise to see if you can do it? Because I think you can do it. You want to try it? I want you to go and try this exercise. And I'll explain it to you. So you're going to set up a test scenario. You're going to set it for a specific date in December. You're going to run it for 10 minutes. You're going to simulate GPS L1, L2, and Galileo E1. So that means you're going to need 2 outputs, one for L1 and one for L2. You're going to go to your vehicle and you're going to actually program a circular pattern. You're going to go in the counterclockwise direction, which you can choose it. You're going to set how big that circle is. You're going to go 300 meters per second, so we'll put some speed on there and start the test. And if you do the test well in the middle of Mexico City, and again, you choose the location in Mexico somewhere, you can actually run a circle in Mexico very similar to what Grace was. So I'm just going to let you guys try it. Is that okay? Yeah. I think you can do it. There's at least 1 or 2 smart people in here, and it's not me.
We should do it as nodes or non-RT.
I would do it in none, unless you have non-RT. You're welcome to. Yeah, don't do it in both. Yeah. You guys online have any questions, let me know, but I think all you guys can jump on this pretty quick too. Yeah. Stars, I've seen that before. I don't know. That is the first time I've ever seen that. You are magic. What you said. That's you know what? Maybe it's because it's so fast. I think I might learn something new just now. Let's find out.
This is because it's here,
I think it is.
It's already a circle here.
Is it?
because I put
Because it's going so fast, it's jumping.
30, I put 30 hertz per second.
Mm-hmm. And I didn't help it because I made it 300 meters a second either. Let's see how this works. Yep.
I'm not saying something like a story.
Also,
Yeah.
The reason being we're in none mode. I just learned this. I'll explain it because it's so fast because it's not real time that it's jumping. And I had you guys going 300 meters a second.
Yeah. 10 meters.
So let me change something. So you guys, let me get everybody's attention for a minute. So you guys just taught me something. I rarely run in the none mode. And in the none mode, remember the clock goes so much faster. So since we're in the none mode and it's running so much faster, instead of it being a perfect circle, it's jumping really, really, really rapidly instead of being a nice smooth circle. So I never knew it would do this. So now I have a new toy that I can show, because that's a good thing for kids to play with. I'll show you guys. I thought I was online. Let me share my screen. So to everybody that's online, listen up for just a minute. If you are in the none mode, you will notice that your circle is more of a star, pretty artistic pattern. And the reason for that is, remember the clock. This is showing an 11-minute test already because it's non-real time. So what's happening is, I had you guys in your settings. You go stop for a second. Go to settings. I wanted this to move fast anyway. So in your vehicle, I had you moving at 300 meters a second. So it's 300 meters a second, but we're none mode, so a second is much faster than a second. So let's see what happens if I drop this down really, really low and see if it goes back to a circle. Yeah, so if you slow your speed down to a much slower speed, it'll be a prettier circle. Yeah, slow it down to about 5. But that's the first time I've ever done that, so I'm excited.
So I guess that the software can support this kind of speed in the non-simulation. So maybe it's not also maybe it's not only working, like you can simulate different scenarios that are so fast as well. You can do that.
I think so. So you guys that are online, if you do have none RT, you can change to none RT and it'll work perfectly. Or where you actually have 300 meters per second, I'll show you. Where I actually, in your settings, where you have 300 meters per second, make it 5 meters per second online. And it should then be a much prettier and cleaner circle. Or go to none RT, because that's real time and it's not that turbo mode. Turbo mode and fast speeds don't mix, seems like. But it was a pretty pattern I've never seen. So all of you right now should see it. If you actually lower your speed, or if you go to none RT, start your test, then it's a much prettier circle. And I did not change my location. Mine's, I think, in New York. Yeah. So, a couple of questions. Let's make this real world. Why would I want something to go in a circle? Give me a couple of applications of something going in a circle to see how it performed or tested or navigated. Could it be a drone? A drone it could be, because a drone's up in the air. We're going to do a car next where you map the streets. A drone's up in the air. Another one I did this for, where there was a company out of Germany that was making autonomous mowers for golf courses. And they wanted to actually take the golf courses and actually be able to see how the mower does. So I did a pattern for them that started with a big circle and it got smaller and smaller. The next thing they did, which was really, really cool, is they then got maps of golf courses, and then they programmed routes for all of their autonomous mowers to mow at night, so they make more money with golfers during the day without having mowers out. So it could be any application, it could be an airplane or whatever, because I could make this circle as big as Mexico City if I wanted to, or go out in the desert and maybe go around circles. So there's a lot of different applications. It's a very, very, very basic application, but an easy one if you want to. And you saw what Grace did a while ago. I could go to my settings again, And I could put a real receiver in a place, and I could go to my settings, and instead of GPS, could I make this interference like Grace did and actually have an interferer going a circle around a live receiver? Sure. Gives you an idea what you can do. So if I did this now, it's still the exact same thing. But at this point, the simulator, I went faster. It's octagon now. But then the simulator itself is the actual interference instead of GNSS. So what was confusing about that besides the star pattern? The jumps, those were crazy. The reason for that, remember, is we're in the none mode, which goes faster. And I was the crazy person that likes to drive fast, so I had you go 300 meters per second, which meant it was just jumping all over the place. So that was me. But I'm glad I did. Makes it fun. Okay, so let's run through really quickly what you just did, because it's only 3 or 4 slides if you want to do this in the future. So enabling motion, you guys should see the slides now, yes? We actually went in and showed enabling motion by actually going in, choosing circle. Do remember that sometimes there's other settings where you can import options, which we'll show you in a little while. But a circle pattern is really easy. You go into your output, you choose that setting, you actually choose it to be a fixed, then you actually go in and edit those parameters for whether it's clockwise, counterclockwise, the size of the circle, and the speed of the circle. Pretty easy. Okay. If there's anything I missed, you did the exercise good. I do want to show you one thing so you know it's there. We're not going to mess with it much today with limited time left, but if you guys want to go, stop your test and go to vehicle. You can go in and change the antenna on the vehicle. So we have a very basic antenna, and if you're curious what that equates to, it's just basically a simple generic GNSS antenna. But you have the ability, if you want to modify antennas at any time, you can actually go in and do that. And the way you do that in the settings is under vehicle, you simply go down to antenna, and you can also change the elevation mask. But you go into your antenna, and you can change all the settings. That's the gain, that's the phase pattern, that's the position. Or you can import these. So if you actually are thinking about, here's a common test. You guys are thinking about doing a test, but you don't know which antenna to use, you can test different antenna patterns. And most companies that make antennas, they give you all the information on their patterns, and you can see how it reacts to each of those patterns. But that's the pattern on the vehicle. Remember earlier, we had the antenna pattern for the satellite. So keep those in mind that they're different. This is on vehicle. All right. So again, a lot of that stuff is advanced, but we're in good shape on time.
The basic antenna is a patch.
The basic patch omnidirectional type antenna. All right. Good. So you guys ready to do a car? You want to do the same thing? You want to try it without me? All right. So here's the deal. I'll give you the very basics in Skydel, and then we'll do this exercise. I'm going to go to Skydel, and we can leave the same configuration if you want, or you can start over. But on this one, if you see my screen, we're going to do vehicle simulation. And in vehicle simulation, if you've used Google Maps, you can pull this together pretty easily. When you choose vehicle simulation, you go to edit, and you can actually import KML files or just simply use a street map. So I can go here and say, I want to drive whatever from Puebla, Mexico. But when you type it in, type search and make sure it finds it, because this is not Google Maps, it's street. and do another location. I don't forget what the exercise is, but you could then do Mexico City. Search. And once you get your 2 locations, it helps if I spell it right. Just like in, you guys watch real quick, just like in Google Maps, you hit next, it calculates your route. Once you calculate the route, look up here, hit next, you can set your speed. All right? So I showed it to you quickly. Here's your exercise. I want you to set up a test. If you don't have none RT mode, do it none, of course. I want you to add 3 outputs this time. I want you to run the test on January 15th, 2022. And I want you to set up a path from Puebla, Mexico to, say that for me.
Tlaxcala.
Yes, that. Or any 2 locations. It can be any 2 locations about 10, 15 miles apart. Set the vehicle speed fast if you want, 120. And then start the test, and you should be able to see it start to map the path, just like you saw earlier. So I'm going to let you guys try that, play with that for a couple of minutes. You guys are doing so good. Why give you all the steps in between? Let you experiment. It's just a math and so they're pretty easy, right? Like we go out. Woo-hoo.
I did this, I did this, I didn't know.
También se van polarizando. Sí, todos
So even going to an address, not all the addresses, you can like go place if you want it. Is C. Depends on the number of satellites. Plus, that road is not very road either. That doesn't make it look better. I didn't. If you give it a specific latitude or longitude, I don't know why it started. Not specific. Yeah, you put a street. And some addresses, primary address, like yeah, probably just put address, probably sure that part. Yeah, you guys can play with this and try different addresses if you want. I just chose cities. You can choose street names. It's not like Google Maps where you can just put a restaurant or something, but sometimes you can do like Main Street or something like that, or you could choose a location. So at the first, it was in a stream with like a very beginning. As we were looking at it, I don't know why it started there, except that must be the main location. And look, it was almost on the river. Yeah, it's just because I just named the city and I picked it randomly. So you go back now, maybe do like you try different address more specific if you want. You're gonna do it like your house or street number or something. Yeah. It doesn't always have every address, but you can get pretty close. Yeah, once you guys do that, if you want to try better addresses, like maybe a good street address, like they're doing AEM right now. You're welcome to play around with your comments. That's what it's for. There is a pull-down menu too. When you go to Street Maps, if you type an address, there's a pull-down menu. You can dig deeper addresses if you want.
I don't know if you guys notice this. If you look real quick, if you type in an address and you want to see if there's anything else underneath of it, there is a pull-down menu there that shows you maybe some different options for this too. You should be able to pull up some primary addresses if you want. I think someone pulled up the address here at AEM and it came up. Any questions from the guys online? If you guys sound like you're doing all right out there. So it shows you all the different satellites that are over your head right now. So you can see GPS. Notice if you change, it always gives you direction south, north. There, so you know which way the satellites are. But it just basically shows you where the satellites are. Just of vision radar. Nice little door. That shows you there's a lot of satellites in the sky. What I would like to know is, do you really see them with the receiver? Because if you're in the middle of Mexico City, that's what's available. But I don't know if a receiver would see them all. Maybe because we're high here, but down in Mexico City, you would not see all the satellites. They would be blocked by the buildings. You see on the screen, I'm actually driving in Paris, France right now, getting ready to cross the bridge. So you can play with all kinds of routes and setups and everything else, but I think this is pretty easy for most of us because we use Google Maps. All right. So if everybody's okay, I say we move to the next exercise and let you guys try something else. Is that okay? This is the fun part for me because I just tell you to do something and then I wait. Okay, actually the next one I do have to show you a couple of things. Everybody online, okay, any problems? I'm watching the questions. I don't think I see any in the chat. Okay, I don't see any questions, so I'm going to keep going then. Okay, so we're going to take this a step further now. So you were able to stay in one location, you're able to go around circles, you're able to drive down the road. Do you think you can go in space? Okay, let's give her a shot. Let me pull up the presentation. It's actually pretty simple once you get the hang of it, if the instructor can find this presentation. Okay, so let's take it way up then, all right? So let's go clear up into space to show you how you can actually do a couple of other really cool things. So when you start thinking about things in space, now you have the ability to show the entire Earth and show how something moves around the Earth itself. So very simple. You've already done this multiple times. Go to your settings and choose vehicle. But this time for your body, you're actually going to go in and choose the space, Earth orbiting spacecraft. So I'm going to go to Skydel and do this with you real quick. Okay, so I want you to pay attention for just a couple minutes because there's a few things here that are a little bit different because obviously it's not a road, all right? There's probably a lot of terminology that you may or may not be familiar with. So the same thing, Earth orbiting spacecraft, you go in your edit fields. You're basically dealing with the 7 elements of orbit at this point. So if you're familiar with this, you studied it in school, you teach it, you understand this probably better than me. But what I like to do myself is if I change something, it's hard to see the big picture if you only have a short period of time. So I typically go to something like a day or 2 days on the time. So that way, if I go in here and I change something like the inclination angle to 500 or something different, then I can see the whole pattern change in not just 1 hour. Because if you think about it, 1 hour going around the Earth, you really don't understand the route like 1 hour driving in a car. So basically you can go in here and say, well, what's that look like for 2 days or 5 days? And you can see exactly how something's going to orbit the Earth. And I think I can bring it closer to the equator here, I think. Get my angles too screwed up sometimes. The direction. You can change all your settings. So basically what I want you to do is play around with this for a couple minutes. You can change the actual direction of the Earth, the side of the Earth. All of these are changeable items. If you want to go in and just mess around with all your settings. And there's no right or wrong here. As long as you don't save it, it doesn't matter what you change because all you're doing is experimenting with what you're trying to do. You're turning the Earth upside down. You're changing the angle. You're changing how something traverses around the Earth. You're changing the ascension levels. These are all things that you can change based on that satellite itself. So I'll let you play with that for just a couple of minutes. So at the end of the day, you have to think about if you're putting a satellite in the sky, you have to match the trajectory of that satellite. Or if you're actually putting a spaceship going to go around the Earth or whatever, all of that's part of it. So you have to figure out those angles. And those are all the 7 elements. And if you're not familiar with them, it's an interesting read if you're tired. It's all the different models and all the references and everything else about how the actual angles are. But I don't have you setting up anything specific here. So set up anything you want. And when you start to test, it's going to be hard to see it because it's moving at a much different rate. You're not looking at a small circle in a city. You're not looking at a simple driving down the road 10 miles. You're looking at the entire Earth. So a lot of times you have to think about this for long term. And this is when tests take a long time. So for example, the company that I mentioned earlier, they do all their tests in Skydel before they launch. Blue Origin does the same thing. SpaceX does it. JAXA is one of our customers, the Japanese Space Agency. All of them basically go through all of this and test this prior to putting it in the air. So I know recently there was a couple of satellites that went in the air, I think here in Mexico in partnership with Japan or someone, I think it was. You guys put a couple of satellites in the air. So you could have tested that entire route of that entire satellite. You can actually do 2 tests. You can even do the takeoff of the rocket too, if you want to. Most people mainly do the actual traverse of the Earth, but you have full capability of testing all that stuff. In that menu, there's a couple things that are interesting to know about. Look in the bottom of this setting where it says, tell me more. Click on that. So there are 2 models that are built into this for spacecrafts. There's the LEO or low Earth orbit models, or there's the geosynchronous Earth model, I think it's called, GEO. And you can actually go into these, and you need to tell it if you want to force one of these to actually use the LEO settings or to force it to use the GEO settings. So if you get into a space type situation where you need to test this stuff, it's not normally near as simple as driving down the road. And most companies do not use our default. They actually have all their paths in a much more specific manner set up, and they import those files over. Because you don't have to use our models, you can import files over at any time, like we've talked about. And some of these space missions have thousands and thousands and thousands of hours that they run of the exact mission over weeks' time sometimes. But they do it very specifically, so they pull their models in instead of using ours, because ours are a little bit basic compared to some complex missions. So the exercise I have you guys doing here is just basically trying these settings, changing it around. If you hit OK, when you leave, as long as you don't save your settings, it goes back to all the defaults that are there. And if you do save your settings, it's OK. The next time you come in, just have a new scenario if you're going to do this to run it. All right. So the exercise is simple, and you guys have pretty much already done it. Really, basically, all it is to go in and play. Is basically all I ask you guys to do is change the orbital time, change the preview times. Just look at things about your settings that you just did to kind of get a feel for it. But again, I prefer to see it in a 1 or 2 day increment, because I get to see the whole pattern, not just a single instance. So, for example, if I go in this right now, and I have it set for 1 hour, and I make a change with just 1 hour to 50, you don't see much itself. But if you switch that over 2 hours, that change right there at 2 days covers the Earth versus there changes the whole pattern around the top of the, where is that at? Asia, I think it is, or whatever. So just a couple of tips and tricks. You will also see a couple things change. When you run your test, your signal levels will always change also. So look at your signal levels right now. If I start running my test, I don't know what it's set for, but look at my signal levels compared to what they were earlier. Remember neg 130 dB, and almost all the signal levels were above it, but now they're all below it. Why is that? Anybody know why that is? Distance. When you're on Earth, you're 20,000 miles away from those satellites. That's going through the troposphere, the ionosphere, interference, and all kinds of stuff. So it's almost in the noise floor. You're up in space right now. You're much, much, much closer to those satellites. So obviously the signal strength is going to be completely different. So we modify those signals for where you are. And of course, with all of them, you can change things as before to whatever you need to. I can go to all sliders, change it if I want to for all the satellites. But keep that in mind that they will look quite a bit different for very obvious reasons. And two, I said this to you earlier, there is no horizon. Remember that dotted line that you saw earlier? The horizon is pretty much broad, sorry. The horizon is pretty much broad because you're up in space now. You can see probably half to three quarters around the Earth. When you're in the Earth, you can only see up because the horizon blocks it. So you will see a lot more satellites, and space applications almost always will work the GPU harder because you do increase the satellite count also. So hopefully what I'm trying to get you guys to see here is you've seen a fixed location, just a simple circle, driving a car. You've actually seen space. We could do drones. We could actually go out in the ocean and do a boat. There's a lot of things you can do with this. But every time you do it, I want you to ask yourself about the application. What am I testing? It's not enough to just simulate that scenario, but what am I testing? Because I'll send you guys an app note after this that talks about a lot of different tests. And there's a bunch of tests. There's position accuracy. Very, very important if you're doing an autonomous car. There's navigation. There's time to first fix. There's timing quality if you're doing like a bank or a clock. So every application is different, and this is why I love GNSS. I used to work on Ethernet systems. I used to work on fiber optic systems and computer networks. That was fun, but it was boring. Every time I go out to a different customer, I may visit SpaceX one week. The next week, I'm visiting someone who's on a research project on a medical device. And think about a medical device. I was working on one a couple weeks ago that was tracking a person who gets Alzheimer's. So that's when your mind starts to go. And they wanted something in a watch or in a shoe, and there's many of these. So when someone leave the house, they did two things. They had a geofence set up with Bluetooth in the house, or Wi-Fi. They had a geofence set up. So the minute the person left over the network, it alerted the geofence, but then it started tracking that person as they left the house or that location through GPS. So each one of those has a different parameter. So what's very cool for me is GNSS is never generic. A train, a plane, a car, everything is different, and the expectations are different, and the quality expectations are different. You know the easiest thing to test? Because humans think about stuff. Think about an autonomous vehicle that followed Google Maps. And think about every time you looked at Google Maps and you're like, what? No, that's a river. I don't drive in the river. So you are the intelligence. An autonomous car does not have the human brain, so they have to build more intelligence. That's why they add LiDAR, so they have seeing things there. They add radar, they add IMUs, they have sensors. All of these things work together. And part of the testing anymore is not just GNSS, it's making sure GNSS and these other technologies work together. So that's why we give you all the plug-in capabilities also. So does that make sense? Any questions or comments or anything to add to that? I'm trying to put a lot of practical stuff on this versus just the software. Okay. Any questions online? Let me check real quick. Okay, so somebody online said they're all good, so I think we'll keep going. No questions. Good. All right. So this is getting easier for you guys. You're getting the hang of this pretty quick, I think, or at least you're fooling me that you are. Okay, so last things is to be able to put in interference. This is when we have fun. I've shown you how to work on things and make them work, and now I'll show you how to break them. Do not use this in public. All right? So we're going to start talking a little bit about jamming, spoofing, and interference. All right, so the Skydel simulation engine will do a bunch of stuff, as you guys can see on the screen. So interference, all types of interference that I'm going to show you in just a second. Jamming. Jamming and interference are almost the same. It's how you use it. So for example, my son flies into Wilmington Airport in North Carolina all the time. And Wilmington stopped putting jets into that airport for 2 weeks because the airplane's navigation data was being affected. They found 1 mile away from the airport at a utility site, a power company, had an RF radio with a bad connector that was leaking interference, and it was affecting the GNSS signal for the airport. So much that they stopped flying jets. That's basic interference. Normally, one spot. Normally, something that's pretty steady. Normally, if it's something leaking or a problem, and it happens sometimes even if somebody shoots at a cable or something at a cell site sometimes. Remember, 20,000 kilometers from the satellite to the Earth. A signal that is neg 130 dB, very low power. So it doesn't take much to cause interference in this, okay? And there's a lot more interference than you think. The question is, what is the power and how close is the interference? Jamming is almost identical, but almost always on purpose. And you guys know the stories of all the things with jamming. And I'll give you a couple of examples of jamming that were not on purpose. Let's give you a couple of good examples. Everybody, the Audi's a good one too. That's interference. Everybody knows about Uber. I love Uber. Taxi cab drivers hate Uber. So sometimes at airports, taxi cab drivers will put a jammer in their cigarette lighter. They're not expensive. I know they're illegal, but go online. You can order one from China for $90. They're easy to get. You might get arrested if you get caught, but how is it going to be able to catch you? But what these guys do is they put it in their taxi and you come out and you want to Uber. And you go on your app for Uber and they're jamming your GPS position. You try to get your Uber, you're jammed, they can't find you. The taxi cab driver's sitting there waiting. What are you going to do? You can't get Uber, you'll take the taxi. Happens all the time. It's almost normally intentional. And two, it's almost always a much higher power. Some of these jammers that you can order from different places all over the world, some of them are like a whole watt of power, very high power sometimes. So it's not just jamming the airport. What they don't know is it's jamming the airplanes. It's jamming the police. It's jamming everybody within a couple miles of the airport. And it happens every day, all the time. Two, and a very funny one, is there was a UPS or FedEx driver, and this gentleman, he had a girlfriend, and he went and visited her every day at lunch. But he didn't want his boss to know, so he put a jammer in there. A third example, which is really funny, teenagers know this. Does anybody have teenage kids? We tracked our kids as teenagers because I was a really bad kid. So I know kids could be bad. But kids learned, they order these jammers, and they go out on Friday night and they party, but they plug a jammer into the car. And they don't know it. Mommy and daddy can't find them, but no one in 5-mile radius can find their way because they jammed everything. Jammers are higher power and intentional most of the time. And of course, you know all the bad things that people do with them also, especially here in Mexico with the trucks and stuff. So you're going to have the same settings for jamming and interference. It's just how you use it. The same signals, the same type of signals can be sent. So we don't have a specified jamming setup. We give you an advanced jamming setup, but we don't give you a special one because it's how you use it. And remember, I can put interference or jammers in one location. I can put an interference and a jammer in a car like you just did. It's crazy, but I could put an interferer and a jammer in Skydel in space. I don't know why, but you could. If you wanted to jam a satellite or something like that, but that would be a lot of money. Just Elon Musk might do it, I don't know. But you get the idea. And then spoofing is one step further. It's not just causing a problem, it's giving it a fake and realistic signal. I think you guys have all seen examples of that, especially on ships. There's been several situations where pirates will spoof a ship and try to run it into land and wreck the ship, steal the cargo, things like that. So there's a lot of examples over this. I will tell you, we will not get in detail on spoofing today because that's the advanced course, because it is not easy. It is not easy at all. Skydel makes it easier, but the technology and the concept is not easy. And two, a lot of receivers are getting better. So a lot of organizations and companies like Trimble are putting out good receivers. But the real problem is the people that are getting, like the trucks that happen in Mexico that get stuff stolen, they have really old and really cheap receivers. That's why they're getting jammed. So that gives you some idea about this, but let me explain this a little bit because we can create any type of signal, and everything you just did in GNSS, you can do with interference. So think about the circle, think about the static, think about the driving route, all of those, the same thing, okay? All right, so I'm gonna go to Skydel, and I'd like you to follow me in Skydel if you don't mind the first time, and then you can play around with it. All right, in fact, I'm gonna close Skydel myself because we have a bunch of space stuff in there. And I don't remember how I set it up, so by the way, this happens in training a lot. You might wanna close it and open it up new. We're changing a lot of things. Okay, I'm going to set up a scenario from the beginning. And I'm going to do mine in non-RT mode. So I'm not going to worry about the start time and all that stuff. I'm just going to keep it basic. So I'm going to add 3 radios, or 3 outputs. Output 1, I'm going to make it GPS L1 and maybe some Galileo. Pretty easy. Output 2, I'm going to do some L2 in here, because almost always in jamming and interference, people only normally detect one frequency. So the nice thing is if you have a dual frequency receiver, if they jam L1, L2 still works. So we're going to do some, let's just do GPS L2. So very simple setup. I haven't made any changes or motions or anything yet. Okay? And just because I want to keep this straight for us, I'm going to make this L1. So I'm going to name the cards. Remember, I can name each card. I'm going to name this L2. Yeah. And I'm going to name this interference. Okay. So this is what you haven't set up yet. So go into your card for interference, which I'm using for my 3rd card. You're not doing upper band, you're not doing lower band, you're doing interference, jamming, and spoofing. So you'll choose the bottom setting. Okay? Remember, you have a choice on how you set this up. So you can go in here if you want and define a frequency just by typing it in. And you can change the actual center frequency itself. You can change the sampling rate. And remember, if I have a multi-GPU system, I could have one GPU dedicated to jamming and interference. But I'm going to cheat because I'm like that. And I'm only going to cause jamming in the L1 band. Everybody with me so far? Okay, good. All right. Now, that only defines the card or the output for interference. I have not defined anything specific yet. So you'll notice down here, go down your menu tab to where it says interference. Go into interference and click on this, and it brings up a whole different menu. Now, Grace tried to explain this when she was on the WebEx, but sometimes the French dialect's hard for me to understand. But you have 2 types. It's really easy, simplified and dynamic. If I want something very simple, no motion, no movement, just sit and interfere, then I go simple. If I want to make it on a car or move around, I go dynamic. So we're going to actually just do, actually let's go with dynamic since you guys are doing really well. So click on Add Dynamic. Since I have the ability to add many different interferers, you give it a name. So they call it transmitter 1, but you can name it anything you want. And if you added 4, it could be 1, 2, 3, and 4. This is just what you name it. So I'm going to call it transmitter 1. It is enabled, which means when I turn it on, it'll start generating. And then you can change the power here, or you'll see you can change it again in a minute. So you'll notice when I did that, no new windows came up, but look what I have right here now. Since you just added a new interferer and you called it transmitter 1, now you can configure transmitter 1. Under transmitter 1, you have a couple of things, and let's go through these in order. General, you can name it whatever you want. You can enable it or disable it at any time. You can change the reference power, so if I wanted to actually put a little bit of different change signal in here, I could. I'm just going to leave it at neg 130 right now. Remember, I'm running in non-RT mode on my computer. So remember, this is going to show up in a spectrum, so I set the color that I want to see. So if you actually add 4 interferers, I recommend you change the color for each one. So you know transmitter 1 is green, transmitter 2 is red, because you can add lots of transmitters if you want. And then you can actually go in and change a bunch of loss and things like that I'm not going to right now. But I'm still not transmitting anything. So I go to signal. And at this point, I add the type of modulation that I want to put out. So whether it's a chirp signal or a pulse signal or a BPSK or AWGN, or if you have your own IQ file, maybe you save some interference out one day on the road, or you pulled a signal from an actual receiver, you can load any noise in here you want if you have the IQ file for it. You don't have to use ours. All right? But right now, I'm going to add a bit of chirp, which is what Grace was adding. You can change the dB levels if you want. It's up to you. But I'm going to make this a multi-signal interferer. So I added chirp. I can add something else on top of that. I can put some pulse on top of that. I can add in some BPSK. And you guys can read up on all of these if you don't know what all these are. But I have that capability to actually have now an interferer with 3 different types of signals on it or more. So it's whatever I want to create in the system itself. Okay? I'm not going to do it yet, but this menu should look familiar. If I go on trajectory, some of these things should look familiar. Fixed, circle, or I could pull in a track. So Grace had hers running in a circle around the Eiffel Tower as far as an interferer. I'm not going to put a trajectory. Actually, I'll just make it fixed for right now. And this menu should look familiar again. So you put it wherever you want. I'm going to put it in the middle of Washington, D.C., and I am going to jam the living hell out of Joe Biden. I'm sorry. Did that just happen? You see my politics came in for a minute. It's near the end of the day. I got to have a little bit of fun with you. So we're going to go right to the White House. I'm probably going to go to jail pretty soon. Let's not do the White House. Let's do the Washington Monument. Where's that at? Yeah. Let's do the ellipse right there. We're going to put an interferer right in the middle of Washington, D.C., right at the ellipse, which is the, I think, the pole. The crosshairs, hit OK. All right, you can change the antenna patterns on these if you want, but I'm just going to leave it as the default. And you notice, hopefully it should start getting redundant a little bit. We changed antenna patterns before. You see a lot of the same menus, but this is for an interferer. Okay, so I'm running a test right now. I just hit start. And what you see in my spectrum right now is you see my RF card 1, which was L1. You saw my RF card 2, and you have no interference, but I should be able to go over here and start enabling some of these. Why are you not sending out noise? You should be able to start your test and enable the interference, but I did something wrong. What I did wrong. I think the power settings, I need to change them probably. Yeah, I should be seeing it in my interference spectrum right now, but I had done something wrong. This works really easy most of the time. So it's near the end of the day. Can you tell I'm getting tired? There we go. So I'm starting to add in different signals right now. And you're starting to see my interference change based on me adding them. So let me add one more. So right now I have 3 signals combined. So I can go in here and toggle each one of those. So if I just want to see a chirp signal, that's only a chirp signal being modulated right now. Or if I want to turn chirp off and I want to turn BPSK on. So you have the ability to transmit all those different signals on demand while you're in that signal. I honestly don't know why it didn't work a couple minutes ago, but I'll figure it out in a little while. I just went back to simplified to make it work. I can turn on the BOC if I want, and you can see the trace of each of those noise patterns, or I want to have some fun, I can really take those up, and I could go back to the power settings and crank up the power on those also, and actually really blast that speed. If yours isn't working, go to simplified. You should be able to generate these. So there's no questions on mine. Okay. So the exercise we're going to do, and this is a pretty hard one, okay? I want to see if you guys can do this, and I've got to go through it too also because I haven't done it since a couple weeks ago. Is you're going to set up a test for last Tuesday at 3 p.m. You're going to set up 3 outputs just like I was. One's going to be GPS and Galileo E1. Output 2 is going to GPS and L5. You're going to put on 2 different types of interference on output 3. So that's the 3rd radio, like I just did. You're going to put 2 types of interference on there. But I want you to build a route for a car. That's your vehicle for GPS. And then I want you to insert a fixed location in the middle. I'm going to show you what this will look like when you're done by cheating. I'm going to pull up a file that I did last week. I actually have a drive at my house. I'll go to the map for you. So basically what you're seeing right now is you have a transmitter like Grace was showing you. The transmitter is my interference. And it's going in a giant circle in a town right near me called Denver, North Carolina. And what I have is a car driving through that interference. So what you would normally do in something like this is maybe you program a route where a car is driving 20 miles. But 5 miles into the drive, they encounter interference. What happens to that car if it's autonomous? Does it listen? Does the interference affect it? Does it drive it off the road or something like that? But basically what I want you to do, and you can play with how on this, you don't even have to do the time and stuff like that. But I want you to play around and try to program a route near you, somewhere you know that's maybe 5 or 10 miles long, with the car for GPS, and then inject an interference signal. That interference will be dynamic, going in a circle, and you'll probably have to move the map and put the crosshairs where you want it to be in that route to actually see that. So this is a little bit of a hard scenario. This is almost advanced, but I want to see if you guys can play around and try it so you get an idea how to do it. If you need general information to follow, here's generally what you're going to do, but I don't care about this time right now. Set it for whatever time you want or don't set it at all. But set up an output, build a route you know, maybe something you drive every day. And then in that route, try to put an interference. And I have fixed here, which is fine. It doesn't have to move in a circle. If you want to put fixed, which means it never moves, and have your car drive by it like it was a bad leak, try that. But play around with that for a couple minutes and see if you can get it set up. Because that's truly the real test to see if everything we talked about today works for you. Does that make sense? You're good to go? I'll float around and help you guys. If you guys online have any questions, let me know. And I don't care what kind of interference you put in. I don't care what signal levels. You guys can kind of play for a couple minutes. I'm a little bit over schedule, aren't I? Wasn't it supposed to go till 4? You guys do this, and then we'll call it a day after that. Because this is a harder one. Is everybody okay on time for about another 10 or 15 minutes? Okay. Yeah, I apologize. I just looked at the clock and noticed that I went a little long. Simplify first. So sometimes simplifies. So you can simplify if you want to try it. I would go back. Working out. I don't. Whenever it doesn't work, I just stop it. So I think it's the dynamics. Like, purpose. Healing is almost always the best. So, for example, I have a project I want to do and I want to beg. I want to go test the truck suit. I can stop all the spray problems because I can tell you that every problem is an old underground sheet.
So you take the jamming test and go to every truck and test the truck. It didn't work. In my opinion, it shouldn't be running hard. You know what I mean? So it's to make sure that the receiver, if always try to jam, if always you don't want to jam, then we try every ability to attack it, just like a network, try to attack it, see how resilient that test is. Exactly. Like black, yes, exactly. Exactly. So this is one of the contests I want to have with the university students. I want to have a GPS attempt time, which someone builds a receiver and someone else tries to attack it. That would be a fun project for you. But the goal is you don't want to jam, you want to try to fight. And now the military is putting in a lot of systems now, surface systems, the way trying to adapt them antennas. There's many technologies coming out now that make it so it's not jammable. So for example, what's called null steering is in the military, if I get jamming in this direction, and I have a surf antenna that shuts in all the other directions. So now you get GPS from all the other directions. So it's an adaptable, smart antenna. If you see jamming and the antenna recognizes it, it goes and you can put a big force test. So that's really the military does a lot. It's a very, very fast. They have antennas on planes that are more expensive than all the money you and I make. Did I answer your question? Good. No, that's now. You may down here. We'll go back to general for a second. No, that's the alarm. It says the trajectory. We may put it down. Another one away. Did you start? So, go to I don't know if I am in the same. Yeah. I don't signal. Watch the thing. Broken. You got the idea. Not this very Are you doing dynamic? Yeah. It's not something I'm using. So put a transmitter one. It's as simple. Okay. Something's freezing all the time. You're not talking about I would go like this. Flash your chart. That's what I did that. Así. Simplifies working. Right, but what you don't remember, so even though you're running a scenario to change it, you don't know what it's actually modulating. That's when you see the big cheat. Yeah, you always want to spectrum in NRT because it's in real time, but not in because there is no receiver. This is your perfect GPS signal that you're transmitting. That's your interference that you translate. You'll see the difference when you look up a receiver. And remember the live demonstration of Grace earlier? Remember, you had two rows. You had transmitter, simulator, and you had receiver. And the receiver was launched. Makes sense. All right, guys, I've actually gotten really over the time. So let's finish up so you guys can get out of here for the day.
So a couple things. Grab a seat real quick. You guys online, hopefully you're okay. A couple things that I noticed, there might be a new bug that I just found where that dynamic isn't always injecting the interference. But I'll send you out these slides, and I want you to go through these slides and these exercises. But if you'll give me permission, I want to kind of finish up a couple of quick topics so we can get you out of here in less than 5 minutes since I'm way over schedule, if that's okay. And by the way, if you guys have questions, I don't mind helping you out in the future, and that's what the forum's for too. Okay, finishing up on a couple of things. I want you to go in the forum when you leave here. There's some videos and there's some really cool spoofing videos. So if you guys want to learn more and kind of see some neat things, go in the forum, go look at some of those spoofing videos, because you're going to see literally a jammer, a spoofer, and two interferers in the same time. Actually in San Francisco, as it goes across the bridge, they jam it and then redirect it. So there's some cool videos there. Connecting a receiver, there's a section on this. You saw Grace do this. It's easy. You go to receiver, you hit connect, and it's a serial input for all of that. Receiver information, Grace showed you that earlier today. And then automation, there was one lab exercise I didn't have you do that is really, really cool. I want to explain it to you. In automation, there's a command called run. In fact, I'll show it to you really, really quickly. We're not going to do the lab, but I want you to see it. So as I'm running this test, if I want to, I want you guys all look at the screen for a minute. I can go to automate. Everybody looking at the screen? This is really neat. Clear out your automation log. All right, so I stop it. I clear out my log. And I start my test fresh. I can actually go over here and change some settings. You notice that the automation pane is grabbing and saving those settings that I'm changing. I'm going to reset them. I'm going to change them all together. Okay, I'm going to stop the test. In automation, what's a really neat feature, if you guys want to see it, what one of the exercises does, is I can run all of these myself. So watch the screen for me. Watch the screen here and watch the screen there. If I hit run, look at the top, it's going to start running all of those changes that I did in the test, and you'll actually start to see the power change. It's all magic. I'm not doing it myself. It's just a way of automating or running a test in series. So that's the last lab that we didn't do because of time, but it's just neat to see that right now this test is running itself, and I'm not doing anything just because I ran that run test in Automate. So you can play around with automation. It's really, really neat to do, and it will save you a lot of time if you have to do a lot of testing. Okay? All right, that's your automation exercise. Next steps beyond the training. I beg you, use this software. It's free. It's a donation. It's $300,000. Use it. 2, give me a second. If you don't use it, you're going to forget how to use it very, very quickly because none of us are young anymore. Well, maybe a couple of you are young anymore. Go ahead, Yvonne.
Let me switch this to Spanish. Really
Okay, perfect. Yes.
Hola, chicos. Antes que nada, les agradezco muchísimo la atención. Quisiera ser nada más ser muy enfático.
Come up here where they can hear you too.
Quisiera ser muy enfático en que esta alianza que estamos firmando y estableciendo con la Agencia Espacial Mexicana les otorga a ustedes el derecho y uso de este software de manera gratuita. ¿Okay? Por ahí alguno de ustedes me hizo el comentario de, bueno, ¿y esto qué? Después del periodo de tiempo de prueba, ¿qué pasa? ¿Tenemos que comprarlo? La respuesta concreta es no. Entonces, por favor, como dice Roberto, les rogamos, les suplicamos que lo usen, que le saquen provecho, beneficio. Que lo único que pedimos a cambio es que hagan uso del software, que nos informen qué es lo que están haciendo con él y que cada vez que saquen alguna publicación, algún documento relacionado a algún proyecto en específico, hagan referencia al uso de Orolia, ¿no? Es lo único. ¿Hay alguna pregunta al respecto? ¿No?
Sí. Si necesitamos alguna licencia para estudiantes.
Las licencias para los estudiantes nada más se comunican con nosotros, nos dicen cuántos estudiantes, nombre, correo, matrícula, y inmediatamente se les otorga. ¿Con usted? Conmigo o con Roberto, cualquiera de los dos. En términos de número de licencias, no hay un límite, siempre y cuando ustedes comprueben que los estudiantes que están, que van a solicitar el software están corriendo un curso durante el año calendario que corresponde, ¿no?
Y, por ejemplo, si pues ya me dieron esta licencia, pero tengo otra máquina donde sí tengo la GPU, pues puedo participar también otra licencia.
Tendría que platicamos caso por caso, pero sí, en principio no habría ningún problema. Acuérdense, las licencias están atadas a un periodo de tiempo y tendrían que renovarla cada tiempo, siempre y cuando haya una utilización de parte de ustedes, algo que nos indique que realmente están sacando provecho de, ¿correcto? ¿Sí? Sorry, Robert.
No problem. And then one more request. We always like to get feedback because training is never perfect. So, by the way, if you guys are putting together a plan for your university, schedule time with me, Avaya and I, one-on-one. We'll actually talk to you. But the very last thing is, at the very last slide, maybe, is a quick survey. In any training, we just like to get a little feedback. It's like 6 questions. So go to that link or scan that code and just give me some really quick feedback. It's really, really simple in Skydel, the software, just so I have it. But from a personal perspective, thank you. I really enjoyed working with you guys. I must admit I was nervous because there's a lot of people in a lot of different places and the language barrier. And when I see many, many people with the titles of doctors and professors, it gets me a little anxious. So thank you. I really enjoyed the training. And I hope I get to work with all of you guys much more in the future too. So good. For you guys online, thank you. You're welcome to log off. But if you get a minute, please, please, please go take that survey. At the end, and again, it's in the slides themselves, and please let me know how I can help you out in the future. No problem. No problem. Thank you. I'm going to go ahead and close out the webinar now. Huh? Oh, okay. What's that? Okay. Yeah, on the webinar? Yeah, there. I just told them all. Goodbye, everybody. I'm going to close the webinar down. Send me any questions. Please log into the forum and take the survey. Okay. Huh? Okay.
Bueno, después del aplauso que le acaban de dar a Robert.
Okay, perfect.
Me da mucho gusto de parte de la Agencia Espacial Mexicana la oportunidad de esta sesión y tenemos unas constancias que entregar a las personas que estuvieron aquí, también los que están allá en sus sitios remotos van a recibir su constancia, al maestro Antonio Jesús Serrano, la Agencia Espacial Mexicana por haber asistido a capacitación sobre la plataforma Skydel en el marco de la alianza ANM Orolia para promover el desarrollo de sistemas GNSS en México y Latinoamérica, con una duración de 7 horas, Ciudad de México, martes 23 de noviembre de 2021. Firman el maestro Carlos Duarte Muñoz y el instructor Robert Burke. Gracias. Al ingeniero José Francisco Romero Achinar, a la ingeniera María Fernanda Macías Valencia, que la vimos ahí muy... Thank you very much. maestro Serafín Chávez Barranco, el doctor Rabindranath Vicente Vázquez del Instituto Politécnico Nacional, que está con nosotros. Al maestro Miguel Ángel Sánchez Caraz, del IPN.
Muchas gracias. Gracias, Miguel.
Y al doctor Adán Salazar Garibay, de la Agencia Espacial Mexicana. A todos ustedes, muchas gracias por haber participado en este curso. Vi que estuvieron muy atentos y sacando los ejercicios. Y bueno, insisto en lo que comenta nuestro instructor. Usen el software, saquenle provecho. Y viene el segundo curso avanzado. Sí, y a los que están allá en sus instalaciones también se les va a mandar por correo electrónico su diploma. Tiene el segundo curso y no el del next course is going to.
Don't know, but there is a webinar on the 14th with a bunch of new information. For the next course, probably is next year. Yeah, 14 December, I think, is the webinar that you guys all get invited to. That's for the future of the program. So you're all welcome. And then we'll probably do more training next year for a full certification, but that'll probably be at the faculty.
Bien, y bien la certificación, entonces, los que estén muy aplicados, la certificación está también en proceso. Muchas gracias de parte de la Agencia Mexicana, del doctor Salvador Landeros, del maestro Carlos Duarte, su servidor Mario Arreola, les damos las gracias. Hasta la próxima.
Gracias. Gracias.